pool fund work plan is coming to an end in December next year, we don't want to lose the momentum that we've built, and we need to start thinking about how we want to support DPS and get the most out of it moving forward, even past December next year. So a lot of good discussion came from that. And then we got to get into some of the more fun stuff. So I thought George did a really good job of putting in perspective where DPS fits in even the bigger picture, connecting of the dots and where the paving industry is moving with more continuous coverage technologies as compared to the spot checking stuff that we have to currently rely on as engineers, and kind of how this technology fits and supplements and helps build upon some of the already other technologies that have been implemented. The contractors, as always, did a wonderful job. We had Forrest was pretty heavy on the examples of comparison of DPS with other technologies, and I thought really highlighted how we have a lot of stuff out there that's giving us good information about our process, and it really has the potential with our DPS to kind of complete that picture and say, okay, this is the result. We're getting good density here. We're not getting good density there. What's different with our process? And he showed examples using thermal, using intelligent compaction, and from a contractor's perspective, seeing Forest and Granite really taking advantage of the technology that way was great to see. And Forrest also hit upon a few things that Matt Oman touched on too, about kind of room for improvement and things about the technology that would make it more attractive from a contractor's perspective. And I think we'll talk more about that at the end of the day today. And then of course, Bryce showed a lot of great contractor perspective. You know, we're in this pool fund pretty heavy on the acceptance piece, but I think we're moving a little bit more towards trying to see it from the contractor perspective too, of how can this information be used even before we convert it to density, just to tell us this is good or bad locations in the pavement. And he showed a lot of good examples of that, and also teased a DPS on a roller for potential future, and kind of, I don't know, get the group thinking about deployment and what that might look like with the technology in the future. So that was really nice to see. Good open discussion. I heard multiple people talking about how great it was having Brian and Todd Mansell here from Caterpillar, basically sharing examples from industry and other technologies and how DPS fits in the big picture from an industry. So it's great to hear from them. And then, of course, the supporting discussion. And then Mike and I shared some examples, again, comparing both just how you can use the device as is on site with some simpler tools, but then also some of the more complicated stuff, looking at comparisons with other intelligent compaction technologies. And then ended the day with some kind of what's being covered with the current pool fund, what we might need to support moving forward once the pool fund is over. And then Brian kind of put everything in perspective with his list of items that we had discussed. So with that, I think I would like to just really quickly name organization to help Katie out here around the room. And then if you really want to, you could share anything you want. Could be something you liked about yesterday, or just try to keep it moving, whatever you choose. So I'm Kyle Hoig, MnDOT research engineer.
Mercedes Kuznia, MnDOT.
Jeff Brunner, MnDOT.
Chung Tao Dai, MnDOT.
Fabricio Oliva, formerly ANCAT, for this project.
Right now.
Cooper, for
Ryan Bose, Maine DOT. Roger Roberts, GSSN. John Warner, Missouri DOT.
Amanda Gilliland, the Transit Group.
Can, University of Nevada.
Brendan Rock, New York DOT. Brian Deaconberg, Virginia DOT.
Urban Gas Consultant.
Rich Hamilton, Advanced Testing Company, New York.
Tyler Carlson, Washington State DOT.
We do. Well, it's like once I start a project, gotta get obsessed.
Gordon DOT.
Jacob Walker, Georgia DOT. Jeffrey Delisa, Georgia DOT.
Ken Talbot with Utah DOT.
Corley Beckman, Utah DOT.
Joe Sias, University of New Hampshire.
John Stewart, North Dakota.
Bryce Warren Consulting.
George Chan, Transit Group.
Rob Hinman, Federal Highway, Ohio Division.
Katie, do you want them to introduce themselves online too?
This is Brian Hurt with CTC and Associates.
Good morning. This is Adam Marlin with the Province of Nova Scotia Public Works Department.
Larry Riggleman, Actual Materials, Maryland DOT.
Lisa McDaniel with the FHWA Iowa Division.
Forrest Tierholzer with Granite Construction.
Hoda Azaidi with Federal Highway.
Monica Jurado, FHWA.
Ram Kumar, Highway Technology Partners.
Greg Londefeld, Ohio DOT.
Dave Sist, GSSI.
Jacopo Sala from Contour, formerly 3D Radar.
Anybody else online? Okay. Why don't we start with Ulrich from Maine DOT, mainly because he's the only one whose presentation I have on my computer right now. And then the other states, if you want to bring me your presentation on a USB, I'll get that loaded while he's talking here.
Okay.
I put it on your computer, ready to go. What's that? Oh, haha, sneaky. Classic North Dakota. He sneakily loaded it on my computer when I did. Yeah, sorry then.
Okay, so it's my pleasure to present to you what we have accomplished this year so far. I would like to take this opportunity to thank Ryan and his team for their continuous support. Ryan is on this picture on the whites, pushing the cards. We collected this year just 3 projects, couple of thousand feet for each. It's not like the way we don't have the privilege to select the projects. The project are almost imposed to us because based on our availability, the availability of the entity crew, and between breakdown, the rain and all the other stuff. We don't have so much to do, so we do what we can, what is available and what we can collect. As I was saying, we collected 3 projects. One project in Portland, South Portland, and the Interstate 295. We started that project last year. We collected that project last year, but this year they changed the mix because they were having some issue with the mix. So we collected that project this year, just 1,800 feet on the passing lane and 1,500 in the zip lane. Last year, we collected the projects in the travel lane, roughly 2,800 feet section. We collected also hammers on Route 9, which is a polymer modified mixer, and it is a day work. Collected, finally, the Sanford Route 4 on the left-hand lane. That project is a hot print cycle with 1 inch surface on top. So I will go through each of those projects including what we gather as data and what we found. This is a project we collected in Portland. We collected this passing lane during the night of June 6 to 7, and we can see here that we those spike are the fingerprint joints of the bridge. So we start collecting the project somewhere down here, and we went through on the bridge, and you can see just by looking at data that on the bridge the electric are lower, and we have the spike here because of the middle of the joints. Try to represent the data. And usually when we collect the data, we have on the 3 feet lane and on the 7 feet lane, which are closer to the weak part, we used to have higher dielectric. And we used to see low dielectric on the edge, close to the centerline joint and to the edge, the shoulder edge. But for this project, we found that even the 3 feet lane where we collect the data, the dielectric were lower. And okay, one thing I need to clarify here is that when we were plotting the data, we include first the bridge section to represent the entire data, and then we exclude the bridge section to represent the entire data. And clearly we exclude the joint, the fingerprint joint, because it will throw out the entire data. So we just represent data including the bridge and the data excluding the bridge. And when we compare both, we found that the data without the bridge are shifted to the right by 0.02 roughly, and the standard deviation is lower, which means that, and that makes sense because we have lower dielectric on the bridge. And this is a representation of the map we collected, and you can see the red line is where we have the fingerprints joints, the finger joints, and you can see, as I was saying, 1 foot and 3 foot, we have lower dielectric, and between the joints, we have also lower dielectric. By looking at that data, you can see that just after the bridge, roughly 100 foot after the bridge, we still have lower dielectric. And we have also lower dielectric somewhere in some parts, station 91 plus 00. all this this is a zoom in of the data. You can see clearly that between on the bridge you have lowered the electric, and as I was saying, 100 feet after the last joint, we still have lowered the electric. We did collect also on the bridge, on that project, the smoothness, and you can see that I represent the smoothness in the section where we collected the electric, and you can see that almost on this section, the smoothness is above the upper limits, which means that you have better smoothness data. So the recap for this net of data collection is that, as I was saying, when we include the bridge section, the distribution curve is switched by 0.2, and the standard deviation is lower, which means that we have roughly tighter data. And as I said before, the knockdown roller seems not to have changed the mode. Okay, the knockdown roller, when you look at the data, we found that the knockdown roller didn't change the mode when even up some 100 feet after getting off the bridge. That's why we still have lowered the electric after they get off the bridge. And I was talking about smoothness. The average smoothness for the person within limit of that for that smoothness data was 41, and the contractor had really bad sensitivity for that project. And we also collect some thermal profile for that project, and we found that we have roughly a speeder stop every 300 feet and some lasting up to 37 minutes. We didn't have the raw data for the thermal profile, so we didn't really analyze the data to compare, but it is something we can do before. This is something we are supposed to do. So this is the second night of data collection for that project, and this looks even better, but still we have, as I was saying, a better, higher dielectric compared to the first night, but the specificity here is that the center of the lane is more compacted than the other side, which is not what we were supposed to be expecting. So you can see roughly we have lower dielectric on the edge and more compacted in the center of the lane. So, this is data collected last year for the same project, but with a different mix. As you can see, when we were comparing the electric, we have a higher dielectric last year than compared to this year. And yes, you can see higher dielectric overall. And the only way, we have only lower dielectric on the 1 foot away from the center line, which was expected, and because that was unconfined joints. I mean, it's the center line. That's what something we should expect anyway. And we also found that we always where we have feather stop, the dielectrics tend to decrease. So that is what I'm showing with the red dots there. And this is a zoom in for the 25-minute stop. You can see we have, it's not clear, but you can see we have lowered the electric, and because of the accuracy of the thermal profile data, you can see that the shifts where we have this feather stop compared to the DPS data, but it's basically the same spots. So recap for that net compared to 2021, we found that we have higher dielectric on night 2 compared to night 1, roughly by 0.2, but still less than what we got in 2021. We have less variability in the data in 2022. Even though we have lower dielectric, we have less variability in the data, and we found that the compaction pattern over the width of the lane is not consistent. We'll be talking about the second project in Amherst on Route 9. For this project, we collect just 2,000 feet of data, and we found that we have some strange thing going on the data. I started looking at the data. I found that there was some issue. I have to call the person who collect the data, and I said, "What is going on? Did you have any problem somewhere?" He said, "Yes, we have some outlier somewhere, and that is due to a catch basin on the road that we collected without knowing." So when I include that, I include the outlier, you can see that the 21 feet, I think it's around the 21 feet, the electric on that lane that we have the catch basin, that is where we have the issue. But you can see clearly that the data here, the electric is right about 499, while when you, I think that we go back here, it's better to, yes, 23, not 21. So when you look at the 23-feet section, you can see there will be a shift when I exclude the outlier data because of the catch basin. It was right about here, about 5, the electric, but when I exclude the data, the outlier is increased by 5.1 or 1.2. And that is exactly where we have the outlier somewhere here. Okay, so I was talking about the outlier data was measured around the catch basin at the offset from the center line joint as the station 188.00, which is somewhere about it's here instead. I need to zoom in to make sure to see clearly, but there was some issue around 188.00, somewhere back here, I guess. But contrary to the previous project, only the edge are showing lower than electric. If you remember, for the Portland projects, we had lowered the electric even on the 3 feet right about the edge, close to the edge. But here you can see that we have only lowered the electric when we are close to the edge. And this edge is unconfined, close to the main line, which is here. It was unconfined, so we were expecting to have lowered the electric anyway. But here it was not unconfined because it was paved with the shoulder, so we were not expecting lower the electric. However, we did see that there was nearly the electric were nearly close, so which means that the way the contractor are compacting the mats, when they get close to the edge, they don't have a consistent compaction pattern. And the last project we collected is the sensors and the impact in cycle projects. When you look at these projects compared to the other, you can see that there is a more uniform compaction pattern. The dielectric are lower here, but they are more uniform. And that's pushed me to compare this to the previous project we did in 2018. That was also a hot implicit cycle project. And we see that, I will come back to here later, we see that the project was roughly almost perfect. So we start looking at to understand why on the hot implicit cycle projects, the compaction pattern seems to be better. And the only answer we can have for now is that since we put a 1-inch surface on top of the hot increase cycle, because of the specificity of that type of treatment, there is more uniform compaction pattern. Something we need to continue to work on. So for that project, we were able to collect, to do the swell test, to do the transverse line test. And as you can see here, everything was almost perfect. We did find that the correction factor is only 0.0, less than 0.001. So, which means that the sensors are working properly. And for that project, we did see that there are some issues at some specific location. And one thing I need to point out is for that project, the contractor was, I will say, late because there was a breakdown and the project they started collecting about noon. And they were trying to catch up with the other lane because we are a Friday. So they were going so fast that you will see later that there was clearly a problem. Even though the compaction patterns looks to be good overall over the mats, there's still a problem. But this joint is unconfined, so you can see there's lower the electric here on close to the shoulder. But when we did the transverse tests, you can see that the left side, which is the left bound that we collected that day, is way lower than the southbound that was paved a few days before. And that's something we understand because I was present on that project when we were collecting, and you can see we have even to skip those 100 feet because they were going too fast. We were not able to keep up with the base. So this is something I was comparing to because this is a coordinate display project. So, okay, so the recap for that project is that I was saying that the data was almost perfectly uniform, except for the 11, the leg close to the line close to the shoulder, and we did perform the field test and the sensor was working properly. I talked about those locations where we had some low electric, and I believe it's probably somewhat where there were some paver stop or something about that. We need still to dig into the data to see what was going on exactly at those locations. So, I was saying that yes, the electric data for Corona desktop collected in 2018 shows similar result as for Sanford, but the southbound lane that I said was, as I showed here, is 0.4 lower than the northbound, the southbound, and what we collected in Corona. So that's bringing me to the end of my, not the presentation, but we used to do every time we collect the data, we used to do the calibration, the electric airvoid calibration. And what we try to do to achieve is we put all calibration together to give a sense to when we say 4.6 dielectric to the common person on the project, what that means. So what we try to do, we try to have a conversion factor to just estimate the dielectric. So when we say 4.6, it's roughly 92%. So density. So what we want to see, a dielectric between 4.65 and 5.7 to make sure that we are achieving our density. This is not accurate at 100%, but it's something we would just want to use as to guess estimate. So the planning for this year is that we are not having a uniform compassion pattern on our projects, and that we are seeing higher dielectric just in the middle of the lane, which is not something we were seeing before. In the past year, we were seeing higher dielectric in the wind path closer to the lane, closer to the wind path. So for some reason, the contractor are not having a consistent compaction pattern. And we also found that from the same project, for the same project and for the same crew, the same, from one night to another, they're having completely different compaction pattern, which is not something we will expect. We will hope for. And we also found that on the hard inclusive cycle, we have more uniform data, and something we need to work on and find why. So what's for next year? Next year, we are hoping, this year, we didn't finish what we were expecting to do. We finally fabricated some parts from those we collected, but I wasn't able to, we did that just last week. I wasn't able to do that in this presentation, but it's something I can definitely update you on. And we were trying also to analyze the smoothness result, because the smoothness is given to us by lane. So I was trying to get it by wind paths and try to see and compare to the dielectric in that wind path, how we can explain what's happened compared with the data with the smoothness in there, and try to see if there's any link between those, as well as the thermal profile data. We had the thermal profile data. We didn't get the raw data until later, so it's something I still need to work and figure out. So our goal for next year will be to identify a project, ideally 2 projects that we will be collecting. We'll go and on the project, sit on that project for 1 week, or at least 1 week or 2 weeks, and collect all the data we can, not just 2,000 feet of data for 1 day, but 1 week or 2 weeks full of data. And ideally, we would like to do it on the project where we have also a thermal profile data planned to be collected. So that will give us a better idea, a broader picture for what we are collecting. Right now, we're just collecting 2,000 feet on one project, 2,000 on another project, and that doesn't give us a good graph of all that's going on the project. So I believe if we go on the project, we stay there for 2 weeks, we collect the data, every data we can collect, we can have a better and a broader picture of what's going on. And again, we are hoping to use the fiberglass plate to do the K test for our next projects, continue to do some core calibration, and continue to get some loads mix and to do mix calibration. That is our goal for next year. And with that, I thank you for your attention, and that's it. Thank you.
All right, thanks, Ulrich. Any questions for Ulrich while John comes up and gets his presentation loaded?
I have one. What prompted you to look at dielectric versus smoothness?
Smoothness. The first thing is because we found that the dielectric we collected this year is lower than what we collected last year. And last year we already had some issue on that project. So, and since we know we were collecting smoothness of that project, we decided to go and check the smoothness and see how it was working. So when we got the smoothness data, we found out that that was the worst we got since we have been. Ryan is here, he can talk about that. The smoothness data for that project is the worst we ever seen in this project.
Worst smoothness you've seen. So you're expecting to see agreement between the two?
Yes, that was the goal, but we still got it work. And we were having the data in by lane, so I will request you to get it by wheel parts, and then we can look clearly and compare that to the direct. Since we are collecting directly by 1 feet, 3 feet, we can look closely and see if there is any kind of relation.
Very interesting.
Okay. Thank you very much, Ulrich. So I'm not going to hijack the computer from John any longer here.
Okay, good morning. Again, my name is John Stork. I am a research and pavement design engineer is my title in the Materials and Research Division next door, North Dakota. So just a quick update on what we've been doing this year, what we got to, what we didn't get to, what we struggled with, successes, all that sort of stuff. I'm gonna stand because I don't like sitting. Sit too long.
As long as you put the microphone up to your mouth.
Okay. So if you haven't caught my presentations in the past, we've been running the density profiling system now for 3 different construction seasons. Prior to this year, we've done 7 projects across the state. I guess our goal or our objective was to sort of fan out in the state, see how different aggregate sources affected dielectrics, all that sort of stuff, see how consistent they were, how the technology functioned with different rock sources, different oils, different grades of asphalt, and then also different percentages for wrap. So prior to this year, I think we've collected about 60 miles last year for data collection. And then this year, we wanted to take a little bit of a different approach. So we wanted to focus more on collecting, kind of like Ulrich saying, we wanted to do larger spans of continuous data. So we only did 2 projects this year across 2 districts. One of them was significantly shorter than the other. The first one was up in the northeast part. That was kind of just a tack-on project. It was more of a training opportunity for some districts. We had a district engineer come out, some of the contractors, consultants, they were interested in the technology. So we used it kind of as an outreach for a promo for the technology. We didn't have the best success with that one. We had, I don't want to get too far into it, but we had 5 of our 8 districts use what we call fog seal. It's basically an emulsified asphalt that's applied. You can see it on the right picture after the mat is laid. So in certain applications, it can be very sticky. This was a polymer modified asphalt. You can see what it does to the wheels. So not only does it cause issues with the DMI, every revolution you do, you pick up a little bit of that film. Pretty soon you're walking a lot farther than it says you are. That sets up like concrete when you're done with it, and it is a miserable thing. GSSI pneumatic tires aren't the best for some of that, so I don't know if that's a ride thing to sort of smooth out your sensor sway or what, but I would urge you to maybe reconsider that design philosophy on pneumatic tires just for this. Anyway, so that was the first project. And then also you have the surface reflection. It's affected by the oil on the surface. We didn't have the best accuracy for just the way that it measures our basically when you're scanning on the road, you get different results than when you are fabricating your gyratories in the lab. That's not fog sealed. You don't have the best correlation between the two. So we're only out there a couple days. It still is a good training opportunity for district staff, all that sort of stuff, contractors. That gave us, this was early in the season, so good way to dust the old card off, I guess, for the season. Second one's mostly what we're going to be focusing on today. North Dakota 6, I don't expect you to know where that is. I don't really even expect you to know where North Dakota or Bismarck is. Bismarck in the center, along 994 corridor. That's where I'm located out of, so I wish there was some grand thing of why we selected this project. Mostly it was based on convenience. It was about 45 minutes from my office. I was able to commute back and forth every day. And it had the other intelligent compaction suite of technologies on it. Your thermal profiler, it had the IC rollers, for IGBEC, notch wedge, all the key items that we try to focus on when we deploy the DPS. It is a typical 2-lane. That's pretty standard for us. it's not necessarily a high priority roadway. If we're talking about interstate, things like that, that would be a more attractive option for deploying something like this, but this was a nice, easy collection as far as traffic control and stuff like that. A couple things we touched on yesterday. This one did span 2 counties, a couple different owners. Half of it's on the Indian reservation, half of it's not. So a little bit of different pavement preservation techniques used with different ownership of the roadway. This was a wrap job, 25% wrap, standard 58S 34, I believe. The wrap is kind of a pain. It's another variable you get. So we don't actually process them. We mill them off the road and then use them right back in the mix. So depending what you're milling off, it changes your mix. You get a little bit of variability on your dielectrics. So 60,000 tons. This was a standard mill 1-inch, place 3, I believe. We were hoping they would do it in one single 3-inch lift. For density's sake, they opted to do it in 2 1.5-inch lifts. So that's doubled my collection efforts, I guess. So we collected, basically the goal of this was to collect start to finish all 60,000 tons. We did, I got most of it. There was a couple days, rain events, other things like that. We weren't able to get all of it. It ended up being about 220 miles of walking, something like that, to collect it. So definitely got some exercise, lost a little bit of weight, wore out some boots. Would not recommend it, but hey. So this year we also procured the mix design module. We deployed that on both projects that we did this year. Ran it in QC lab. QC lab ran their production gyratories, no additional workflow, other than, you know, shooting the plugs before we dumped them. Now, overall went pretty smooth. I guess couple hiccups that came. So when you set it up in the lab, it's powered typically by a generator. They shut the generator off at night, shuts their concentrator box down, and it sort of freezes up the system. Wasn't a big deal. I would basically just stop by the lab in the morning, reboot it. They were just kind of hesitant with a software they never used before to mess up, I guess, anything. So there's a couple times where they didn't dunk it or they dunked it before they measured it. You know, we lost a couple things with that, but overall pretty successful, pretty user friendly. No real concerns on the mix design module, other than, I guess, security was one of our concerns. Better be careful with what I say here, but it wasn't the most safe project location. We had some stuff walk away from the plant site. So that was a concern. If you're going to leave one of these in the field lab, maybe take them with you on the weekend if you know that's a problem. Ended up just locking it in my spare room every weekend, bring it back out on Monday. Not a big deal. So the photo on the right, I just wanted to highlight it. It was the day before we got out there. Their pouring truck, while they were out on the road, they got clipped. Luckily, nobody got hurt, but it's just a good reminder of why we're trying to push this technology, obviously, for the, you know, reducing pouring, destructive testing, all that sort of stuff, data quality, but also for, you know, making sure stuff like this happens less frequently than it does. They were lucky, and they were very grateful that we were out there, you know, trying to reduce the amount of pouring that they're doing. So I apologize. I don't have anything really too polished. I just finished. We finished this in the beginning of October, and then I spent a couple weeks doing lab gyratories, and I just got the IC data actually while I was on my way up here on Tuesday from the contractor. So I haven't had a whole lot of chance to dig into that. That'll be a winter thing. What we did do is we ran, you know, similar to what Rich was talking, we ran calibration curves every day just to see the consistency of it, see if we need to necessarily do it once a day, if we need a mix design in every single lab we have, or if we'd be okay, you know, maybe at the mix design phase, running a couple different AC contents and sort of using a project specific one. We haven't had a whole lot of luck like Maine was doing, where you talk about a statewide calibration curve. It is highly variable to your aggregate sources and your oil. But from a project specific, we only had about a tenth to a tenth and a half of dielectric shift from, you know, the 17 days that we did. So fairly consistent. That's your curve on the left is all just, you know, put into one data set. We had an R squared of 0.97 on that. So fairly consistent on that. Those were all done after the fact. This is the laboratory gyratories compared to those, I guess, my gyratory curves that I created after the fact. We did see a little bit of a bias, a little bit of a skew to where there were higher dielectrics were yielding the same densities. So we were predicting a little bit lower densities than what we actually experienced in the field with the cores. And that's consistent when we looked into the coring results as well. So I'm still looking into that, whether that's a difference between their gyratory versus my gyratory, or if that's something, maybe we artificially age the binder by letting it cool and heating it back up after the fact. I guess I'm not real sure. I haven't dug too far into it just because of the time of when we completed this project. So, again, this is all of our cores overlaid over those calibration factors. You always have some of the flyers. That's nothing new. Overall, we had pretty good agreements. It was about plus or minus 1% typically on our predicted versus what our extracted cores read. Notch wedge were a lot better than our standard butt joints. We've had a lot of issues with just the way we core. We core right over the butt joint instead of offset, like I'm assuming a lot of you guys do. So getting that agreement is very difficult if we're not using the notch wedge. But notch wedge, we've had really good agreement with accuracies from the DPS. So. Some of the challenges, staffing. I guess this is probably not unique to us. We've lost, I guess, half of our staff in the last year, moved on to different opportunities. So a lot of this was a solo effort. If you've done any collection with this stuff, it's not really a one-person operation, but in our case, we didn't really have a choice for that. So even just loading and unloading the cart by yourself. I mean, there's days where you're loading it in the back of the Suburban and unloading it every core you get to. I mean, you're doing it 75 times in a day, and it's pretty cumbersome. Equipment wise, we had a couple sensor dropouts, mostly in cold weather application. We remedied that by basically parking this in the warehouse at night and then running 90-degree heat while we drove out in the morning. And so we did get a wide range of weather on this job, 100+ degree days, all the way down to using Evotherm at the end of the job. That's just kind of for go, I guess, in the fall. So that was a bit of a concern. And then daylight. I mean, you're the last one on the road. You're following the finish roller. If you're looking to collect until they make that end, you're going to be the last one out there. So there's safety concerns with that. There's long days, lots of hours, lots of walking. That's one of the biggest concerns. That's one of the biggest challenges of doing a full-scale project collection. So if you're looking to do that, definitely keep that in mind. Multiple people would be better. Safety, I'm not going to hit on too much because we've touched on that a lot in the last couple of days. Obviously, you're working in live traffic. These asphalt trucks, they get into the cyclic nature of running back to the plant, and you're a little guy in a big trucks world out there. So definitely be careful with that. Nobody wants to die over something like this. So, couple equipment things, as you can see there, I guess on the right. This cart's got a lot of miles on it. I'll just put it that way. So you get a lot of balance in the arms. And so you can see that hole on the bottom there sort of wallowed out. We've had some issues with it sort of tilting forward and then also with it coming out of height. And so that'll throw an error for you. We've had to sort of tighten that down. And when you have bushings, they sag over time. So just do your equipment checks, I guess, in the morning of every day when you do their calibrations. It's kind of what we found to work for us. You'll have to occasionally tighten some of that stuff up. Not a big deal, but they are expendable parts. We've worn some of the bearings out on the wheels, things like that. So it comes back to the ruggedness category on some of this. But overall, equipment was pretty reliable. We didn't really have issues with calibrations or anything, just some of the routine collections, which is kind of why we wanted to be out there and see these challenges if you go to a full wide scale collection on a project like this. So what we're going to look at next year, some of the final thoughts on some of that stuff. Pushing this cart is not a sustainable way to collect the entire project. I'll just leave it at that. It's not even because I'm the one doing it. It's not reasonable to expect even I was ready to quit after one job, much less do it for an entire season. So it's something that needs to become either more efficient or automated or roller mounted or Segway mounted, vehicle mounted, however it needs to be. I guess I see it in two different aspects. It could either be, you know, similar to a high-speed flowograph where we deal with the moisture susceptibility and we can run top lift after the fact, or it needs to be an equipment mounted thing, more of a QC role, in my opinion. Second piece is how much data is enough. I sort of adjusted our sensor spacing and our pass count just for logistics sake. And we still got 3.6 million points or something like that on this project compared to, you know, 600 cores like we standard for acceptance. So we really, it's just balancing, you know, nobody wants to get waterlogged with all the data that we have. That's obviously both ends of the extreme spectrum there. So that's something we need to look at, is how much is enough and how much do we really need to make informed decisions on qual. And then obviously the best place for this technology to live. In my opinion, it has its role in both applications. I would love to see it as a deliverable. I would love if a contractor comes up to me and they say, hey, you know, if I tell them I want 99% conformance at a 95%, they say, hey, we got this cool thing called the density profiling system we're going to run on this. I would love to take a step back and say, okay, leaving this pool point out, but we'll see. There's a lot of room for that. I think it is a very powerful tool for both. I would love to see it as a deliverable if it's mounted on something, and we accept based on a lot-based, random lot-based. We collect, verify results, and then if they drive with the contractor, we accept their results. That would be my personal opinion of how this is best suited. That all kind of depends on your acceptance criteria as an agency, but that's sort of how we're looking to do. We're not quite ready to do the specification piece yet, just because of all the variability we're seeing and some of this stuff. It's just not quite there yet. So we're gonna probably just continue to do maybe some pilot projects here in the upcoming year. So, that's all I got. Are there questions on that? Any? What do you want to know? Anything for what we saw? Bryce?
So they did 2 1.5 lifts?
Yes.
Did you see a lot of variability from first to second?
So we saw it so it was a sliver landing where they had the unbound on the shoulders. We did see some variability. You know, whether that was from picking up the unbound or whether it was being on an unconfined base material, we saw lower dielectrics on that were then remedied when we got to top lift. So yes.
He's still having to deal with the application of the fog seal.
Yeah. So 5 of our 8 districts still use it. Some are less set in their ways than others. Leave it at that. But yeah, we're dealing with basically is it even necessary, and is it if it is necessary, that's just one of the hurdles, I guess, local, maybe unique to North Dakota, that we need to deal with. Because if we're gonna push this towards implementation, half of our state uses it. So yeah, this is probably our 4th project we've done it on with fog, and some of them are better than others. It all kind of depends on their dilution rate and how it breaks and everything like that. A lot of the whole point of it is that it gets absorbed into a hot mat, fills your bowl as well. If it does get absorbed well, it's not as big of a deal. But if it sits on the surface, if it's an oily mix, it causes what you saw there. So
we do have similar problem when we did our pilot project for asphalt real-time smoothness measurement with a pneumatic tire on asphalt. So I ended up with a little plastic scraper mounted just on the wheel. So it was kind of at least to scrape some of the asphalt buildup. Once it's too much, then you still have to spray some oil.
Yeah, we tried the WD thing, and I mean, you're talking 7 miles. You spend more time spraying than you do collecting. So I don't know. We scraped them every day. It's basically how we dealt with that. I mean, when we recalibrate it.
We mounted a scraper just.
Yep. I understand. Yep.
I have a question regarding the discrepancy between the lab
Yes, sir.
dielectrics and the ones you got. Was the lab also from truck mix?
Yes. Yep. So that was the discrepancy. That was the QC lab that was running production gyratories, and then it sampled at the same time, and then I ran those after the fact. So same mix, I wouldn't necessarily call it a split because it wasn't necessarily the same. You know, we sampled once a day, they sampled throughout the day, every 1,500 tons. But it was the same mix. Just aged differently.
It was multiple days.
Yeah, 17 days consistently, so.
So just curious about the aging. Do you have highly absorptive aggregates that you might expect the aging to make a difference? More of a difference, I should say.
I'm not sure what the root cause of that is. Especially not in that region.
Is it like 1 hour versus 2 hours aging and we're same temp? It just.
Yeah, I mean, it's just reheating.
Yeah.
So, Joe, I thought that you have one side show the cores, it's most of the cores on the one side of the.
They're also skewed.
Yeah, so just kind of bias on that. Do you think?
Compared to the calibration, I think it's the same thing. I think our lab calibration, something's happening to our plant mix when we re-age or we reheat and do it after the fact, so. But to get them to make the calibration curves every day without a contractual thing would not happen, so. We were stuck with grabbing samples and doing it after the fact.
John, do you plan to use Veda for the next stage analysis to compare IC, PMTP, and your DPS?
Yeah, so like I said, we got all of our other IC stuff earlier in the week. We do use Veda. It's just a matter of, it's not something after 15 hours of pushing the cart all day. I can go throw together a project file. So maybe you can work it and make it a little bit easier with some of that, a little quicker. But yeah, we do at the end of the project. That's something we do in the winter time, look at, sort of forensically of what. But again, it's got to have different uses, right? That's not useful for the contractor to know what went wrong. It's more or less for best practice. It's got its place, but we do mostly Excel-based stuff in the field. So pretty easy. Anything else? Okay. Thanks. I think I was.
We put together to a party and then everybody asks questions. That's crazy. Thanks, Ron. So next we're going to bring New York. Going to be a little bit of a switch in subjects. I think a welcome switch, though. They're doing some neat stuff with their specifications and how they're attacking the data collection aspect of it. So excited to hear from Brendan here.
Yeah, so definitely would echo a lot of the things that we were just talking about, the QC versus QA stuff. In New York, we're really invested at this point in developing an acceptance version of the spec. So I'll give a quick update on some of our data from this season, and then kind of talk about what the spec looks like now and how we got there. This kind of fit into a bunch of different places in the presentation, so I just put it up front. This is how New York DOT is split up into our 11 regions. And this kind of shows where our projects have been. We've had this on 16 contracts to date, trying to spread them across the state to get exposure of the technology to our regional counterparts as well as the contractors out there. This season, and I'll apologize as well, I haven't had a lot of time to go through this data yet. We're just still going through it. It's going to be a winter project for us as well. But this gives just a brief description of what we saw. We're not a heavily beta invested state, and we also don't do a lot with IC. So we're doing a lot of our analysis through Excel. And last year, virtually, I spoke about some of the histograms and things that we were doing. This is a much more compact version of that because, as you'll see later, we're investigating a few different ways of how we're going to calculate for an acceptance. So we've moved towards trying to develop that acceptance tool, so the data is kind of reflected. But you can see our total average is 92, 94%. for the different offsets, 95, 95. So did well, standard deviations about 1.8. And then you can see the breakdown in percent of data that's in different bits of percentage on the bottom. And again, this is our comparison between DPS core location, DPS at core locations, the cores, nuke gauges, and actually in this job we have PQI as well. So these are some of the graphs that we're looking at more aggressively than generating those maps of dielectric across the map. Because this is really how we're going to get the message through that this technology is able to be used as the other ones were. So like we were saying yesterday, this is better accuracy than some of the things we're using now. So we're trying to show that in the data to our contractors. Another job, a lot more data. You know, again, we're seeing the 93, 94%, and you can see in the bins, you're looking at 90% of the data in the bottom 2 bins. So really good. We're at this point really happy with the data that we're seeing. We're happy with our calibrations. So at this point, we're moving forward with our acceptance tools. Now, these are some of the things, though, that we're still working on investigating. Going the way we're going, we don't have the ability to go back and look at, you know, where the paver stops were overlaid on maps and things like that. We're going through the data, and then as issues come up, we're contacting the field and looking through work reports to see what could possibly explain these things. These are the types of things, though, that we see on occasion, not frequently, that we're still investigating, and it brings up what we're going to do with it. So you can see that the DPS on all the core locations is really consistent this day, but the core readings and the gauge readings dropped for cores 2 and 3. We're not really sure why, and our plan would be to go back to these locations and collect rolling core mode data in those spots, in probably around those spots, and see if it was just a localized area. But we had some concerns about this has now been open to traffic for quite some time, so that calibration that we developed may not be so accurate for that. And that kind of leads into one of the methods that we're looking at for the acceptance, going back later to do the scanning. That's a big question mark still. So how do we develop our specification? The rest of this is going to be talking about the spec and how we got to where we are today. In New York, we're not, we have a DPS, but we are contracting, the contract puts all the data collection onto the contractor. And that contractor either has their unit for themselves or they subcontract it out. But basically, we use the same process for developing the spec and developing the acceptance method. So these are the same goals. I stole this slide from another presentation, but everyone knows the basic goals for why we're doing this. So I'll skip them. So the first season we did was 2020. Very, very short spec. It basically said, we want to use this new technology, collect the data and show us what it can do. And we were going to look at it from our end and see what we can do with that data. So it was very simple, just hire someone, collect it, and let us see it. We started out with 100% coverage. As we said before, that's not really manageable for the number of people that have these units. It's not really manageable to collect all that data. And on the other side, we didn't really know what we were going to do with it yet. So it was a lot of information that we didn't really need. And prioritizing these, like I said before, the core, nuke gauge, and DPS comparisons in order to get the buy-in from the people that are hiring the contractors. That was obviously going to be important. Phase 2, 6 jobs in 2021. We reduced our coverage to 50%. We added new requirements for the core locations. We actually do 4 core location scans. We'll do static, longitudinal, and transverse, and we do a rolling longitudinal and transverse. We've been looking at averages, but we're also trying to figure out what the best way to go with that is. That's still currently what we're doing. But yeah, it was great to hear some conversation about that yesterday about what the group thinks the best way to go. At this point, we really have in New York people dedicated to this, so that's what the additional personnel investment. We reduced our calibration specimens. I think everyone did that. And the distinction is between QC and QA, which we've talked about a lot. In New York, like I said, going QA and seeing if the QC will follow. 2022, 7 paving jobs, increased our reporting requirements. This year we had a contractor purchase a DPS unit, which is great. Got more exposure in the industry. It eliminated a lot of issues that we had with our spec. The specification to this point had still largely been to collect the data, and we work with the company as we want. We had some issues with the contractor collection, specifically the operator training, as everyone has said. There was one person that they had trained up really well. They had some bumps going along. They actually had 3 jobs. First 2 went well. 3rd job, that person got moved away. And it came down to whoever was on the job that day would push a cart. The data quality is significantly worse when someone doesn't have multiple days of training. So for this coming year, we're going to be doing operator certification course. We have the new spec. We're splitting it between the specification and now a materials method, which will basically just be how we want the layouts, how we want the reporting to look, the offset requirements, things like that. And the operator certification we're going to do right with our ride quality group. So they'll come at the beginning of the season. Every operator will have to be certified by NISDOT before they can go out on a job. We also had some sensor dropout problems. We, like I said, own a pave scan, and Rich does a lot of work in New York as well. So we've been facing that this whole time as well. So we've added requirements that multiple sensors to ensure redundancy. The clear way to define confined versus unconfined, that comes out of our data processing side. We're doing everything in Excel and trying to boil it down to what an acceptance method might look like. There wasn't a real clear way to define whether the joint was confined or unconfined when we were looking at just raw data. So we've added some things into the method that will make that a lot clearer. Like I said, the operator cert. We're also doing the standardized data submissions. We had a lot of problems with that too with the untrained operators. And the amount of options that you have for exporting data from PaveScan. We saw things that were kind of all over the map. And it didn't help that when we went to go back, they weren't always keeping the records the best way they could. So we're standardizing that moving forward. So MM99, as I mentioned, is the method that we're using. And it defines the break between QC and QA for us. We haven't used DPS for acceptance to date. Everything has been a like a shadow program to collect data. Moving forward, we're going to develop an acceptance method that will still remain a shadow, but we're going to look at what acceptance would have been on these jobs. We haven't developed what the payment would look like, whether it be on lots, segments like we talked about yesterday. We're still developing triggers for the corrective actions. If there's a large area that needs to be corrected, that's what we're going to be working on over this next year. So one more year of collection, kind of the way we have been, just with the increased certifications. And throughout this year, we're going to be developing that. It was good to hear yesterday that there was some talk in the technical working group about some pay factors and things like that. So we're definitely moving in that direction as well. So our vision for the future, we're going to be rolling out our operator cert this year. We're hoping to return to 100% coverage in 2024. Like I said, we're doing the shadow acceptance version of the spec, and we hope to do a full acceptance in 2025 and reduce coring in 26. It's an ambitious schedule. I don't know if we'll meet every part of it, but that's what we're hoping to move towards. Any questions about that? It's definitely a different track than what we talked about yesterday. I mean, it was great to hear all the work that the contractors are doing on the QC side of this. Really exciting work. In New York, our experience is that the best way to get the technology moving forward is to put it on contracts. So that's what we're doing.
Is MM99 publicly available?
Should be next week.
Okay.
Yes.
And is it not, you said you're hoping to do every project, but right now it's just selected project. Do you have the criteria how you pick projects from the two?
Yeah, so it wouldn't necessarily be on every project. It would just be an option for projects. So right now, our targeting for project selection has been mostly geographical, trying to get things throughout the state. We're also starting to target where we have 50 and 60 series paving, which includes the nuke density and the cores, so that we can continue to generate those correlations between technologies. And starting to target some interstate jobs so that we can get, most of our jobs have been in low volume kind of roads to new technology. So that's kind of where it always starts. We're trying to get some more experience on different series of paving and some interstate paving. But target, as far as like project selection for acceptance, we haven't developed that yet.
What is your certification looking like for the operators?
Yeah, so the plan for that is to basically have MM99, which is why we're still polishing that. Basically, that's going to have all our layouts. It's going to have all our reporting and everything like that defined in that method. The plan is to have a side-by-side with our ride quality. They do a certification every year. Have a little sample section of asphalt. It's obviously not going to be brand new, but we don't really care about what the data is. We just want to see the operator do it right. So our plan is to have, a couple of days, maybe 2 weeks of appointments available during that time. The operator would come with their equipment, basically perform a scan of that section and report or do an export that meets all the requirements in 99, and just basically watching them do that. This is our first year doing it, so we're trying to keep it as simple as possible, but the basics of, can you turn this on? Can you put the offsets in right? Can you put all the targets in? We had issues where all of those things were not, the operator couldn't do those things. So we're it's a very basic operator cert, but I think it's an important step, and it will develop in the coming years as well. But if you get if you get data that's been collected on a full day in time mode instead of distance mode, it doesn't help. So those are the kinds of things we're trying to do.
Right, an excellent job. Couple questions. What was the rationale for comparing DPS and cores to the nuke gauge? And then second, what's the rationale for going back to 100% coverage? Because I'm the guy who pushes the bar.
Segue. Yeah, so, well, segue maybe a little bit. I mean, I agree. I think the next iteration of this technology involves some kind of either automation or vehicle mounted system. I don't see how it could possibly go with just walking 100%, right? The 100% coverage is a target, but the biggest, I mean, as you know, the biggest hiccup we've had is availability of units and operators. So we're trying to solve both of those things. But if we don't, I mean, we ultimately want to have 100% coverage, and we're going to end up moving the acceptance in that direction. So we're trying to get the word out that we'd like to go that way, and see where we land. As far as the comparison between cores, nuke, and DPS, that's, you know, cores and nuke is what we're doing now. And the DPS is where we'd like to go. So we're trying to show that this technology is capable of measuring equal or better than what technologies we're using now. I think we'll all agree it's not a perfect measurement technology, but if we're getting better than what we had, that's a pretty good standard. So that's the rationale.
And you're going to look at that only at core locations or every 200 feet on a 60 series, as is typical for the gauge density? Will we also be doing DPS every 200 feet or just at core location?
This year or in like a full acceptance?
In a full version?
No, so we're only doing it now at the core locations because that's what we have. And we're trying to generate the population of data that we need in order to convince people. Moving forward, it's likely going to be averages of lengths, full coverage of the connection. And as Rich brought up the other day, we don't have calibration pucks every day. We're calibrating in the mixed design phase, and we've been pretty comfortable. And I think some of the data that was presented earlier shows that it is pretty consistent. And we've always had the fallback option of if there is an issue, we can always pop. And we'll notice too, I said reduced coring schedules. Core-free pavements has been like the tagline, at least in New York, for this technology. That's great if we can get there, but at least initially, if we can reduce, I forget who said that yesterday, but if you can say 50% of cores, that's huge. That's a huge time saving for both the contractor, for the life of pavement, and for the department. On 50 series jobs, we're taking all these cores, turning them around and back to the contractor with data the next day. That's a huge lift for the department. So if we're able to give them real-time percentage numbers in the field, and we can reduce our coring operation, that's a huge lift. Yep. Go ahead.
So I guess the question, so why do y'all not do the calibration flex every day? Is it the lack of having the MDMs, all the labs, or what's the reason?
Well, we're contracting all the work. Everything is built into the contract, and it hasn't been required yet. The MDM has only recently been available. It just wasn't practical up till now, and we've spent our time trying to assess the early on calibration and see if we're comfortable with it. And we've become pretty comfortable with the data that we're getting from that one calibration. Now, that being said, one of the big things we've been looking into is what degree of change in the plan would trigger the need for a new calibration. We have seen problems where, like one of those plots I showed earlier, where we saw a big drop, day over day, and go back, come to find out, they changed a source or something like that in the plan. So that is one thing we're looking into with our equipment, is what degree of production change needs to be there to trigger a new calibration. That's the way we've been going. I guess we'll find out if it was right in a couple of years, but yeah, that's where we're headed right now.
My question is M99 and your separation between QC and QA. Could you maybe clarify that?
Yeah.
In terms of, you said you're contracting everything out. Is the contractor actually measuring it, or is it already held all that?
Yeah, so right now, everything has been in the contracts. So we're basically paying for the data right now. We're not accepting or anything like that on data. What the QC QA split will look like in a couple of years is what our focus has been. So the vision for the moment is that the contractor would be collecting the data still, and we are going to develop some way of verifying the data. MM99 is basically just a more agile way for us to update what we want. So in this, we can update in the Materials Bureau the method year to year based on issues that we're seeing. Maybe we got too strict in one area or whatever. So MM99 is really just the method for how we want things collected. It shows the offsets of the sensors from confined joints and things like that. And specifically what outputs we want. Like I said, we don't have all the metadata and things like that we were talking about yesterday. We're looking for a large population of just data that we can process on our end and get it into Site Manager. So that's all MM99 is. It's just an easier way for us to update the current practice for field collection for the state.
So you're verifying, you use the term verification. What have you got up your sleeve to get that done? Curious how.
That's a few years out still.
What's out of data? How are you going to do that?
Yeah, so I mean, we have one PAVE scan right now, and I mean, I don't see, we don't have the personnel to run full coverage either. So, obviously cores are the first and easiest way to handle something like that at a reduced amount than what we're doing now. We're not really sure yet. We still need a couple of seasons to figure out what we're going to do to verify the contractor data. We've talked about a few things. We talked about cores. We talked about again going back and doing a later run with the DPS and see if we can do that after traffic has been on it for some time. Not really sure if that's going to be possible. But that's what we're doing now. As the contractors are collecting the data on the jobs, we're using ours to kind of investigate ways that we're going to use to verify it. So, sorry, I don't have an exact answer for you yet.
I think it's an important topic. Right?
Yeah.
It's something that keeps coming up around this technology and it needs to be addressed.
Yeah, absolutely agree. Yeah.
It doesn't make sense to do it twice.
Right.
All the pressures. That is directed at that, basically, folks. Be the bad guy, but going back to the CFR and recognizing that the world we live in is different than it was 5, 30 years ago. Maybe we should be looking at CFR.
Yeah.
So Did the people online, were you able to hear Adam's comments there? Or should we make him say it again? I'm sure it'll come up again in the discussion at the end, but that's an important topic. And thanks for the presentation, Brendan. That was really good stuff. So Brian is joining us from Virginia. The flight tried to keep him from coming to us, but he was too determined. He's here with us today, and there was so many questions that I didn't want to stop. So if you all are fine with it, I want to give Brian his full allotted time, and then we'll just adjust the schedule as need be. So don't feel rushed to get through your slides, and we'll go from there. So, all right, thanks, Brian.
Thanks, Kyle. If I'm doing this right, hopefully I'll have some fun.
There you go.
But, thanks very much for the opportunity to come here and chat with the group. I really appreciate that. And hats off to those of you folks, especially John over there, if you walk this many miles behind this thing. I'm a tall guy, and standing behind that cart, I'm either hunched way over or I'm kicking it every step. So my first comment for GSSI is do something for tall people. Angle the handle, make the handle longer. I don't know what, but it's is the mouse what I'm supposed to be using? So luckily in the projects we've done, we've done relatively short distances, maybe only half mile per project. So I want to start off by acknowledging my colleague, Harry Nair. We both work at the research division for VDOT. That's what the Transportation Research Council is. So our office is in Charlottesville, Virginia. And just for informational purposes, it's a high of 53 degrees there today. So in terms of our testing, we bought the first DPS unit last year, 2021, using state funding from federal facilities. So thank you to those folks. And we started our testing on 5 field projects, and we followed up again with phase 2 starting this year, where we did another five field projects, and then we hope to do a few more next year. We purchased the MDM MIS design module unit this past year. We've only done a little bit with it, so I'm going to try to gloss over it quickly, but we have to do more else. I guess I talked about this in a online, whatever the proper term is, a month and a half ago, and I had great aspirations that we would get a lot of things done. Reality did. So again, the phase 1 that we did last year was really to investigate the use of the equipment and get our feet wet. We looked at multiple projects and mixture types, in particular nominal max aggregate sizes. So we did 9.5 and 12.5 millimeter mixes. This year we added in a 19 millimeter and 25 millimeter mix. And the only issue that I noted, and I don't know if it's because it was the 25 millimeter mix, or because when I was walking so close behind the all the projects we're doing are testing right behind the density tech. And I don't know if on this particular project, you were just close to the front of the roller, but we got a lot of pickup on the tires, just like you were mentioning. And when you're talking large pieces like that, it's like driving a thing over a rubber strip. And I spent a couple hours with a torch and a 5-in-1 tool, peeling all that stuff off the tires. That was a mess. So long story short, lesson learned from me is don't be so close to the density tech. Give time for that material to cool off and get pickups. It was a mess. Put it politely. So phase 2, we started again this in 2022, was continued phase 1 work plus adding a lab component. And what we want to do is we want to compare the DPS results with field core density, and then we also sample mix in the field to compare. So notice the term I'm using here. I'm using DPS to determine or to denote the field unit, DPSL to denote the lab unit, rather than using hopefully the terms. So we compare the lab unit with results from lab pill density, and we call that PMLC, our plant-made mix lab compacting, as opposed to plant-made plant compacting. So there's a reheat step in there. And we're hoping to follow the process of doing the spec development. I'm just not sure we're quite there yet. But I'm glad to hear that you're concerned. Maybe I'll be contacting you, Brendan. It sounds like you guys are really heading that direction. So I put in a couple steps in here for how we conduct the field work. I'm assuming this presentation will be available later. So maybe some folks that haven't done this work, maybe this would be a help. When we do our work, we do an initial scan for about 300 to 500 feet to select the core locations to start with. And we have a crew of 4 folks that come out with us, 2 folks that are doing the core work and the patching, one of us pushing the cart and one of us sort of jumping between the other 2. So we select the 3 high, medium, and low dielectric values, and this is you didn't bet about think here. And then we sample 4 boxes of mix from the paper for the lab bills to be able to go back to the lab. Our boxes are like 65, 70 pound boxes, so that's how much here we collect. We measure the dielectric value in each of the core locations that we pick, and you know, I had been doing this based on a time measurement. It was static measurement with a time sequence, but I guess based on yesterday's conversation, maybe that's something we ought to change. So the question I have is how far do you run that distance measurement? The length of the core, or I mean the diameter of the core, or some distance shorter of that because the beam spread?
In core mode, it stops automatically. Start on the edge of the core, and it goes 6 inches, and then the plow.
Gotcha. Okay, that's helpful. Thank you, Roger. So for those of you online, if you didn't hear it, Roger just mentioned that in core mode, you can go through and it'll automatically start and stop at 6 inches. So that's helpful. So while the other folks are coring after we do those measurements, I go and continue testing in 500 or 1,000 foot section, just depending on, because again, we're right behind the QC technician. And so as they move up, fill up behind them, walk back and forth. And just again, for self-preservation, I had the segments together in Excel. That's how I've been doing the analysis. Not that I'm promoting Excel over Veda or anything like that. I knew Excel much better than I did Veda. So again, this is us doing the testing. We purposefully picked projects that were lower volume routes and had an undefined edge, just because we wanted to see as much variations between the projects. VDOT is one of those unique agencies that we maintain all the payments from interstates to subdivisions, and so we had really a wealth of projects to pick from. So when I go through and I do the files, I orient the device this way. I do 2 scans or 2 passes with the entire cart. So and all the data that I present, pass 1, 2, 3 are left to right. The first pass, and 5, 6, and 4, 5, and 6 for the second pass. So that way, again, I can go back and look at my data later, and everything's oriented the same way. And that was one of the first things that I learned. So the next picture there on the right is a picture showing Harry going through and doing the testing. In some cases, yeah, it's kind of close to oncoming traffic and things like that. So that's a potential concern for sure. So again, how we plan, I guess, to do the work in the lab, but we've only started this process. So the first thing is using hashtag T166 to make all specific grab each core that we take, and then we calculate percent density, that easy equation. To come up with the GMM, we're using the daily rights value from the plant instead of a project average. We think the daily value is a better option. Looking at plot the core dielectric value that we obtained earlier versus that percent density to obtain the compression equation, and then plot that density versus distance. And so this is a thing that I encourage. I don't know if this is already underway. Again, I've kind of come into this full-time operation maybe partway through or later than most folks. So if this is already done, I apologize. But I think terminology, I really hit on terminology a lot and the importance of making sure we're all doing the same thing for a lot of things. So when we plot this density versus distance, is it the density, is it the regress density, is it regress percent maximum density? Yeah, I'd like to see a contrary use for all those things, because in some ways, each of those 3 things could be something totally different. I heard they were mentioned earlier this morning about a calibration curve, like a statewide average. I would say that's something that's not, it doesn't make sense, at least in my mind. I tried to plot, so these are 4 different projects we did. I plotted them all on the same scale, so you can see how that calibration curve moves around, depending on, of course, the dielectric properties of the aggregates, the binder. As far as I know, I don't think we have any magnetic aggregates. So it'd be interesting to find it if we did. But again, you can see that that curve does move around on each project.
Just curious, approximately where are your projects located in Virginia? I mean, so I see particularly the top left one relative to the other.
I don't remember, but everything we've tested has either been in the Northern Virginia area where we could be in dye-based material.
Yeah.
Or we could be in central to South Virginia, Southern Virginia, where we're in more granites and limestones. And in terms of the Excel work, this is how I come up with the information. And so I plot the two different distributions there across the top, and then the plot the regress. I'm going again calling regress percent maximum density there, the distance across the bottom. This is a project that I had mentioned, I guess, when I did the online workshop. So for this particular project, it just kind of anecdotally, I talked to the density tech, say, hey, I'm noticing a lot of low density on that number 6 scan, which would be the right edge of the pavement. And he said, oh yeah, he said, we got a new guy on the screen and he's starting the right edge of the screen. And so it showed up on this and I collected some, however many feet, 2,000, 2,500 feet, almost the whole thing was low density on that right edge for the same reason. And you can see each going across, I guess the figure on the bottom, the green line that's on the bottom is from that right edge, the number 6 scan. And you can see it, unfortunately, the distance is cutting off, but each one of those little troughs at the very bottom represents about where the truck came to the pavement. If you cut that distance off versus the amount of material on each truck, so segregation is what we're seeing. Otherwise, across the rest of the map, I thought the formula looked pretty good. So again, us doing the work, starting to move into the lab, this is some things we did a few weeks ago. Our first attempt, we did not get a very good correlation. And I don't know if it's because it was the first time we did it or, but anyway, I'm not sure we followed the proper procedure. It didn't work so well for us, so we need to go back and revisit that. The way we did the testing, we took the core from the field, sliced it, of course, to get the whatever the other layer was off of it, tested it with that cut face down, and then we did the 4 measurements, so you rotating the device. And I looked at the variability between each one of those measurements, and the variability is really low. I think if I calculate a COV, it's like a 1/4% or something like that. So my question is, one, if there's a specification for this, is there a variability limit on those 4 replicate measurements set up? I don't know if that's something you're doing, Joe. And if the variability is always low, do we need to do those 4 measurements? You know, cut down a lot of time. So then measuring again the dielectric values from lab pills, we fabricated pills from the resource collected during paving. Again, we call it PMLC, a plant mixed but lab compacted. I'm finding out that the height is not necessarily all that critical as long as you actually know what it is. So we targeted 116 to 120-ish millimeter tall by 6-inch diameter, not cutting the faces. And I think most folks they're doing manufacturing pills and jars where have some sort of mechanism where they know the mass material that needs to go in to get the amount of density that they want. So we estimated a mass T of approximately 96% density, and then we adjust that mass up and down to come up with three other densities, 90, 30, and then 3 replicants of each density. So again, this is what we're planning to do. We haven't actually done this yet. This is what I'm planning.
Brian, just to clarify, the height not being that important, you're talking about what the height actually is, not what height you input into the device.
Yeah, so yeah. Kyle's comment was you need to know accurately the height of the specimen to put it into the machine, correct?
Yes.
Is it 116 or 120 millimeters, 116 or 120 millimeters that you target to use the specimen? That part doesn't matter.
Okay.
So, but yeah, absolutely, the height of the specimen in the DPSL unit or MDM unit is correct.
Yeah. And the only reason I clarify that is there's been multiple instances where if a user doesn't put in the correct height, then you get a huge bias in your results.
And I think that's part of what happened to us on the very first attempt we did it. So yeah, absolutely. So to reiterate, it's an important point. Knowing the height of the specimen to do the mix design module is critical. Actually targeting what the height is, there's a range. But measuring the height and inputting correct height is very important. So again, trying to come back to maybe save a little bit of time here. I wanted to end my presentation with some random thoughts, and hopefully this is useful for discussion. We expected to see a correlation difference between the DPS device in the lab and the DPS device in the field. I think if I understand correctly, this ought to change with the core thickness. So if let's say I'm doing most of our work in the agency is an 1.5 to 2 inch mill overlay,
If I'm measuring that 1.5 to 2 inch mill and overlay in the field, I'm getting some influence from the material from that. So if I go through and do a correlation in the lab and I'm making 116 or 120 millimeter tall specimen, I've got a different situation than I have in the field where I'm trying to measure, you know, the 1.5 or 2 inches. So to me, I wonder how on earth can we set up a correlation prior to construction when I'm measuring a different thing in the lab than I am in the field. So to me, that's a question I have. I don't know if anybody else has looked at that yet. So a lot of these questions that I ask, I'm going to caveat this with, I am a fan of GPR testing, and I've been involved in GPR testing since the mid to late 90s. So I'm not trying to, but this is my tough love presentation. So in terms of implementation, we still haven't really figured out who's going to do the actual work. So far, I have been pushing the device most of the time. I don't intend to do that for the rest of my career. I don't want to do that for the rest of my career. But anyway, who's the primary operator? What's the timing of the measurement too? Again, all the work that I've been doing has been right behind QC, density tech, and there's a lot of downtime. In terms of my dollars per hour, it's not a good return to the state, I don't think. Because I'm doing a little bit of work and I'm sitting and doing something else maybe, or I'm sitting and then I'm doing a little bit of work. To me, ideal, and I heard it mentioned, I don't know if it was John or Wendy who mentioned it earlier. To me, the ultimate for this would be to have this on the same device that comes back and does our ride quality testing. We come back within a week or 2 weeks, run the machine over top of the paper section, and it goes to traffic speed maybe, and then we collect the information that way. I know there are manufacturers out there. I think one was on the call or on the call earlier. You know, a lane-wide, lane width GPR antenna to make one pass over the whole thing to me would be ideal. I don't know as far as the sampling rate. That's really behind the question I mentioned yesterday. What kind of testing interval do we need? Do we need to test every 6 inches? Can we test every 5 feet? Can we test every 10 feet? If you start to get to those orders of magnitude, I think with the equipment that we have now, we can start to do close to highway speed testing with this. And I think that leads, at least in my mind, to a much easier chance or a much easier process to implement this technology for an agency rather than the cart-based method. I think what the cart-based method does is great if, again, from the agency, my agency perspective, it makes good sense to me for a contractor to do this as far as QC work, but I'm not sure it's there for agency acceptance either. I also wonder in terms of, you know, the different requirements, maybe the test spacing, the density value, all those kind of things. Should we be looking at, do those answers or do those results change on the different road types? And again, maybe that's only a thing for me because of the type of roads that we cover. But do I need the same testing density for interstates as I do for subdivision? Do I need the same acceptance criteria for interstates as I do for subdivisions? And right now we haven't even looked into that, but that's some things I added in here after some discussion yesterday. Ideally, I think what we would like to move to, we don't do anything in terms of PWO in our state. There has been in the past big pushes against that, but I think the times have changed. It was interesting to hear yesterday the comment that 25 or 27 states have some sort of PWO process right now. So to me, I think this process lends itself really well to that. So I think that makes a lot of sense in my mind, at least, as a way to develop a special provision for us to incentivize density and conformity. And all that being done through a PWO process. So that was the last slide I have. I'm happy to address any questions if you have. My contact info, my email is kind of long, so thank you very much.
Question. Are any of the tests, you said you tested some 19.5 and 25 millimeter? Did you do that with the DPS? Is that some of your results up there?
No, they're not.
You did run the DPS on some of those mixes though? And how did it work well for you?
Yeah, it really did. So this was on a interstate widening project on 995. They were adding a lane and a full width shoulder to the inside of the existing interstate. And so it was a perfect opportunity. You know, I mentioned this the other day to somebody else, I forgot who. That on all these projects, I said I want to go to these projects that are isolated from traffic as much as I can in daytime. I don't know about everybody. So this project was, you know, Jersey walls everywhere and it was all daytime work, so it was easy for us to get to. Again, for convenience, I think John mentioned that earlier. So we ran through the first layer of BM25 is on top of the aggregate base. We did see more variability in that, but I think it's a function of where it was placed and what it's placed on. The next layer that went on top of that was a 19 mm mixture and saw a lot less variability. That mixture was really good for me. But unfortunately, I don't have the data on the airship.
Are you putting those in like 2.5-inch lifts or 2-inch or what kind of thing?
I think the BM25, the 25 mm mix may have been 3.5 or 4 inches, and the 19 was probably 3. Yeah, our airship games are 10 to 12 inches of asphalt.
Good presentation, Brian. I enjoyed it. Thank you. You said you used T166 for getting the voids. Did you? I guess this is probably a question for everybody, but how often are you having to run T331 after that water absorb is too high? That's something we've been running into. If we get our water absorbed, we get higher voids. I mean, at some point, we're just gonna have to run 331 to begin.
Yeah, for the particular mixes that we've been using, we haven't had that issue. But we've been doing all so far all dense graded mixtures. We haven't been running SMAs to it and things like that.
Yeah, similar for Minnesota, we're running mostly dense graded mixes, and then in the instances where we don't get a dielectric measurement before we do our T166, then we'll do a core dry and then measure it that way. But we're not getting kind of the open graded or really high void mixes where the interconnecting voids affect our T166. I guess the other thing we keep in mind is, at least for the calibration of the curve, once it gets up high enough in voids, you kind of know it's bad. So whether the T166 is under predicting it at 11 and it's really a 13 at that point, it's, not as critical in our curve.
And that's one thing, maybe, I hope I emphasized through that process earlier on here. Certainly, we would have measured the dielectric of that lab fabricated pill before we do the void measurements because of the dunking.
That's in your presentation that you compared the dielectric, the MDM with cut faces versus no cut faces?
No, we didn't do that, but I wanted to mention that we were cutting the face on those as opposed to the, so that's the field core, as opposed to the gyratory main pill, we're not cutting any faces. Just wanted to show the process, that's all. But we did make comparisons.
Okay, correct me if I'm wrong, but I think we get a break now. So let's see. Let's be back at 10:10. All right. Well, a lot of really good discussion at the official sessions and then even better discussion over the break, I suppose. But all good things come to an end. So we are to the portion of our agenda where we wanted to get some time for open discussion. And if there's any other states that weren't able to do a presentation, now is your time to shine, or now is your time to just say hello. I see Craig Londefeld is online. He's always good for an Ohio update. Craig, can you hear me, and do you want to share with the group an Ohio update? You might have had a better break than us. Any other states online? I see Larry Riggleman is there. Maryland.
Hi, Kyle.
Hey.
This is Rich from Alaska. I'm
there we go. Rich
listening in.
Anything you want to share with the group, Rich?
No, I'm still looking for that mystical acceptance project where we'll get to use the DPS for acceptance, but haven't found one yet. Still working with the designers this winter, seeing if we can't push something over the finish line next year.
Yeah, I know you're pushing the incentives and the bonuses, but people evidently don't want money up in Alaska.
I think the contractors would be happy with it. It's more my own agency. I think it's the resistance to change.
Gotcha. All right. Thanks, Rich. Do we have any other states joining us online or in person here. I guess we could move to the in-person people. So if you're a state and you're here, you don't have a choice. You have to at least say hello.
Raise your hand. There you go. Don't leave Mercedes hanging.
Here in Utah, we've just started to take the RDM and actually go out there and start performing some of the tests out there on an interstate, in an interstate application. And through trial and error, we figured out how to set it up, start to gather data, make some mistakes, keep learning that process. I think we've all been through that, but now we've got the data. Now we're trying to figure out how to get that information into beta and trying to review all that data and try to make it into something useful that we can use in UDOT. But I think we're very proactive and liking what we're seeing so far. And it's been amazing and a lot of good feedback because everybody said, what are you guys doing out there on the road? We talked to them about it and they're like, this is awesome. So there's a lot of positive feedback from industry out there in Utah and the department.
George is right there.
Excellent. Utah, we're coming over for beta workshop on March 1st, 2023.
Okay.
Yeah, well, Georgia, we've had RDM for several years. It kind of moved around in different groups. Started with our testing bureau. They actually mounted it to a golf cart. And we're collecting data. I think they were happy with the data. I wouldn't mind someone looking at the data and saying it was good. You know, I know they collected data with I think they had made a mount or something for the actual whole incident and everything. But you know, been working with the RDM, but we got the MDM and working on doing the we're trying to get a couple mixes, a 25 millimeter and a 12.5. They're both super paved mixes, dense graded. We are running into, we were talking about T166 and 331, where we're running into a lot of we get above that 2% water absorbs. So it's kind of like, do we just need to do 331 from the start, and all the bills kind of thing. And again, I'm glad it came up in this meeting, the issue about how, I guess, New York, how y'all do not doing every lot the calibration for us, because like we've talked about before, where we're set up, but we're not doing volumetrics, that would be definitely somewhat of interest for us. Like, does that need to be done or not? So I found that very interesting to see, for us what we can kind of, because we'll probably look at it where we're, for the research purposes, when we're on a project or something, we'll be getting the mix and we'll be, just doing it in our group ourselves. But on a regular project, that wouldn't be happening. So it's kind of like but we can kind of compare it, get the data, doing the calibration bills, and then also looking at it for calibrated with the next. And then trying to get a lot of data. Hopefully have some others look at it. Yeah. And give us some feedback. What we're looking to do, we came up with a kind of our own 3-year research plan for the RDM. I mean, I think our materials office is pretty dedicated for us looking at this. And then we're trying to, within that, kind of create a little lab study for the MDM. So I'm really interested in kind of what Virginia was doing with that. My boss is, I don't know, Dr. Peter Wood. He's formerly from NCAT. And that kind of thing. He knows how to do research. Yeah. But it's really a powerful tool. I mean, we're very, very interested in it. Just kind of gather more data and see where everybody else is. But I know some of our things that we were looking at have already been answered, I think, when we were talking. Just kind of sit here and see what other people are doing.
Great. We have Craig joining us online. Go ahead, Craig.
Hey, everybody. I don't know, I guess just a few thoughts. Some of the things that kind of, I guess, good / bad that others are having some of the same issues, but some of the sensor issues that we've had, that was one thing that I was gonna bring up. You know, the cold weather seems to be kind of uniform across what several others have been talking about, but you know, we've just had a lot of issues later this fall, even with, you know, keeping the sensors indoors overnight and warm and inside vehicles, you know, during travel. Couldn't get them to boot up and couldn't get the carts to run a few days. So that's been something that's been concerning. We've just had some other generic issues. Another one that had to go back and get swapped out. And GSSI's been great about helping us out with those kind of things. Just you know, continue to have some once in a while, and keeps us thinking. You know, what's the do we need to still consider maybe some of the ruggedness or some of these kinds of things as we you know, move forward. Some of the discussion about the kind of the ground truth like plate that you were talking about, Kyle, with a, you know, known dielectric, I think that's a really good way to go. Really would like to see some of that move forward. One of the other things we've been trying to understand a lot more this year has been just how we want to handle longitudinal joints and how we would want to mix that in potentially with you know, with what we would do. So we have a specification that we use on our, you know, higher volume roads, 4 lanes interstates, where we actually take physical joint cores and have a pay calculation, you know, factor just for the joint itself that is a 6-inch core, you know, centered on top of the joint. And we moved to that because we previously had been coring with, you know, 4-inch cores. We would take 3 from the lot and kind of mix them in with our MAC cores for the day. And we found that, you know, by not having that higher level of you know, requirements and detail, you know, those cores always, you know, were a lot of times coming back really low in density. And, you know, if you moved off a little bit, the density came up dramatically very quickly. And so, you know, we weren't really capturing those really low densities like we were when we moved them over and put them right on top of the joints. It's really improved joint quality in Ohio, so we're happy about that. But now it's how do we handle that with DPS? You know, if we measure off, are we moving back to the same situation we were in, where we have these, you know, unconfined sides that are, you know, lower density and some of those kind of things. So just how we want to handle that. Didn't seem like measuring right on top of the joint was a great idea either, with, you know, some of the crushed aggregate and things that we end up when you make a good joint at that location. So that's been something we're kind of interested in and looking to figure out over maybe the next year or so.
Good information, Craig. Thank you. Are you going to be able to stick around for the discussion at the end of the day today?
Yeah, should be around all day today.
Awesome. Yeah, because I think some of the stuff you bring up is going to be critical for the future of DPS. So that'll be good to circle back on some of those things that you brought up. All right, let's keep going around the room here.
Yeah, there. So I'm from Washington State. We're a little behind compared to a lot of these other states in terms of implementing this technology. We've been able to go to a few different projects. We've been rolling the RDM on bridge decks. We can stop pouring that. We've just been collecting data in terms of research, following a lot of the videos provided by you guys, by MDOT, you know, helpful YouTube videos in terms of how to run the machine, how to do mud calibrations and all of that. So we've collected data on 4 different bridge decks so far, but we haven't got around to actually like looking and researching and analyzing the data in the Excel sheet and plotting graphs and everything. Essentially, we just have a bunch of data right now that we need to take a look into and see. Hopefully, the goal would be to stop pouring bridge decks and using this new technology, and then as we get more familiar, implementing it further.
Thank you. All right. Do we have any other state updates here? Going once, going twice. Steve, you want to share?
I just have a question. How much asphalt do you have on your bridge?
We've been going out to, like, we milled and filled a new pave, a new lift on the bridge deck. Usually it varies to about, I say the average about 2 inches.
All right, well, way to go, States. You got us back on schedule here. We have coming up next our vendor updates and question and answer. And it's important for us to be neutral, so I'm not going to decide who goes first. I'll let them decide for themselves. Arm wrestle, maybe, I don't know. All right, GSSI is listed first. So Roger, come on up.
There you go. Thanks, Kevin. Please ignore the raindrops. It was a PowerPoint. So today we're going to talk about new developments that occurred in 2022 forward to what we're thinking about 2023. That will be likely. So in 2022, we released the HK and MDM. We generated and came out with GSSI mixed calibration equations, which I'm going to spend a few minutes talking about. And also, near the end of the year, the HDN RDM desktop version for DPS user group fund members. HDN MDM acronym Mixed Design Manager. It's a standalone setup for mixed calibration using box or cores. Cores too. We've made a bunch of measurements this summer. We're feeling you can measure the dielectric of cores. There's a lot more variability though. So that's one of those things we're going to have to continue to look at. But certainly for forensic purposes. GSSI mixed calibration equations. Based on dielectric mixing models. Simplifying assumption here. The asphalt mix is a combination of two different dielectric materials. We have the asphalt, just the binder and the aggregate. Let's call it dielectric, the GMM dielectric, right? No air brakes. Then the second constituent would be the air brakes, which have a dielectric of 1. So here's the concept of the GMM dielectric. We have one of those familiar charts, DOT plots, in 2018. On the vertical axis percent voids, horizontal axis dielectric. Each one of these blue dots right here is a Mach measurement. Machs were collected over a range of dielectrics and percent voids. A least squares fit line was drawn through these bucks. If we extrapolate that least squares fit line down to 0% voids, we get the GMM dielectric, the dielectric corresponding to 0% voids. So why a mixing model? With a linear fit model, we need multiple bucks at multiple percent voids. Varying voids, right? With the mixing model, in theory, we only need one puck or core, any percent voids. How can this be? Here's an example of a dielectric mixing model. This is the average Strickland bounds mixing model. For short, just the average have HS model. Don't worry so much about the numbers here. The most important thing to look at, there's only 3 variables, right? The measured core or POC dielectric, measured percent volts, and the GMM dielectric. If we know 2 of these, we can calculate the 3rd. So, if we make a measurement, a dielectric measurement or measure the percent volts, we can calculate the GMM dielectric. That's all we need for the mix calibration, one of those measurements. Then, using the GMM dielectric and any measurement, dielectric measurement, it can be a field measurement, we can calculate the corresponding percent voltage. Let's look at this graphically now. Here we have a plot of percent volts versus dielectric. The base of these lines is our GMM dielectric, 0% volts. So, using that mixing model from this slide, for every dielectric, we can calculate a corresponding percent volts. So these lines represent different GMM dielectrics that can basically tell you what your mix define. They can define the mixes. So this line right here would be the mix calibration for GMM dielectric. The lines are nearly linear. That makes sense, right? All our calibrations are least squares fit lines right now. So we're real fortunate at GSSI to have a bunch of calibration bugs. Actually, we have a couple hundred now. It's a wonderful thing. We have 5 different mixes with wide range that I'm showing here of dielectrics. Each circle here is a measurement, percent voids and dielectric. The colors, each color is a mix. We have a really low dielectric mix. We have a couple, 3 right here in the mid-range and 1 really high. Note that all these bucks, all these measurements fall parallel to these lines. What this means is that the mixing model works for each one of these mixes with a wide range of dielectrics between mixes. So how well does the model work if you only select pucks from percent voltage from 4 to 7? Recall that we can get a mix just based on 1 measurement for 1 puck. So let's just take 2 pucks here, between 4 and 7% volts. We have our least squares fit line from all these measurements. And for our mix model, we only take the measurements from these 2 pucks. We go back to that average HS equation, and then we calculate this green line, which is the mix model. See how well it fits all the pucks. So a critical question is, how well does this mix model work with the linear fit? How does it compare? 8% volts, right? That's a really important boundary here between good and bad for PWL. And furthermore, for the mixing model, let's just use measurements from pucks between 4 and 7% volts. So we have 5 different mixes here. Maine through Utah and New York. I really like that Birch Lake Road. It's a nice name. What we're doing here is at 8% voltage, we're calculating from our least squares fit line the dielectric. We're also calculating from the mixing line corresponding dielectric. And then we look at the difference. At 8% voltage, we see that the average difference is 0.019 in dielectric, with the maximum being 0.03. That's really good. But let's look at it in terms of percent volts. So what we're going to do here, here's a different mix. We have a least squares fit line, and then we have a mixing line. We're going to take 8% voids, find out the dielectric on that least squares fit line that corresponds to 8% voids. And then we're going to use it to find the corresponding percent voids from our mixing line. Okay? And we're going to do this for a lot of different data sets. And look, this is not a very good correlation here. We're seeing over 1.2% difference, but that's an outlier. So we took the data from the 2021 MnDOT paving season that's available online. 3 paving jobs, totaling 32 different mix calibrations. Each data set is from 1 or 2 paving jobs. So we have our 8% voids from our linear fit for each one of those data sets. Here's our puck data set along the horizontal axis. 30% voids. We calculate the corresponding percent voids from our mixing line. And we see that there's an agreement to within 0.4% voids over 1 standard deviation. That's really good. There are a couple of outliers. And we're going to focus in on this one right here in the next slide. So we're going to take a closer look here. I apologize. There's a lot of data here we're talking about today, but I love data. So here we have data. And there's a lot of great data here from everybody. This is a great thing. So data from consecutive paving date, 6/15. We have our least squares fit line and our mixing model. Really good agreement, right? We're going to jump over to 6/18, 6/19. Again, really good agreement. But in between, there's this big discrepancy from that one spot from the previous graph. So we see here are all our puck measurements. There are 8 puck measurements. There are 3 measurements, these 3 plus signs, that are way off the mixing model. The least squares fit line has to fit the data, so it forces its way over here. There's a total disagreement there between the 2 methods. So in the next slide, I'm going to dive down into each puck measurement. Remember, each puck gives you a unique GMM dielectric, a unique potential mixed calibration. And so we're plotting on this axis from the data from 6/15, our puck number, 5 pucks versus GMM dielectric. You can see here that the variation is between 6.15 and 6.25. So fairly good agreement there on 6/15. Jump over to 6/18, 6/19, again, pretty much within 0.1 in terms of dielectric. 5 different pucks. But here's our problem, Dave. We have 8 pucks, GMM dielectric, from the first puck. 5th, 6th, 7th, and 8th pucks are right in line with those other 2 days. But look at these pucks right here. Those were the ones that were off the line. Totally different GMM dielectric. Something is dramatically different with these pucks. If we use those for the calibration, we'd be off by 3%. So what's going on? We don't know. But something. And we could figure it out with further forensics. The GMM dielectric is low. So that means it's not a worship issue. Could it be segregation? Different aggregate data. Error in measurement. Don't know. So next, let's look at day-to-day variations in mixed GMM dielectric. There's been a lot of discussion about how much does a mix vary from day to day. Well, this is something that we can use to really figure that out. So we have the 3 paving jobs, each 21 paving job. So we're plotting the GMM dielectric versus paving data for each one of these jobs. The green line right here is the GMM dielectric from an average of the plots. for each one of those paving days, from one day to the next. And we can see not much variation, plus or minus 0.05. And that corresponds to about plus or minus 0.6 volts. That seems reasonable. And the TH30 paving job, pretty much the same thing. And the TH60 paving job, 19 days of paving. We can see as we start the job, we have nice consistency. This is the bad data point from what we saw from the previous slide. If we filtered out those 3 bad data points, those 3 bucks, we would get a GMM dielectric right up there with the rest of them. So we can use this GMM dielectric to do QC on bucks. And furthermore, we can see trends. During the first 9 days of paving, the GMM dielectric is between 6.15, 6.2. And then it looks like after day 10 and later, it drops by about 0.05. It would appear there could be something different with the minutes. The other thing to note here is that our GMM dielectric standard deviation using the mixing model is much less than the GMM dielectric from the least squares fit line. So this could imply that the mixing model is more accurate. We assume that the mix varies minimally from day to day. So there are all sorts of really interesting applications using this mixing model, the average HS equation. We can track batch to batch, day-to-day variations in GMM dielectric. And the changes in the GMM dielectric are due to changes in moisture content, binder content, aggregate dielectric properties. So we can do a lot of forensics using this method. And we can do QC on cores and buttons. The GMM dielectrics need to fit the model if the dielectric of the mix hasn't changed. So if we have segregation in the mix, it should change in nearly every case, the mix dielectric. So our recommendations going forward for generating the mix calibration using cores or pucks. For cores, minimum of 3 cores, but I think more would really be wise. In mid-range dielectrics on the map, if possible. Avoid the high and the low dielectric areas. Why? Greater potential for segregation. I think you get the most accurate mix calibration just from the mid-range dielectrics. Pucks. 3 pucks at design number of gyrations. So when you're doing your mix designs during the winter, you can do your calibrations in the lab during the winter. These will give you baseline numbers for each mix. And then when you're doing your mix calibration equation in PaveScan, MDM, or RDM, use GSSI curve for your mix calibration equation, which corresponds to the, and then curve 2, which is the average HS. So the last thing from 2022 is the PaveScan RDM desktop version. Freely available to pool fund members. We're going to send an email out after the meeting with a link to download. So this is something, we're going to have a utility there. You take a USB key, plug it in, you can download your projects to the USB key or flash drive, and then take that and upload it using a utility to your desktop, running this version. And so you can do all your processing with the desktop version. So likely 2023 paving season developments. Great discussion here these last couple days, and we're really incorporating a lot of the things, hopefully, that you mentioned. QA correction using a fiberglass block, simplified user interface, vehicle mount, and the cloud. Fiberglass block QA. As Kyle mentioned yesterday, the dielectrics are corrected to a known reference value. So you can go back day by day and get the same number. We've had real good results in the field this summer at GSSI, and I'm real glad to hear MnDOT has also. So we're thinking the swerve and the repeat line probably aren't necessary going forward. And we're thinking this will likely replace our daily air and metal plate calibrations. It's that accurate. Going on the right, we have a prototype here. Ken Corcoran from GSSI, he's in the picture. We did a lot of data collection together this summer. Here's our prototype parallel block, 1.25 inches thick. It's thin, and it needs to be placed on the asphalt when you're doing this measurement. We've also lifted the cart 1.25 inches. We want the same height for this measurement as we do over asphalt. Simplified user interface, in addition to the current rule. So we've seen a lot of feedback, and certainly feedback in the last 2 days here, that the user interface can be achieved. So there's a thought. Thinking an easy collect, auto project and file name, right? User presses a collect button. They don't have to enter in any other information, except maybe if it's distance or time mode. And time mode with GPS. Post processing, KML export, statistics at 100-foot increments, summary statistics, and maybe a folder structure for the different export types, so you don't get overwhelmed with the data. And we're certainly curious to hear your thoughts on this. And we did some testing with a vehicle mount using a roadhouse block language. We simulated the easy collect mode. And my vehicle mount, I think it's obvious to everybody here that the cart can be a little too fragile. It is too fragile. Too much work. Cost. Can't hire an extra person. You need 2 people. And safety. Exposure to the pavement tree. So we have a prototype set up here. We collected data recently this summer, mounted on our van. And we did some data collection on the parking lot. With a cart and with the van. So on the left, we have our cart data. It's a pretty good sized parking lot. 400 feet by 250, 300 feet. Percent compaction is mapped 88 to 98. And we're comparing these data sets at common locations. We filter out areas where they didn't really align up. And with the van data, it was time mode with GPS, single data, right? Backing up, going forward. With the van, 20 minutes. Smile. King collected data with the car, not so happy, an hour and a half, right?
You have a picture of that?
No, I have a picture with the thumbs up.
Oh, there you
So amazingly close agreement between these 2 data sets. All the highs and the lows line up just about exactly. We use the fiberglass for the QA. So I think the future is bright to simplify this. And if everything is GPS registered, we can, I think, simplify this. Finally, the cloud. We're still ironing out the final details, and we're really looking forward to trying to get it done, to get to a good point by the end of today. I don't know if it's possible, but I think that's the future too. We're going to implement it somehow, in some fashion this year. That's all I have to say. Thank you. Any questions? Yes.
Quick question. You said you didn't know about why those outliers. Is there no project feedback about asphalt content or any mix parameters?
Well, I took a really close look at the data last fall. And there wasn't any smoking gun because they had MnDOT had all the information regarding the mix, the GML, the asphalt content. So it's really interesting.
So for that data set, one thing in 2021 that we used for the input for thickness was the gyratory compactor readout, which works great for design void pucks, but you can catch it mid gyration for some of the really high void. If you're just removing mix and keeping the height the same, you're looking at really low gyration.
The 10%.
Exactly. Yeah. So in that case, the thickness output from the gyratory compactor is more variable for the higher void mix, which could be a contributing factor to that. Like Roger said, no smoking gun, but you know, one thing just looking at that and looking at the test summary sheet, there wasn't much of a change in mix from day to day. So I do tend to agree with the mix design GMM there. So thank you.
So Kyle, are you inputting gyrations then instead of locking your height consistent in that instance?
For the, we still have a target height, but the target height isn't always the actual height, right? So that's.
Along the same question, since you recommended using mid-range apart for your model fit line, GMM line, have you verified that with a core versus pop? Because in the field, I always have a skeptical about fitting model with the real world. Have you validated that with the field cores with your GMM line and whether you capture all these good or bad mix, not just the mid-range?
Good question. Question for the remote people was, have we verified this mixing model with cores? Yeah. The good news is that MnDOT had cores for just about every one of these paving projects last year, so, and they lined up with the pucks, except for a few outliers that aren't yet understood. So, yes, by association.
So Roger, for the truck mounted the DPS system, have you tried to measure the joint density? We had tried this because we have difficult time to mount them since 6 inches away from joint.
Yep. We have not tried it along the joint, but one of the contractors has a golf cart. And we were thinking the other day that a golf cart could be pretty darn useful for doing it along the joint.
And besides, it's probably too heavy for fresh asphalt pavement.
Yeah, that's a concern also.
What's the data collection speed with your van?
He was in a parking lot, so he was going pretty slowly. But time now we're collecting 60 scans a second. So if you're going 45 miles an hour, you can collect one scan per foot time.
Is there some plans to still incorporate some of the processing with the simple collect time mode that you've implemented with the distance control mode, in the sense that you're able to do segment by segment percent conformance when you have the DMI and you're in distance mode? Is there any way to use the GPS data to do similar analysis in pave scan or plans, or speak about that?
Yeah, I think that's the idea. What we do is because we have the GPS, all the positions are registered. We should be able to break it into 100-foot sections. Okay. So, regarding the cloud, there was one thought. I was talking to Rich at the end of yesterday's session, and it was uploading just the exported data file for every project, so that could be downloaded by somebody else. But we could talk about that a little bit. Yeah.
The van versus the cart, those were done right after each other on the same day. Is that correct?
That's right.
Is there any thought to doing it like in the spring to see different levels of contamination, for lack of a better word, soils, brake dust, things like
I think that's a great research project.
that.
Well, thanks a lot, Roger.
All right, so next we'll bring up Chuck. Earth Science Systems.
Good morning, everybody. Good morning, everybody. This talk is about another dielectric scanning system. We call ours the asphalt pavement scanner, the APS, and it measures density. It measures density in compaction, just sort of like the GSSI system does. But it also measures thickness, roughness, and temperature as well. And you can see in these pictures here, the center of everything is this green box. This green box has all of the sensors in it. It's wireless. And what's neat about that is that, you know, it's easy to set it up in different deployments. You can put it on a cart, you can put it on a vehicle, or you can make spot measurements with it. So the other part of the system is a tablet computer. And so the tablet, you know, if you're in a vehicle, the tablet can be up in front with the user, with the driver. So we really think that this is a really neat system for really a comprehensive MAT assessment. So my outline today is just to talk about the system. I think a lot of people here might not be very familiar with our system, so I just want to give a 10,000-foot view of it. Talk about the measurements. We've recently moved from a cart-based system to a vehicle-based system. And then I think the hot topic of the day is verification and calibration. So hopefully I'll add some things to seed that conversation. Oh, the down button. Okay. So before we get started, I just want to reiterate, in my humble opinion, I think GPR is just a wonderful, wonderful technology because there's so much information we can glean from GPR. Just imagine this green box here. We all know that we're looking at the amplitude of the reflected wave that bounces off of the surface, and then we can calculate dielectric and compaction from that. Well, we can also look at, in our case, if we look at the first half of the reflected, the first half cycle of the reflected wave, we're looking at 1.5 inches depth. If we take the whole cycle, we get 3 inches of depth. So we get both of those simultaneously. If you look at the time of flight of that waveform, we can see how high the scan head is off the ground, and then we can measure roughness as the cart moves along. And then part of the wave penetrates to the bottom, and in many cases, we can actually measure the thickness of the mat too. So that's 3 different things we get just from bouncing a wave off the ground, or 4 if you look at different depths. Our system also has an IR temperature sensor and an integrated GPS. So let me just describe our GPS real quick. The GPS is integrated into the green box. It's a 4-constellation GPS, so it gets the US GPS, the Russian GLONASS, the Chinese Baidu, and the European Galileo systems. So by itself, you've got a little bit more than 1 meter accuracy. But if we get, you know, the RTK base station information, we have centimeter level accuracy. And a lot of the state DOTs have these RTK networks, like Minnesota does and other states. And you can freely just subscribe to those RTK base station feeds and get the centimeter precision with almost no effort. If by chance you're in a location where there is no base station feed, maybe you can't subscribe to one, your state doesn't have it, you can use our base station. You just bring it out to the job site, set it up, to, you probably put it on the center line and you can have the centimeter level accuracy that way. And I'm not going to go through all of our software, but all of these measurements can be used to create maps and reports. And we can also export our data to Veda. The dielectric and temperature information can go to Veda. You can obviously input the mixed calibration. The profile or the height of the surface can be exported into ProVal, and so IRI can be calculated. We calculate IRI if you don't use ProVal, and then we've got a CSV export. If you really want to be a data scientist and look at everything and something more than just a user level. So just a couple quick examples. This is cart-based data. This is a subdivision where you can see these are 7 lines in a 2-lane road. The center line you can see has not very good compaction in the joint, and then the last 2. I don't know if you can see the mouse move there. These are the last 2 roads that were paved that day. I don't know what was going on, but the contractor didn't do a very good job of compaction on those last 2 roads. But that's just sort of a quick example of compaction. Here's a quick example of thickness. In many cases, we can see the bottom of the asphalt, all of the lifts. There's a reflection off of all of that. And I think most of you people familiar with GPR have probably seen examples of this, but we can make thickness maps. And in this location, it's supposed to be 4 inches of asphalt, and it's anywhere from 3 to about 6. We've talked about this calibration using gyratory pucks, and I don't think I really need to go over this process. There's one thing I want to bring up, and that's the idea of potentially adding a digital signature when the lab tech does these calibrations. And so that with that digital signature, there's no possibility of somebody later on in the workflow fudging the numbers, doing some fraudulent activity. So this is just something I think I'd like to throw out there for discussion. It also lends provenance to the data. So I suppose there's a guilty party. I believe there is an AASHTO proposed standard for doing this. There's certainly been talk of it. I think it's been introduced to the committee, but I think it's in the very nascent stages where you take 3 gyratory pucks to come up with a calibration equation. The first puck is the design puck. The other two pucks are just lower density pucks, the same height, but with a different amount of material in them. And I think everybody here is pretty familiar with this. One of the questions that comes up is, as always, is the instrument measuring the right dielectric? And so we provide a little reference disc that we can put on the top. I think, we don't have a picture of it, but there's a reference disc that you can put on the top. And I think I forgot to mention, this is our scan head it's the same green box that we use in the field. You can turn it upside down, put a coupling cone on it, and measure the dielectric constant of the pucks using time of flight mode. So we have done a lot of work really using the NCAT, the statistics sort of proposed by NCAT to make sure that these measurements are repeatable. It doesn't matter, we get the same number. It doesn't matter which serial number of device we use. It doesn't matter what operator does the work. We make these cross plots of APS measured density versus AASHTO density, or versus another APS sensor, or versus another operator. And the statistics that we look at are the accuracy and precision, and those two multiplied together are the concordance correlation coefficient. And based on the NCAT guidance, that number is supposed to be better than 0.975, and we're much better than that. So this is really, really a very accurate, robust method. It's just working better than the specified guidelines. So in this example, there were 40 some odd pucks that were taken with different measure heads and different operators, and we like the results. We've operated, or excuse me, we've offered this single scan head cart for a while, with the idea that we wanted to make something inexpensive for contractors, easily adopted by contractors. But the feedback we're getting is nobody wants to push a cart around. We've heard that multiple times today. It's a safety risk. The contractors don't want to add labor costs, and invariably, there's already somebody out there with a pickup truck that probably has nuclear gauges and maybe some core drills. Why don't we put these sensors on the pickup truck? Or maybe other contractors have a small vehicle like a Gator where they have some roughness measuring equipment on there. Why don't we piggyback on the back of that? So that's what we're trying to do. I'll show you in the next slide. And the DOT feedback, they want accurate, verified results and full coverage. So with that, we think a vehicle-mounted system is the way to go. So this is a system that we've recently built. I'll point out that you can move the scan heads anywhere on the back of the vehicle that you like. The scan heads can be oriented. Our sensitive area is about 24 inches by 18 inches, an oval shape, and you can orient the scan heads any way you want. The whole thing mounts to a trailer hitch, so it's easy to mount on a lot of different vehicles. We've had some very encouraging and early results with this, and we like what we see. But we've also had an outing where we had a vehicle that had a 3/4 ton truck with a diesel engine, and our sensors were just shaking about an inch just due to the vibration of the engine. And so, as you can imagine, we didn't get very good results there, but with smooth running vehicles, we're getting good results. So that's something we have to keep an eye on. Our sensor box has accelerometers in it, and maybe one of the things we can do is put a red light, green light, put it on a vehicle that's running too rough, whatever it is, you get a red light, and we know that we can't use that. The outriggers, these arms that these sensors are mounted to, they're motorized, and so to do a background calibration, they'll automatically go to the top and then come back down to the right level above the ground. And we can tolerate plus or minus 2 inches of variation in height above the ground. And if you've got more than that, you probably have other problems. If you've got more than 2 inches of height, plus or minus 2 inches of height variation. But the whole system is wireless. The operator sits in the front. You push a button to raise and lower the sensor head, so you never have to get out. And so we think it's a really nice system, and our early results are really encouraging, like I said. There is something that I learned that I didn't expect, and that is if you're trying to maintain a survey line that's close to a joint, or you want to do a bunch of repeat lines, it's actually a lot harder to do in a vehicle than I anticipated. And overcorrecting is, you kind of need to learn how to do it. But one of the things that really helped a lot is we were working with NCAT, doing some tests there. And for the IRI certification, when they do the repeat lines, when they have a vehicle, they have to really make sure that they run the same traverse over and over again, and that they're not off to the side. And what they recommend doing is getting a forward-looking camera, just like your reverse camera, but forward-looking. And in this case, this is a camera that mounts on the rear view mirror, but the camera is looking forward. And you can put a little piece of tape on there and adjust the camera and line that up with markings on the road or a cone, some sort of fiducial in the distance. So with that, we can stay within about 4 inches on our repeat lines, and so that's actually a really big help. One slide about roughness here. I'd mentioned that we've got this really accurate height measurement that we're measuring using time of flight of the GPR, and so we've got a height measurement. We've got 2 wheels on a vehicle, and so what we have is very similar to a profilograph or a rolling straight edge. And we do this deconvolution thing to turn the GPR measured height into the actual height of the ground, and then take that height of the ground or the profile of the ground and turn that into IRI. And the approach that we use doesn't have the deadband problems that a traditional profilograph would have, and we can talk about that offline. But let me just take you through a few plots here. So this top plot is just the position of the three antennas on the three scan heads on two repeat lines. And you can see that the deviation off the center line is reflected in all of those. And each of these sensor heads has their own independent GPS system. And so this to me, the fact that they all show all the small scale variations just shows how nice the RTK GPS is working, and you know, the independent variations are we get good results across all the sensors. So the second plot is the calculated height of the ground, and the ground height is different depending on which, you know, if you're on the right, left, or center, based on the color that you see here. And you can see some little variation here. We're looking at about a half mile's worth of data, and pick a color, pick the red color here. You can see that there's a little variation here. But that variation is on such a long wavelength that we don't care. So for IRI, we're interested in variations from about 6 inches up to about 100 feet. And anything greater than that, we don't care. So if we don't reproduce that faithfully beyond 100 feet, we don't care. And then the last plot here is the calculated IRI. That's just a roughness in a moving window as we move along. And each individual color you know, repeats really, really nice. This particular example, we had the vibration problems with the truck that I mentioned earlier. So we had to filter out some of the high frequency or the short period wavelengths. So we couldn't really certify with it. But we think with a smooth vehicle and the results that we've seen that this is going to work pretty nicely. Okay. Switching topics here, I want to talk about how we calibrate our sensors in the lab. So that they read the correct dielectric value when you take them out to the field. So we calibrate using, we've got these standard blocks in the lab, these 3 by 3 foot by 6 inch thick blocks. We've got polyethylene, quartz, and marble. And you need to know what the dielectric constant of those blocks are, what our standards are to use them to calibrate with. You know, just using polyethylene, you could look it up online and say, oh, polyethylene is 2.3. Well, it's really not. The polyethylene that we get from vendor A might be 2.28, and the one we get from vendor B might be 2.33. So what's the right value? We have a common laboratory technique uses an open-ended dielectric probe, an open-ended coaxial probe. And you put this probe up against the material that you're trying to measure, and you hook it up to a vector network analyzer, and you can measure the dielectric constant versus frequency. But this setup has to be calibrated, and that calibration, you know, we have to account for fringing fields on the dielectric probe, the electrical lengths of the cables, and to determine that, we put an open load and a known dielectric on the probe so that we calibrate our lab setup. And so the open and the short are simple, but the known dielectric is harder. What's often done is distilled water is used, but the electrical properties of water can change, you know, markedly just by adding a grain of salt or sugar. And so cleanliness is a big issue. Plus the dielectric constant of water is temperature dependent, so we're adding yet another variable. So that's difficult. We were lucky enough to obtain a NIST SRM, standard reference material. And so this reference material is almost not frequency dependent and almost not, the values don't change versus temperature. And NIST has determined and certified, you know, its dielectric constant to a lot of significant figures. So we use that NIST reference to calibrate our lab setup, and then use that to measure to come up with the dielectric values of our calibration blocks. So these calibration blocks are NIST traceable transfer standards. And I should point out that our calibration setup, we have repeatability better than 0.02 in terms of dielectric content. So this is a very interesting tool. Yeah, there's more to say on that, but we can talk about that offline. Something that people have asked about in terms of coming up with a golden profile. If we have a golden profile that we want to run our scanners on and validate that they're working okay, well, what is the dielectric value of our profile? And people have said, well, maybe you could use a percometer. And I think the answer is we can do something similar to this, but this particular device is a bad choice. It's the wrong frequency. It's not accurate enough. But maybe something like this could be used to make a golden profile. So let me say a few words about how do we know if we're taking good data in the field? And so what we have is just a light with a green check or red X that has a bunch of checks behind it. So if the device has if the temperature is changing too fast, you'll get a red light. If it's been too long since you've done a background, you get a red light. If the height is not within range, you get a red light. If there's radio noise, you get a red light. If you're going too fast, that's actually a different indicator. You get a red light on a different indicator. So that's just a real-time validation that the device is being used properly. What can we do with the data in the field to make sure that our device is working good? Well, we can do a repeat lines and do statistics on the repeat lines and look at those statistics in the light of PP98, for instance. And that's fine if you want to do 1 or 2 repeat lines, but I think really to validate the method, we can do a lot of repeat lines, and for each point along the line, we can do the statistics on the repeats just at that point along the traverse. Sort of like the IRI measurement does. So if you think about the IRI certification, there's certain metrics in terms of the height measurement that the device has to meet, but there's also metrics on the distance measurement that the device has to meet. And I think maybe we should have both dielectric and distance in our QA assessment. So another thing that we can do in the field is if you want to make sure that the device is reading the correct dielectric, you can take the scan head off, put this coupling cone on it. I'm pointing at the screen, you can't see. Put the coupling cone on it and do a reflection measurement on a known standard like this. And so we've had this for quite a while. It's a bit cumbersome. And so what we're working on right now is a reference target. It just hangs off of the sensor and it gives a reflector that's the same distance. It's the same distance that the scan head is over the ground. So the outrigger, you'll raise this up, you'll put this on it. It's a really lightweight piece of equipment, and it makes a reflection with the same strength corresponding to a dielectric constant of about 4 1/4. So you can always put this on, very lightweight, very easy to verify in the field, and so we've got good initial results. That's coming early next year. So with that, we're planning on doing a lot of field tests with this device, with this vehicle-mounted device this spring. So what we want to do is a bunch of repeat lines, like the IRI measurements. We'll do 10 repeat lines, more or less, and calculate the repeating statistics at each point along the line, like I measured earlier. And then we'll start rotating sensors over the line. But the vehicle is always going to track the same line. We tried moving the vehicle over and doing subsequent lines, and that didn't work very well. That was probably a problem with the driver in many cases, not being able to drive a repeat line. So we're going to have one line that we repeat over and over using the cameras as I mentioned earlier, and we're going to we're going to analyze the results using these statistics put forth by NCAT. So yeah, sensor to sensor variation, line to line variation, and we'd like to do cores as well, but I have cores. cores and the actual dielectric measurement have quite a bit different volume of investigation. So we're always going to be doing some apples to oranges comparison there. And I think there's been talk in the past about taking a large number of cores from a certain site and all of these dielectric measurements and comparing the statistics as opposed to the individual readings. And that might be a better approach. So just to wrap up here, I've got some open questions to the industry. How do we do our factory calibrations? We have a method. Maybe there's some other methods that people want to put forward. And maybe these methods might go into the next PP98 specification. Right now, PP98 just addresses drift. It's not an absolute. There's no absolute dielectric value that's treated there. And I'll just point out that some of these ASTM standards that are mentioned in PP98 really are not applicable, so we should review that. How do we demonstrate dielectric accuracy and stability? I think I put forth some methods. People have been doing this for, you guys have been doing this a lot. And I think what you do for a survey versus the method are two different things. So versus the method, this is what we're going to try to do this spring, where we have lots and lots of repeat readings. But for an individual survey, maybe one repeat line is all you can do, and other than that, then it's the reference target that you can put on there. For density or compaction, I think we have a really well tested method for using the gyratory pucks. I'm really pleased with that, and I think there's been enough tests on that we should feel pretty good about that as a group. But the cores are another matter, and like I said, I think the cores, there's going to be some apples and oranges there. One question that comes up, you might notice that I called it a validation target, not a calibration target. And so what happens if you're in the field and you put this validation target on the scan head and it's supposed to read 4.25 and it reads 4.2? Well, that's within the DPS spec. Do we adjust it, or do we let the user go on and do the survey? Or what if it's out of spec? Do we allow them to correct it? Our position right now is that these units are factory calibrated and that the user should not change the calibration. And I'll leave that open for debate. We can certainly do what the industry recommends, but if we don't, right now we're taking responsibility for these calibrations. If you can go off and change your calibrations, then that opens up the possibility of fraud. And that segues into the digital signatures for the mixed calibration. If they're digitally signed at the lab when the calibrations are made, they can't be changed in the field. And these mixed calibrations could potentially automatically be imported into Veda. So the whole workflow gets easier for the user. We have provenance. But if we're gonna make guilty parties, then we have the whole spectrum of responsibility, liability, negligence, and fraud. So I don't know the answer to any of that. And the last thing I think is this percometer. We could build something that's applicable if we want to make a golden section. So I think that's it. Bottom line is that we would like to hear from you. Tell us what you need as an industry, and we'll try to incorporate it. So please let us know.
All right. Well, thanks a lot, Chuck. We have still 3 minutes for questions for Chuck, and then if we go over, we'll still have time for discussion with all the vendors at the end of the day too. Are there any questions for Chuck?
Chuck, do you anticipate being able to add additional sensors on your vehicle mounted platform?
The question is, can we add more sensors to the vehicle mounted platform? The answer is yes. At the moment, we may not be able to add more and process the data in real time. However, each sensor box has its own memory storage on it, so we certainly can, but there's going to be some engineering work to make that happen. And the real-time display would sort of would be some sort of decimated version of all of the sensors and some sort of QC check to make sure they're all working properly. But short answer, yes.
And then a second question has to do with, so as I've had always try to be mindful of potential for fraud, right? If you're sending that to a cloud or server, can you digitally lock that cloud data and still allow for the field, if there are differences in the field, to allow that and kind of just flag it? Does that make sense?
Log the changes.
So allow it, lock it at one level, right, where it's in the cloud. But then when in the field, if they need to revise calibrations, allow for that, but then you have something to reference off of from what was done originally. Is that create too much of a mess?
The question is, if we transfer the data to the cloud, along with mixed calibrations, can the mixed calibrations be modified after the fact if they've been digitally signed or somehow locked when they were first created? And of course, the answer is yes. Maybe there's multiple signatures, or maybe there's just a flag that says, okay, this has been modified after the initial. We're not going to keep you from doing your job, but we just want to set the appropriate flag.
Yes, yeah, and like in ProVal, you can do that too, where you can see exact logs.
Try changes.
Yeah, where you can see all the logs of what has been done on the file. So if someone has changed something, you know that it's been changed.
That sounds like a great example.
All right. Well, thanks a lot, Chuck. So we want to give Jacopo his chance to present some thoughts from 3D Radar, or formerly 3D Radar, now Contour perspective. Jacopo, can you share your screen?
Yes, I can. I also try to be visible.
All right.
If the camera starts. Yeah, you see me, right?
Yes.
And now I hope you're going to see my monitors in, let's say, this one. Okay, you should see it, right?
Yes.
Okay. So first of all, this is going to be a short presentation. So I know you guys are looking forward to lunch, I presume. And I also would like to make room for some questions, not only for me, but also for the other vendors in case, there's always a little room to do that. And I actually prefer to answer questions than to guess which, what I should be saying. So, and what you guys would like to hear. So I really encourage questions. Yeah. I'm really sorry to not be there in person. I was looking forward to the event, and for a series of unfortunate circumstances, let's say, I wasn't able to participate there this year. And yeah, that's really a pity, because those small conversations that you have during the breaks, during coffees and such, they tend to be very, very interesting. And of course, being remote, I don't get any donut, and I have to watch you while you guys eat it. And that's not nice. But all right. So to introduce myself, some of you already know me from other meetings or other contacts. I'm Jacopo Sala. I'm chief scientist from Contour, formerly 3D Radar. And some of you might have stumbled on the company. If you don't know 3D Radar or Contour now, from before, it was a company formed during at around 2001, and has always been concentrated on. So the product line is all three-dimensional. So we only do array systems. So first, this is supposed to be an update from vendors. So I guess the first big update is that we changed name. So what you knew as 3D Radar AES has become Contour AES. Just so you guys know, we keep calling the system. So our three-dimensional GPR system is a 3D Radar system. Okay, so we have this kind of slack or gray area where we keep a little bit of the legacy of the company, and yeah, we haven't really changed the name to the system. So you can call it the 3D radar system. It's still that one, is still ours. So about the system, which is now contours, anyways. How does it look? We have a range of array systems, and those would be our systems antennas. Those are the ones on the bottom left. We have 3 models. 2 of them are ground coupled. They would be the first and second, so the big and the second one that you see there. Those are just examples. We have different sizes. And then we have an air coupled system, which is the one that is an air coupled array, which is the one that is of interest for this specific application. In particular, I mean, it covers more or less everything you would like to do on pavement. And it was the natural candidate to implement a dielectric estimation technology, all right? So we haven't developed a specific piece of hardware to do this kind of measurements. For us, it's been more an adaptation on the software side. So we had to look at our system, analyze it better, because if you want to provide an estimate, you know, a number out of some radar measurements, you need to verify that, first of all, you can do it. And then you need to figure out what are the properties, how you should maneuver the signal, how you should process it in order to provide some specific output. And our system is vehicle mounted. There are different sizes, which I can show you in the next slide here for the air coupled system. Let me try and move if I manage. Oh, well, it should be fine. Okay, sorry. We have different sizes. It's from 3 feet in width to about 11 feet in width. That's a very big system. But let's say that the ones that are more used for pavement analysis you know, to go into traffic with it are the 1.8 meters and the 2.1 meters. Somebody has the 2.4, but not many people very often people is not comfortable in going with something that exceeds the size of the vehicle itself. All our system are multi-channel and have a 7.5 centimeters, so it's about 3 inches spacing between the channels, and therefore collect a very, very dense grid. And they are ultra-wideband antenna elements. What I haven't mentioned is that our radar system, contrary to the ones that perhaps you're used to and the ones that we've seen in other presentations today, this is a step frequency system. So, in order to perform the dielectric estimate and the electric evaluation, we play a little bit with this characteristic of the system too. I'm not going to go through the step frequency technology, but by all means, get in touch, ask me questions. I really love talking about radar systems and the step frequency in particular. In terms of positioning, and I heard yesterday and today that this is kind of a hot topic. We treat positioning fairly well, so we respect the topic, absolutely. And each and every one of our antennas have an embedded PPS receiver that allow us to really synchronize our system, every single scan actually, with an absolute clock, which is the GPS clock. So that allows us to be very precise, even if you're moving very fast. And it's important to see, and this is a graphical representation of what happens when you move the system on the field. You can choose the sampling inline, all right? So these are 3 different choices for inline sampling, for example. Somebody moved the slider and decided to have a coarser or a denser inline sampling. But you can go from a very dense grid, which is 3 inches by 3 inches, to something that you can decimate in actually both directions. So you can decide to have less channels open. You can decide to collect data every meter, if that makes sense, or denser than that, all right? But it allows very, very high definition and very high resolution, both in X and Y, all right? So coming to the dielectric mapping now, you are seeing on the right-hand side a couple of pictures of there is one of our arrays on the bottom is mounted on behind the vehicle. On the top is a customer that we have here in Scandinavia, in Norway, that has both the ground coupled system, which you see more on the back, and I don't know if you can see my mouse pointer, but in front of that trailer kit, that trailer, sorry, there is an air couple system as well. So these guys are happy they are doing both measurements at the same time. So why do we call it dielectric mapping and not dielectric profiling? This is an internal name that we decide to have to differentiate from what is already available. So we are not really doing what you've seen before, what the other guys are doing. We are trying to be high resolution. So we collect more data, we have more samples, we collect a very dense grid with a single swath. So we are doing a map of the electric values. Also, the way that we are collecting, the way that we are manipulating the data and the sensors, it makes for an actual real two-dimensional map of the electric values with a higher resolution. The system, depending on which one you get, you can get up to full lane width coverage, the single pass. Every single effort that we've done from the very beginning was to have this thing attached to a vehicle and to move at traffic speed. All right, so that was we've never been push cart. We always looked at how can we make it work when it's attached to a vehicle and it's moving very, very fast. And since this is software for us, it's a software adaptation. So we use the sensor in another way, both in data collection and in post-processing phase. But at the same time, we can collect the data that we've always been collecting. So it does collect three-dimensional GPR data that you can decide to process yourself, outsource for processing, store for future use, you name it. And with those, you can do whatever else we do in terms of payment application, which is thicknesses, void detection, I don't know, rebar mapping, whatever. So what does a high resolution image give you? Well, compared to profiles, well, you are able to put the data into context. I like to use the term contextualizing the data because even though at the end of the day, you know, when you generate a report, when you're telling people where to core, when you're telling people where it's wrong, bad or good, sections, during interpretation is very often important to being able to understand the data better. So when you see an image that is closer to reality, you are able to put the data that you have, the numbers, into context, right? And I seen yesterday, for example, there were in many presentations, you guys had the profiles, so the dielectric values or the density values that you were extracting in with profiles. And to understanding better, you had the temperature map to see, oh, okay, this happened because of that. In our case, the images that we get are so dense that they are, I would say, not one-to-one because that's impossible, but let's say close enough to be comparable in density and feel to the temperature maps that you use to understand better why the density is different, right? And on the left-hand side, you see that picture was taken so that you could see a little bit of the sun bouncing on the asphalt. And that's exactly the same kind of features that you see in the dielectric data on the right-hand side. And it's also possible to understand, you know, how the dielectric moves around features, because radar is never a point-like measurement, it's an aerial measurement. And when you transition from a high dielectric to a low dielectric, that has an effect on your reading. That's why sometimes you get, you know, those peaks, a peak before it's low and then another peak afterwards. So looking now at some data that were collected. This was collected at traffic speed, northern Norway, by those guys that had the trailer. They didn't use the trailer for this; was attached to the vehicle directly. I think they had it on the back, but the kind of flavor of data that you get. And I could use the software to demonstrate this, but I think I can just move a little bit around to let you see type of detail that you're able to get. And the way that you transition from different dielectric or density values, all right? And the complexity of this kind of data, okay? So if I go to the next slides, then these are 3 images taken from, I think it was the same data set. The entire data set is some kilometers long. I think it was 6 kilometers in total. But these 3 in particular, they were trying to drive fast, again, traffic speed, but having staying close to the longitudinal joint. And I think that's when that's where a system like ours is able to provide a little bit more insight, if you want, just out of the picture it generates. Because then you, the colleague right before me, he was saying, you know, it's not easy to drive on a joint with a sensor. Well, I agree completely. And you can see here what happens. You know, the joint is moving, but we have so many sensors that we see it in the data. You don't really need to concentrate on where you're driving as long as you're not really wrong. But the subtlety of the information, both inline and crossline, shows a little bit how, you know, how complex it could be to evaluate a situation. So the more data you have, the more you're able to put it into context. Okay. I have a bunch of these examples. I could go through them with you online, offline, wherever you want. Just please do get in touch if you get curious. It's certainly something that is a little bit different from the other systems that are in these in the meetings here. And this is now an old image. It was one of the first tests that we had done, but I think it's I think it's a cool image because it shows really different different type of features and how the system is able to resolve even tiny ones in an image that then again you can put into context. You can understand better. So you have starting from the bottom, you have a transition from one type of asphalt to another one in a roundabout. Then you're having longitudinal joints that actually are on the roundabout, you know, circular as the roundabout is. And then as you drive on a section which they were not really interested in because it was not new asphalt. But it was there is a crack, and that one actually impacts the data somehow because it changes the type of reflection that you get from the top. Okay, so in short, an update regarding activities that we've done in 2022 and that we are bringing into 2023. So we perform additional tests and pilot project with users here in Scandinavia. So for now, we have been limited by the fact that we needed to provide active support for the users and we wanted to be at location. We have refined the algorithms based on the output from these projects. And we also took all the necessary steps to initiate the finalization as a product. And I'll tell you, the heaviest bit here is really the factory calibration procedures because we have arrays of big size, so we need to have big jigs in order to perform calibration and make sure that we have stable results. There is going to be more testing and pilot projects coming up in 2023. I'm hoping that we can do it. We can do some also in US. We do have a good user base in US, and I'll definitely get in touch with for example, MinDOT to perform some tests. That would be really interesting. And the one thing that we noticed from the process that we've done, and that I think I could argue it also from the presentations during the last 2 days, is that the dielectric to density conversion can be a little bit of a challenge. And I mean, not so much the PAC estimation and things like that. I mean, really the density readings that you can argue from the dielectric estimation that the system provides. In our case, or in the case of a user, they've seen a lot of variability. For example, they were collecting data during the morning, and as the sun was illuminating more of the road, passing through the buildings, they could see changes in the information. So they were driving back and forth, and therefore, even a small amount of humidity can really change the output. So it's one needs to be a little bit strategic when collecting this kind of data. So to summarize, dielectric mapping is part of the 3D GPR system tools, is not its own system, is a software enabler, let's say. You can capture longitudinal and lateral variation in a single pass at traffic speed. It's a fully automated process. It doesn't require any manual interpretation. You push a button and it goes. And you can do it in quasi real time, okay? So while the file is being acquired, right now, as the file is stored, is going to be processed, but it's a result that potentially we could have in real time, since it's fully automated. It can be combined with traditional GPR data collection and interpretation. The data is there, whether you use it or not. You can go and interpret it. And it has full integration within Examiner, which is our post-processing software, which means also a lot of other things. For example, the availability of satellite imagery. You can synchronize with video collected during data collection, and a bunch of other things, which would require another time slot in order to explain how Examiner works. And the output can be offered in various formats, KMZ, KML, tabular, I don't know, you name it. We have really, really many. This being said, I hope these were short enough and interesting. So I thank you all, and I really encourage you to get in touch if you want to know more. And to ask questions now, if you really have to.
Thank you, Jacopo. That was very nice. Questions for Jacopo about the Contour 3D radar presentation? It's always tough being before lunch, but we have somebody who's ready to ask you a question here.
Competition. Nice presentation, Jacopo. I'm real curious about the measurements. You saw differences between sun and shade. Was there a big temperature contrast?
No, not the temperature. It was due to humidity, basically evaporating.
Yes. Moisture.
Moisture.
Okay.
Another question?
I'm going to ask questions always related to beta. Suppose the vendors in the US output the data into MP39, which is to a standard format. Do you plan to output your work to that standard format?
Yes, we can. Let's say that the software has been prototypal for quite some time. It still is, because it's not fully productified yet, but the productification and brings to within itself also the compliance with standards and output formats.
Got a thumbs up if you didn't see that, so you answered the question.
All right.
One question I have is, how does Denmark or other European countries accept density data? I mean, what's their standard practice and specifications? I just don't have any frame of reference for that.
So I cannot speak for all countries, but frankly is a bit of a mess, because it depends on which country you're in. So they tend to not agree with each other, so they can keep arguing. But you have a macro area, which is Scandinavia, right? But the procedure for now is done. Now I don't want to say stupidities, but it's not very much different from what you have in US, at least. Other European countries, sometimes they just act after the fact. So unfortunately, still like, we need to take a lot of core. It's going to be randomized, and God knows where you take it, and you need to be within this, because that's being required, and otherwise you pay a fine, something like that. but they do not. The limits really vary from country to country. Another thing that I can add regarding especially using GPR for the electric estimate and then transforming it into density, is that one of the challenges that we have here in Scandinavia, and that is that they're very stuck in using a very specific model for dielectric to density conversion, and it turns out that which is not a linear fit. And one of our customers, for example, in their pilot project, they could do a very good linear fit. So they had a very nice linear fit, but they had to use this other model according to the road authority. And using that one, nothing fit really well. So the problem they had is that they had a very bad correlation using that one. Although they were able to show that linear fit was better, and there were other studies that were demonstrating that linear fit was better. In many cases, they couldn't really get out of the swamp in this. In that sense.
Sarkento for that, yeah, well, because he put out a publication initially using an exponential fit. They must be following.
Yeah, I know. It's they're using a lot that one, but I'm not sure. And I also discussed a little bit with Timo. Yeah.
Okay, well, great job, Monica. You are the first person to raise your hand online, so ask a question. Go ahead.
I just have a question in regards to antenna interference. Are you seeing that when looking? Because I know when we used it for other subsurface studies through Sharp 2, I remember we did get some, I guess, like power line interference and stuff like that. Some of the towers. Is that still something that has to be worked out with this system for this practicality?
For this practicality, there is an impact, absolutely, but it's much easier to take care of it than for example, for other projects we are involved, where you might want to have a little, when you're resolving things in depth, right? So here we are looking just at the surface, and we have more data than necessary. And also there is other things happening behind the scenes, a little bit of secret sauce. But it was one of the objectives that I had for 2022 was to make sure that there is that I can either mitigate or bypass or fix, for lack of a better term, electromagnetic interference in this kind of measurement. And the only cases where there's nothing to do, you need to seriously trash the data, is when basically the entire signal gets jammed. And in those cases, there's nothing we can do. I mean, it's a GPR. It radiates much less than every other radio equipment that is around. So it's if the entire bandwidth is jammed, it's jammed. There's nothing to do.
Okay, thank you.
Yep, but good question.
And you've opened the floodgates, which is awesome, Monica, because now we have Dr. Zagay raising his hand. So go ahead. Yeah.
Hi, Kyle. Thank you. Jacopo, I know you want to sleep, but last question.
What time is it there, Jacopo?
Oh, well, no, it's still early. Well, I can sleep anytime, but it's 18:56 local, so it's almost 7 p.m. I can I will also eat, but it's going to be dinner.
At least you're up to watch the next World Cup game. So I have a question. Since when you are working on this type of projects, I mean, you will be working on this is new construction, so the road is closed. So would it be a value looking into the ground couple 3D GPR instead of the air couple ground? Because you don't have traffic in there. I mean, this is closed roads most of the time.
You mean to use the ground coupled instead?
Yeah.
It could be an option. The difficulty comes with the fact that you're very close. You know, you're bringing the reflection from the surface very close to the ground couple, to the sensors. So you are in a way you're ruining a little bit your peaks, your amplitude readings. The air coupled stays very nice and separated from everything else. So it's very easy to, or very easy, it's relatively easy to use it. But there probably is some ways to use also the ground coupled, but I do not know what you are giving away with that, right?
I see.
So it's always a bit of a trade-off, but there might be a way. It would be interesting to experiment.
Well, we do have your ground couple here in case you want to try it.
Oh, we are going to, so.
Yeah.
Yeah.
All right, we have a question from Rich Giesel.
Hi, Jacopo. I was
Rich.
wondering if you could, if you could tell us what we could do to find a poor tack coat layer underneath our new pavement. Is there a way you can look down through the mat in increments and find like the bottom of the new mat where it's supposed to be glued to the old mat and see if there's a defect there? Because we have a lot of trouble with that, with tack being tracked off, especially in the traffic lanes by the haul vehicles.
Yes, I mean, now everything needs testing, so it would be, I prefer always to have something tangible to discuss, right? But definitely you can use the GPR as a standard GPR. So you can go through the data and trace interfaces or highlight certain levels of amplitudes from an interface that you have traced, and then highlight where you can have possible detachments. And you can do that with the same resolution that I was showing in the other pictures. So I think one thing that will be definitely interesting is not only putting the data into a context, which is, you know, an XY context. You recognize geometries which vary laterally, but also to contextualize the readings that you have at a given depth, which starts from 0, with other readings that you get at further depth. So it's all this data for me will be, it's going to be very, very interesting to utilize the entire data cube and extract more information, not only data from data, but information from data. So technically, yes, I think it's something that you can use the system as a, traditionally, let's say, as a 3D GPR to do that. Good thing, again, you can do the two at the same time. So you can take direct measurements and then collect a three-dimensional data cube that you can interpret and slice any way you want.
Okay, well, we're right at the top of the hour here, so thank you very much, Jacopo. And also, I really love to see the hands up and the discussion online, so please keep that up at 2:40 Central Time. We're going to be getting into discussion of ideas for topics, tasks necessary to advance DPS beyond the current work plan. So a lot of discussion then. So good work, online people, and of course in-person people. We'll have more discussion later, but lunchtime for now. So thanks a lot to the vendors. You guys are great and always taking this difficult challenge and sometimes demanding users, and we really appreciate all the hard work all three of you guys are doing on this. So thank you. Lunchtime. All right. It is 1 p.m. Central Time. So I'm going to introduce Fabricio, who's done a lot of instrumental work for the pooled fund here. And he just submitted his final report this year. And we've asked Fabricio to share some of his results, which are obviously very applicable, especially to when we start talking about certification programs like what New York was talking about, and how we can take all this data and put it to use. So, but I'll let you explain the details. All right, thanks, Fabricio.
All right, good afternoon. Yeah, the 12th hour, right after lunch. We'll see how it goes. When I'm teaching that, this is the hour that I have to figure out how to keep students awake. So hopefully I don't have to do that with you guys, right?
If you have to, you have.
All right, all right. So as Kyle mentioned, I was able to participate, and thank you very much, Kyle, Di, and the entire group here for sponsoring this project when I was at ANCAD. I still work, but I'm also doing some consulting work, and we're gonna be moving to Clemson in January. So basically, the study included three main tasks. One was on the effect of thickness and underlying materials. But we're going to focus on the next two topics, the development of equipment and operator certification processes or methods, and determining precision and bias statements. Basically, for every standard practice that we have, we should have an idea of what is the variability in determining those statements. So the unit feedback. Right, I think we're good. So if we have any standard practice, we should have those. And if you're curious about the first topic, which includes the results on the effect of thickness and underlying materials, we have a publication available, and it should be reachable online. But now, let's move on to the proposed laboratory certification programs, which is at the moment is a proposal. And it's also based on what we have heard about inertial profilers. Here, we're talking about density profilers, but eventually you'll see that there are some similarities. And when we were discussing about this, we decided maybe it is a good idea to start thinking about coming with ways to certify operators, certified equipment in similar ways, or at least something that has been done in the past. And it makes sense at that time to go and check what we have in terms of AASHTO R56 or inertial profilers. In this case, we had proposed two programs, one for the laboratory portion, when you compact the box in the lab and you come up with the regression equation. That's going to be the laboratory certification program. And the other one was going to be the field certification portion, providing guidelines and at the end, scores that an operator in equipment have to pass in order to get a certification. But again, at this moment, it's a proposal. We have received some feedback, and we know it's not going to be easy, but at least we're going to have, the framework to start thinking about this. Just to show you what we did in terms of the lab portion, we evaluated two mixes. One was a dense graded, the other one was a coarse graded, 90 millimeter versus 9.5 millimeter. And here you see the pictures of those two, significantly different just by looking at them. And then we created several pucks, basically to generate 4 different air void levels. And you see the results in that table. And of course, you can see the regression equations. For each air void level, we created 3 replicates. And you can see even at that point, we had some variability. So we had also, we provided some analysis, statistical analysis, to also show that, we can have some variance, and you can have some, interesting ranges when you start designing, well, if I only have 3 pucks, are those 3 pucks actually representing that mix? That may be the case. That may not be the case. Sometimes you select 1 puck, but then you generate another at the same level of air voids. They don't are exactly the same, right? So there's some variability just by creating those pucks. In terms of deciding what to do to analyze those results and come up with something that applies to, in my opinion, a high precision equipment like this. We decided to go with some indices that have been used, for instance, when you compare thermometers. We did this with when we were checking the rice equipment, but the manometer. So we have the digitals, and we have the traceable NIST or manual. So we did that within several exercises, and we decided maybe these 3 items, these 3 coefficients can work, or indices. And the first one is the concordance correlation coefficient. And as Chuck mentioned, we want to have something that is gonna provide less than 2%, 2.5% error, or you want to have 97% passing, 97.5. You also have this called total deviation index. And let me go back at the beginning. The first one has to do with having values that are gonna be close to the quality line. If you can see in the top right graph, the total deviation index and the coverage probability are pretty much the same. The difference is that you follow one if you already know what is your range of dielectric value, or if you prefer, you can also just use a probability coverage of 90%, which is typical in statistics. So one is giving us an idea of how close are those values in terms of the identity line. And the other one is the probability for those values to be within that identity. Okay. So with that, we apply that to all those different mixes that we had using 9 sensors. All of them from the same vendor, SSI in this case. And you can see that the plan is to compare them, all of them, in pairs. In this case, you can see that we have the threshold at 0.975 or 97.5%. And the idea is all of them, or at least for the majority of them, to be above that. And that was the case, giving us an indication that these are sensors that are providing very similar results, at least with this index. Then we have this total deviation index, where we found that there was one, maybe two results, when we compare sensors that were not completely in compliance. So we needed to double further investigation on those. But that's what we wanted to see. We don't want to see we have everything perfect. And we were able to identify that those results were part of the 90 millimeter course mix that at some point it was sort of difficult to test when we were running the standard practice. And when you have the one position, then 90 degree and then upside down and so on, those are the ones that gave us more variability during that part. So here is also reflecting. And the next one, as I mentioned, is pretty much the same, but viewing them in terms of probability or in terms of a percent value. In this case, is 0.9 or 90%. And it's going to be exactly the same. The two that didn't pass before are going to show here. So those are the ones that Chuck was mentioning, and you can use that pretty much for any device that I think I don't know if Amindo, they were able to test the height gauge. There's one that they wanted to implement. I don't know if that was the case, but that's one of the good applications of this type of analysis. That you can have several sensors, operators, and have them go through this process. Doesn't have to be all these different mixes, all these different sensors. Whatever you have available in your lab, you can go through this, during the winter time and just check that your sensors are working properly. This also can be used to analyze outliers. In this example, we found that, again, the same 90 millimeter core mix was showing us some of those odd results. And you can see that before and after treating those outliers, everything tended to be in line with in respect to meeting those criteria. So this can also be used as a way to analyze or determine outliers. On the other hand, all the samples that we had were sent out to the FHWA lab and the HODA. They are not here, right, connected? Well, their lab was able to test another 3 or 4 sensors, and they were also able to determine a bias on one of the sensors. Basically, what you see here is the identity line and one sensor compared to the 211 compared to that 194. But that was also done with other 2 sensors, and it was consistently showing that bias in the results. So at that point, what did you do? What is the decision that you do? You apply a bias, or you send it back to the manufacturer to get it, recalibrated or fixed, or, something has to be done. But this can be detected in the lab at some point. So if we go back with the objective of having a certification is not only to have the operators going through this process, knowing what to do, but at the same time detecting and making decisions before taking these sensors to the field. That this bias can be amplified, when you go to the field and provide you even worse results. We develop a web application. At this moment, it is in a free, like a temporarily free server, but hopefully it will move to the main the domain. But the idea is to have enter those results, comparing one or two operators, several sensors, and you will obtain the quality line and those coefficients. And you can also have this part of the outliers treatment that you can also apply. All right. So again, the proposed methodology, if we were to follow with this, is first define the frequency. The recommendation is at least once a year to go through this process. As I mentioned before, maybe during the winter when you're already taking care of all the calibration, all the training for your operators, that's another step that can be done. And you may already have some gyratory samples, from different projects. Just make sure that you have at least three different density levels, ranging from 3 to 10%, and then the operators must test all the samples using at least 2 sensors to have some statistical results, of course. But ideally, you will have all the sensors, not only the one that you have in the lab, but bring all the sensors that you have in the field and go through this process. And you can select 2 of the 3 indicators. As I mentioned, 2 are pretty much the same. And then analyze this in terms of dielectric and determine, for instance, if there are going to be some outliers, investigate if those are in fact outliers, and then adjust accordingly. And as I was mentioned in one of the meetings that we had, again, this can be included in already existing process. In this case, AASHTO R61, that some of you may already be familiar and already applying in your laboratories. Okay. So the next one is the proposed field certification program. And this one is pretty much a copy with a small differences with respect to AASHTO R56 for inertial profilers. The big difference here is that we didn't have a database of profiles compared to when they developed R56. We had to develop in artificial density profiles and come up with a way to generate scores similar to the ones for inertial profilers. And in that case, the difference was that we decided to go with root mean square % error, comparing profiles and comparing the results of those profiles in terms of performance. And what I mean by that is that we generated several thousand profiles, varying ergos, varying distances. So changing all these different parameters that you may encounter in the field, but those are artificial. And then we use AASHTO to determine, using different scenarios, different climatic conditions, different payment structures, to determine what could be the effect in terms of performance. So basically what we have was we selected reference profiles, then we adjusted those using different standard deviations. We created candidate profiles, and all of those were analyzed in AASHTO. So we have responses that are going to be based on ergoids and how those ergoids are going to affect running, tracking, so on and so forth. Right? So based on that information, at the end, we came up with this graph, but most importantly, the scores. You can see that all those different plots running, IRI, cracking, all of them tend to go all the way down to 90-something%. So that basically, what we use that is like the baseline as part of this, defining the scores. The only difference that we did is we needed to change what was the tolerance that we were gonna accept for this. So for instance, for accuracy, we went and decided that a score of 92 is required to meet 10% error and at least 95% of the comparisons. And for repeatability, the score, the operator or the equipment has to meet is 94 to meet 5% error at the same 95% comparisons. So if you check IR56, they also provide you with similar scores, slightly different, but it's the same idea that you have to meet these scores in order for your equipment and operator to be certified. And again, this is going to be a little bit difficult. It's going to take time. The same thing happened with the inertial profiler certification programs. There's one at NCAP, and I took advantage of that. But I knew it took time. And in the country, there are several already, but I mean, not all the states are requiring that type of certification. The reference profile that we recommended here at the beginning was to have a payment, existing payment, change some of the variables that were required, and then basically take course to have a correlation. The only difference is that that section has to be pretty much destroyed at the end. And then sort of that was done in Miro this year, or last year, right? This year, I'm sorry. But they took advantage of the reconstruction process and advantage of having different mixes available. And that means that it can be done. It's going to be difficult, but it can be done. The other alternative is come up with a golden electric equipment that is also in the making, right? So we have alternatives at this point. We also have created an Excel application where basically you're going to have to enter all those profiles, reference profile, candidate profiles, and then the software is going to give you what are the accuracy and repeatability scores. And so here's an example of all the different profiles that were obtained. And at the end, you will have the scores, an average of accuracy and an average for repeatability. And you're required to run 10 times the same number the same number as AASHTO R56 to be consistently in terms of statistics. If you were to go lower, we'll have to recalculate everything and make sure that your scores are going to go according to the number of repetitions. Right? It's like when we go and do percent within limits. And what happens if you take 2 cores versus 4 cores? The statistics are going to be a little bit different, right? It's the same here. So the recommended methodology in this case is define the frequency. This can be done at least once a year. You'll gather all those different devices, and either you have a section that you can take course at the end, or you have a golden standard to go through. Minimum 2 sections of 200 feet. And the idea is to have either different density levels or different asphalt mixtures. The idea is to have variability in terms of the surfaces. And to take 10 profiles. And then we're going to have a reference profile that they can come again either for after you have all the readings. You can determine the reference profile by taking course and using correlations with the electric or another device. Or eventually, if we get that golden standard, that will be better. And you can use the Excel tool to come up with those scores. Something close to profile, but at least I guess trying to reproduce something or do something similar. And what are the potential applications? Well, we are seeing nowadays that there are going to be new devices, or already new devices, because this was done, this study was done only using PSSI sensors. but now we're gonna have more. We have heard about, going, faster, vehicle mounted. So that's gonna be a key. If we want to see if at the high speeds, you're obtaining the same results in terms of those profiles, well, probably gonna have to go through this process. And it can be at some point the case that we may have different technologies that are non-dielectric. I don't know, maybe those gauges that use capacitance, they can get to that point that they can also join the party and go, in terms of profiles. We don't know. There can be other technologies that can also determine density profiles that are non-dielectric based. So those are, in my opinion, those potential applications. Now let's move on to precision and bias statements. As I said before, every standard practice should have this, or at least an idea what is the inherent variability when we do any type of testing. For the lab, again, when we go through that process of compacted samples in the lab and obtaining that regression equation, in this case, we have available 9 sensors. Basically follow ISTM 8691, which it's the one standard that allows us to go through different processes, check different statistic values, and make sure that at the end we're obtaining a representative precision and bias statement. And here are some plots of what they call H and K consistency statistics. The idea is those are going to be based the criteria that you see here in the red dotted lines. Those are the criteria that are whether H values are between those ranges or those criteria, or the K below that criteria. Those are determined based on the number of sensors. But the idea is to meet all. Otherwise, we need to go back and identify what is happening. The H is going to give us an idea of what is happening within the lab, and the K is an idea of what is happening between labs. All right, and at the end, we also need to plot standard deviations versus average of the results. And the table on the right, and that plot is done in case we obtain any trends. That means that the approach that we follow is not quite right. So if we were basing everything on the standard deviation, we probably should move to coefficient of variability or other ways to quantify variability. On the table on the right, you can see the dielectric, the average, maximum, and minimum dielectrics for within lab and between lab. And those are the values that we are going to include in an standard, at least preliminary results. As you can see, 0.445 for within lab and 0.065 for between lab. Those are dielectric values. We went through an exercise and computed or estimated what were those same statements in terms of density. And you can see on average, within lab, it's going to be less than 1 pound per cubic foot and a little over 1 between lab. And if you compare those results to the values shown in the table to the bottom left, these devices are providing us way better results in terms of variability when we try to estimate density, at least in the lab at this moment. Okay, so when you compare that to the typical bulk specific gravity or the core law, we are way better than those to estimate density, which is part of what we have seen. I mean, in my opinion, in terms of that repeatability and just the way the equipment works in terms of having us or providing us with more precise results. The next is the field statements. In this case, everything was done at the NCAP test track last year during the reconstruction period. We only had six sensors. That's the minimum that is required by ISTM 691. But we also had 8 different sections. We wanted to also evaluate if there was going to be some effects on the precision statements. if we were to check just the joints, and we see that was not the case. Here's the photo on the top, on the bottom left. You can see the configuration of the equipment. Basically, we have only two sensors. The idea was to have one sensor going right next to the joint, and the other one in another position closer to the center of the section to evaluate that joint effect. So basically, we had three replicates, three runs with each sensor, and that created all the values that you see on the table on the figure on the right. So when you see the value of N6, that's the section N6, and with the J is at the joint. So at some points, you can see that in some cases, we did observe some differences with the results compared at the joint or with another location. But for the most part, that was not consistent. It was just part of having research done in a controlled environment where quality is observed, in a different way. So probably that's a little bit of bias in what is typically happening in a project. And we also check the same statistical criteria. And basically at the end, we encounter that everything met those different results or different criteria, and we didn't have to adjust anything. We were okay by defining variability in terms of a standard deviation. And at the end, here's the table that shows us what is the within the lab and between lab statements. Slightly higher compared to the lab that was expected. For the electric within the lab, we have 0.07. We have been using 0.06 from the beginning. Then we have also been using 0.08. From experience, when Kyle and his group they were working on this and found out that 0.06, 0.08. So those were the values that we had at the beginning without going through this process. And now we can confirm that, yeah, those made sense at the beginning, now even more. And but we have between lab that's a little bit different. That went up to 0.1 to 2. But that's expected, when we compare different labs and different operators, that's going to change. And when we translate that to density, you see, for within lab, we have 1.4 pretty much, and between lab at 2.3 pounds per cubic foot. So you compare those to nuclear gauge and non-nuclear gauge statements. You can see that, again, we are significantly below, which again, is part of what we have seen in terms of the quality of the equipment and how they tend to provide us with better results. Right? So the proposed methodology in this case, not a proposed methodology, that was the methodology that we followed, is that we needed at least 6 different sensors to come up with the statements. We performed equipment consistency verification on each sensor. And that was the line. We didn't have the fiberglass block at that time. Then we also measured 100 feet of each pavement section to be tested. And all the different checks that were performed during that time. We added one metal plate at the beginning of each section and at the end to make sure that significant spike in the electric was an indication that we were measuring the same starting point and ending point all the time. That's something that can be done. But if you have a very accurate DPS, that's going to be another way to approach this. We wanted to stay away from the joint 6 inches. So we tried to. We had something that was hanging from the edge of the bar, and we placed the sensor 6 inches away from that, and we were carefully watching that thing was hanging was right on top of the joint. of course, it's not easy, but you know, that's the way we had to do with that. And we want at least 2 replicates and just following STM process and determine those statements. Well, where to use this? Well, basically, we already have in the process of, or at least one standard Ashton. If in the future there's going to be an ASTM that can be included. And again, this year, there were some efforts to reproduce this during the construction of Mini Road. And hopefully those statements are going to be updated with those other results. And eventually this can also be used, you know, for control and acceptance. You know, you're going to have these values that are going to allow you to compare what is happening within your own control and acceptance group, and where you're going to use these to compare results from quality control to acceptance. And with that, thank you very much. And I'm including a couple of contact information based on what I'm doing and I'll be doing in the future. Any questions or comments?
I always have questions. So for the CP, the CCC, and the TDI, it looked like the 3/8 versus the 19mm mixes, the data looked different. Had you considered having different criteria for those?
Okay, just to repeat the question. You know, there were different results in terms of the 9.5mm and the 19mm. You know, and we know that those differences could be part of you know, having not only you know, different compaction or gyrations, because those were 2 different mixes from different projects. You know, differences in asphalt. So there are more of the variability that comes from the mix that comes from the testing itself. So I think it's not going to be fair if we start separating criteria based on different materials. If we wanted to try, or at least we try to establish the variability of the test, and try to avoid or not make or not include that variability that's going to come from sampling or just the mix itself.
Yeah, I guess I would have expected more variability with the larger aggregate, right? And so, yeah, I wasn't sure if it made sense to then adjust expectations as far as precision and bias based off of that.
Yeah, those are going to drive. Yeah, I agree. Those are probably going to drive that variability. But that was you know, part of what our thinking at that time. That we wanted, you know, we knew that the majority of agencies are probably only doing dense graded mixes. But we also wanted to have, you know, something different. We're going to go even for with SMA, but we were able to find coarse graded mixes that, you know, at this point, who is paving coarse mixes? Not many states. But yeah, we found that, you know, those are probably going to be driving those statements. But you also want to include, you know, that variability, that range that is going to give you, in case that mix eventually is used. But if you're using dense graded mixes, you're going to be fine.
Regarding your proposed certification module, a 2-part questions. First, when you calculate the cost correlation for the repeatability and accuracy, do you follow some of the procedure under R56? Because I'm a program profile, right? We have 5 procedures. First, filtering to gear to what is useful. For R56, it's II filter. Second, convert slope. In your case, doesn't really apply to. And the third is interpretation to make sure the point by point are matching between each of the profile. And then and then calculate the course correlation. In Proval, we also apply a penalty functions that if you have compensating error from one point to another, you will be penalized. So that I wonder, did you just use the plain course correlation computation, or you have applied the penalty function? Secondly, you have the two criteria, one for repeatability for 92%, 94%, that based on your ME simulation, right? Based on the density from your simulated dielectric profile. Do you assume that perfect dielectric to density conversion?
Yes, well, for the first question, basically, we started considering a course correlation, but we ended up going in a different route. We did a program in Excel, a way to match, at every foot, you have to match the reference and candidate profiles. So that is incorporated. And then we went with something relatively simple, just basically this root mean square error to come up with what is going to be the score. So as I said, we started with post correlation. We found that it wasn't going to work with our purposes, but we decided to simplify that a little bit. And that's the route that we follow. But yeah, it is incorporated that part of where you're gonna have to match every point to make sure that you're comparing apples to apples, or at least every single location. In the second part, let's see.
92 and 94%.
The scores. Yeah, the scores. That's basically. That doesn't include any penalty, or as you mentioned. But it's basically on one of those different performance criteria or different performance results. That they have to, depending on what is the variability from candidates to reference, or when you compare two different profiles, that difference in terms of airboats was the one used to estimate what is going to be the effect on flooding or on cracking. So it was, in terms of airboats, measuring the field, or not measuring the field, simulated, and then estimate performance based on for instance, if your target was 7, but that was your reference, but your candidate was 8%. So what was the decrease in performance? And those scores consider that effect in performance.
Just quickly follow up. When you started in the future, when this actually implemented, any equipment may have 2 or 3 and maybe multiple sensors. Are these criteria going to had to be passed for every sensors, or average of the sensor, or what's your vision?
I think it has to be on every sensor. We already observed that there can be some bias in the sensors. So ideally, like with inertial profilers, you have to make.
Yeah, the people.
Yes.
Excellent.
All right, great discussion, and some of it might spill over into our discussion at the end. I know that first question got me thinking about what Bryce was talking about, and actually Brian from Caterpillar, about project selection for DPS, and some of those statistical results for the different types of mix might inform our selection process. So Professor Josias is going to bless us with an amazing presentation here. She said, guaranteed the best presentation you've ever heard in your life. No, it's getting.
Wait a minute,
No, I'm lowering it now. So, but anyway, it's getting towards the end of the 2-day session, and when we were putting together the agenda, we were worried about maybe a little bit of drop in energy here. That's why we put Joe here because she is going to blow you away. But UNH has been outstanding help during the pooled fund. So while I pull up the presentation here.
There we go. That looks right.
Looks correct.
All right, thanks, Kyle. So what I'm going to go through today is a little bit on a couple different projects, efforts that we've been working on at UNH. And just an outline of what we're going to go through. The first is the NCHRP IDEA project that has focused on the lab dielectric system. And then I'll go through an overview of some of the work that we've been doing with the DPS data and developing the tool for doing some of the analysis. And then I do have a couple of questions that I'm going to have you think about. We'll save the actual feedback for the end because I think that works a little bit better with the schedule. And then I'm just going to go quickly through some of the next steps that we've got for each of those different efforts. So for the LDMS, I think most folks are familiar with the lab dielectric system and the intent in terms of what we were doing with the NCHRP IDEA project is really looking at replacing the current AASHTO procedure for determining bulk specific gravity with the LDMS equipment. And so again, the objectives for what we covered in the IDEA project were to look at the impact of specimen geometry in terms of height, the different asphalt mixture variabilities, and the surface conditions on the measured dielectric value. Looking at repeatability, okay, of those measured values in the lab, and then also refine the calibration procedure and methodology for the actual laboratory measurement. Okay, and then that was kind of part of the phase one. Phase two was really looking at how do we establish the relationship between the laboratory measured dielectric value and laboratory bulk specific gravity. Okay, and then all of this, we've got a draft AASHTO test specification for the actual measurement. That's part of the final report for the project. The project officially ends at the end of this month. So the draft report is under NCHRP review right now and should be available whenever ERB gets around to publishing. So for the project, we selected materials that had as wide a range of aggregate geology as we could from across the country. You can see we've got representatives from a lot of the pool fund states as part of this, and that was intentional to help leverage some of the work that's being done under the pool fund as well. We've got mixes that went from 4.75 to 37.5-inch nominal max size, some virgin mixes, some mixes with wrap, and a range of binder grades. So we had a total number of 16 mixtures that we sampled for this effort. In terms of what we evaluated, so we broke it down into a shorter subset or a smaller subset of the mixes where we did a density study with a lot of different specimens, a lot of different range of densities from 1% air voids all the way up to 15% air voids. And that focused on just on one size, just typical mixed design size, height, 120 millimeter height specimen. Then we also looked at our geometry, varying the heights from 100 up to 180 millimeters, and then also looked at the impact of compacted faces versus cut faces. Okay, and in terms of the repeatability, Adam, what are you doing back there?
You needed a challenge.
So in terms of evaluating the repeatability, we're looking at and establishing the laboratory measurement protocol. How many measurements, replicate measurements do you need to take? How do you need to orient the specimen when you're taking these measurements? Does it need to be just on, one orientation? Do you need to rotate it? Do you need to flip it? And so with that, looking at the repeatability, okay, we had An, who is our graduate student that's been working on this. In that study, he was making 160 measurements on each puck, okay, at different orientations, repeated measurements at each of those orientations, flipping it up, back up. So we had the data to be able to do the statistical analysis that we wanted to do to figure this out. Okay, this shows you an average values for all of the different tests that were done. So you can see all the different mixtures that we evaluated and the bulk specific gravity versus the average dielectric value for the average values from each of those specimens. So you can see that pretty clearly we've got a linear relationship, okay, for each of the mix. Okay, fairly similar slopes, okay, but very different values in terms of the dielectric. Okay, and this really depends on the geology, the dielectric of the aggregate that you've got. We did find that as your bulk specific gravity decreases or as your air voids increase, the variability of the dielectric measurement does increase. Okay, so you've got more, and again, this is using the time of flight method. So it makes sense as you've got more air voids, there's more kind of different potential paths. So you've got more variability in those measurements. Okay, surface conditions. Okay, again, we went from the finest mix, okay, to the coarsest mix. Didn't have an impact, okay, from a statistical perspective on the measurement variability. Okay, and again, this is time of flight method. Okay. All right, so with all of that and all the statistical analysis that was done, you can read the report if you want all of those details, but we did a lot of different things in terms of looking at how we defined the repeatability and the variability. But really what it came down to is the recommended protocol is to take 3 measurements, okay, at any 3 orientations that are about 120 degrees apart. And that gets you a dielectric constant that is statistically equal to those 160 measurements.
You could still do 160.
You can still do 160 if you want, which you don't have to. You only have to do 3. And then in terms of the protocol, I know you can't really read this, so I'll just talk through it. But really, you'll take those three measurements and look at the range of those measurements. Okay, if they're within 0.02, okay, you just average those. Okay, if they're the max and the min are outside of that threshold, okay, then we've got a process for, okay, identify which one's outside the range, repeat that one, okay, go back through and look at the average, okay, or okay, the worst case scenario is you do another 3, okay, and then you take those 6, throw away, trim them, okay, get rid of the highest, get rid of the lowest, and average those 4, okay, and that comes out to, again, a representative dielectric value. Okay, so we've got that procedure, and that's all outlined in the AASHTO draft procedure. Okay, then the next step, okay, was really looking at correlating the dielectric constant with your bulk specific gravity. Okay, now it's not, can't have a single relationship because we saw all the different values for the different aggregate mineralogies, right? So we have to do something where you've got some information on that aggregate, you know, those aggregates. Okay, so the way this worked, at least again, and this was, started working on this about a year ago on this part of the effort. So some of the stuff that Roger presented a little bit earlier supersedes this. But really what we're doing here is taking those component materials. So we actually measured the dielectric of compacted aggregates, okay, and the dielectric of the binder, which doesn't change very much, and then used a mixing model, okay, to get the dielectric of the components, okay, and then using the Haitian-Strickman model that, again, that Roger presented, okay, and going to the maximum theoretical using that 0% air voids. Okay, again, he did a great job explaining it, but really you can get at that correlation between the dielectric, okay, and your bulk specific gravity. Okay, but it does require that you do dielectric measurements on the aggregates, okay, at least the approach that we started with here. Okay, and you can see we did this for 3 of the different mixtures. The 3 mixtures we chose were Connecticut, Mass, and New Hampshire, partially, okay, because it was easy for us to get the materials to be able to do this. Also partially because they actually represented the range of those dielectrics pretty well. We did get Virginia materials, but unfortunately with the production, Virginia materials arrived in October, so they didn't end up making it into the final report. They're in the process. We're doing the testing now. But you can see for two of the mixtures, for the New Hampshire and the Maine mixes, we have a really good agreement between the measured the measured bulk specific gravity and the bulk specific gravity calculated from, predicted from the dielectric measurements, okay, using the models and using the approach. Okay, the one Connecticut, okay, that one was a little bit outside, and what I'm showing here is we've got the line of equality, but then I've also got the dashed lines represent the allowable variation in the AASHTO T 331. Okay, so you have an idea of how those line up with precision that we're used to dealing with now. Connecticut was a little outside of it, but we did find that Connecticut, when we're using the model that takes the component materials, okay, and gives us our mixing, okay, Connecticut we had some issues with. It worked really well for Maine and New Hampshire, not so well for the Connecticut materials. At this point, we don't really know why. Okay, so that's something that we've got to look into a little bit. But this, in combination with modifying the approach that Roger was talking about a little bit, are some of the next steps that we're thinking about in terms of an easier, simpler way of getting from the dielectric to the bulk specific gravity. All right, so that's kind of a quick summary of the IDEA project. Then I'm going to go through an overview of what we've been doing with the pool fund data. Okay. And first of all, just kind of going through the objectives, okay, for the work that UNH is doing, is going through and reviewing the data and analysis to propose any kind of changes that might be needed to the current protocols. Okay, so this is for routine implementation as a QA tool. Okay, so we're looking at developing a master database, okay, with both field and lab measurements. Okay, refining the protocol for determining the relationship between dielectric and density. Okay, changes potentially to field measurement protocols for sensor bias and data variability. And then also developing a data processing tool, okay, to process that field measured data, okay, that's gathered using the DPS equipment. Okay, and then develop materials for implementation. So the tasks, and I've got these color coded, anything in green is something that's either we're currently working on or has been completed. Okay, so we've got all the data and have the database developed and have gone through the process within the database of doing the data quality checks and doing the statistical checks, doing the outlier analysis using the tool that's been developed, and I'll talk about that in a minute. Okay, and then we're looking at evaluation of the sensor bias. Okay, so developing acceptance criteria, and this is some of what I want some feedback on, of what kind of statistical measures folks are interested in, because we do have the capability of incorporating different types of measurements in the tool, okay, in terms of the statistical testing and statistical measures that we're using, and then taking that data from the SWIRB, transverse, and other strategies in terms of how do we determine if there is bias and what you need to do potentially to correct for it. With the new developments, we've done an amendment for this. We're also going to be looking at the use of a standard material, so the fiberglass block. Okay, and then all of these are going to inform the field measurement protocols. Also, again, looking at the correlations between lab and fields. And again, initially when we started this, okay, field is using the surface reflection. Lab, we were focusing on the time of flight, but now we've got also, we're going to be looking at the lab version of the surface reflection, see what makes the most sense to use for that correlation. Looking at different levels of analysis in terms of a specimen level, lot, project, however you want to break it up. And again, with the modifications are all those in orange, okay, really trying to figure out what's the aerial domain in the field that corresponds to that core location, okay, using all the DPS information, okay. what makes sense again from a statistical perspective. And then looking at the protocols on the laboratory procedures. And again, a lot of this is leveraging what we've been doing in the NCHRP idea study. And then also looking at data variability, okay, taking the data that we've got, starting to identify what are the variables, okay, that can cause any kind of systematic differences that we might measure, figure out what we might need to, how we might need to categorize our measurements or how we're doing the measurements, identify in terms of the process that we're using, what's the appropriate statistical analysis to use, you know, to figuring out the extent of coverage. And again, a lot of this leads back into a lot of the conversation that was happening earlier this morning. Figure out how that areas are varying in terms of density longitudinally as well as across the width of the lane, and how often do we need to do those accuracy checks. Okay, and then also developing this data processing tool, okay, and then finally the draft specifications, implementation tools. So a little bit more on the data processing tool. Okay, so this has data pre-processing. Okay, some of it you have to do it outside of the tool, the way things are set up now. But again, with some of the conversation that's happened today and some of the advancements that would be made, a lot of this pre-processing probably is going to be either eliminated completely or greatly simplified. But we're dealing with what we've got right now. Looking at data validation, so identifying outliers, okay, analysis of the data from the sense of variability and measurement variability. Okay, and then finally developing acceptance criteria. So the data pre-processing, right now with the files that come from PageScan, there's two different ways that you can take that data, okay, and put it into a form that then can be used in the tool. Okay, so depending on your preference, okay, and how comfortable you are with certain types of manipulation of different files, okay, there's different ways you can do that. This flowchart just kind of steps you through the different ways that you can get the data from the PageScan, okay, to the form that's required to put into the processing. In terms of, and again, the pre-processing step, okay, it can be adjusted, okay, depending on the format of the exported data, okay, by each of the agencies. And the users can also, there's some flexibility in terms of how many sensors, okay, that are being used. So we're trying to build in the flexibility, okay, in the tool as well. So the tool itself, okay, there's a summary of basic statistics, okay, shows you some of the distribution plots. Okay, you also get plots of your dielectric versus lateral distance, plots of the dielectric versus longitudinal distance. Okay, so it gives you a nice kind of overall snapshot of the data that you're putting in, what it looks like. Okay, that also goes through the process of separating out any missing values or invalid values. So it'll go through and identify if you've got missing cells, okay, identify if you've got values that are not reasonable for dielectric measurement, okay, and it also will, you know, with your latitude and longitude, it'll identify values that are outside your area for your project. So, okay, if you're in Connecticut, your latitude and longitude for your data says you're in Nebraska, it identifies those as an issue. Okay, the process of identifying outliers, we're using in the software, the tool right now, we're using the quantile range measurement. So based on the distribution of your data, okay, and again, the user can define which quantiles, okay, you want to use or how you want to define your tail quantiles. The example that I've got here uses 25%. So it identifies your lower tail value, okay, your upper tail value, which would then be at 75%. Okay, it figures out what's the range, right, of those values, and then it establishes thresholds for identifying those outliers based on the range and that Q multiplier, which again, the user has an option to input. Okay, so this process identifies those thresholds for the outliers, okay, and then it goes through your data and tells you how many outliers you have, okay, and it's got the representative percentage, okay, of those outliers of all of your data points. Okay, so this is just showing an example for different days of data collection. You can also do the sensor variability check. Okay, and in this case, this is showing an example when there's 3 sensors. Okay, so if you look at the plot down here, okay, in the lower left, okay, you can see it's hard to see from the projection, but on the left, it's got the average value from the first sensor. The next point is the average value from the second sensor, then the third sensor, okay, and then the next point is the average value from sensors 1 and 2, sensors 2 and 3, sensors 1 and 3, and then all 3 sensors. Okay, so again, using the statistics, and in this case, it's set up to use mean and standard deviation. It will identify, okay, if there's variability from that statistical standpoint, okay, between different sensors, and it highlights in red. Okay, there's also longitudinal measurement variability. Okay, very similar in terms of how it works. Okay, to the sensor variability, using average and standard deviation as the criteria. Okay, oh, and I forgot to mention before, you can do the sensor variability based on dielectric value or percent compaction. It's got the functionality to do either one. Okay, and then you can also do the longitudinal by either your file names, depending on how you've done it, okay, or if you've got them combined by your stationing. Okay, and then you specify kind of how you want that broken up. Okay, for feedback, and again, I just want you to think about this while I just go through the last few on what we're working on next. Okay, but really want input for this tool. What kind of functionality are you looking for? Okay, what kind of analysis is of interest? What do you need? Okay, what type of statistical measures are you interested in? And we focused on certain statistical measures, but certainly we can build different additional functionality into the tool based on what you as the users are looking for. So think about that for a couple minutes. Next steps for the lab dielectric. Okay, we're going to be going back and looking at doing a little bit more digging into those current models. Okay, for doing the correlation between the lab dielectric, okay, and bulk specific gravity. Okay, trying to alleviate some of those shortcomings that we saw with some of the data, and trying to get rid of that need to measure the component materials, because we saw some of that didn't work so well. Also really looking at trying to dig in a little bit more in terms of the contribution of the component materials to the overall dielectric regimen. So one of the things that we ran into when we were doing this analysis and looking at how do we take that dielectric value and determine the bulk specific gravity, when you've got RAP, okay, how do you characterize that from the dielectric standpoint? Because that RAP is its own kind of component, okay? It's not necessarily the same mineralogy, same aggregates, okay, as what you've got in the new mix. So how do you deal with it? Okay, so we've got to work on dealing with that a little bit more. But again, if we can move away of the need for measuring that dielectrics and the component materials, that will be helpful. And then also we'll be looking at some of the machine learning methods. Okay, so the current models, okay, they're models. Okay, so let's use some of the technology that we have and look at some of the machine learning methods as well. And then again, as I mentioned, okay, all the lab work, okay, was based on the time of flight. Okay, we're also going to be looking at the surface reflection method. Okay, and then finally, looking at thinner specimens. Okay, so going to, we'll probably be wanting to do field cores. Okay, and then also if we're using this as a laboratory procedure, going away from just 6-inch diameter, looking at different diameters as well. And then in terms of our next steps, you saw the overall task, but in terms of what we're immediately looking on at incorporating next is whatever feedback we get from this group in terms of the tool, okay, and then update the tool and the instruction guide, okay, for using the tool based on that. Analysis to correlate the fields of the surface reflection, okay, to the time of flight and the surface reflection measurements in the lab. Okay, and then also looking at core densities, okay, and what we're talking about in terms of the coverage, okay, for the dielectric and that core density distribution that's needed. So those are kind of our immediate next steps for what we're doing with that's directly related to the report. And with that, thanks for your attention. I think I kept most everybody out.
Well, if you would have lights off for a little bit.
I'm trying to help you.
Do we have any questions?
Questions, comments? Yeah.
Just a comment in terms of,
Just for the people online, evidently it's easier for them.
Online people feedback for you.
Yeah, but somehow it helps to have a microphone.
just a comment in terms of what you mentioned about quantifying all the components and how that's going to affect the specific gravity. I think it's going to be even more important when you have now all these additives, like you have ground tire roller, fibers, recycled plastic, all those, you know, and we keep adding more and more of those to the mix. So I guess that's going to be a challenge.
Yeah, it is. Yeah, that's why we're hoping to try to get away from the need for measuring component materials.
Both measurements are good.
Yep.
Great presentation, Joe. This is actually a question for you and Roger and Chuck. For the outlier, I'm always very careful to get rid of outlier. For a very well calibrated system, certified operator, you collect the DPS data, and how can you see eye to eye to agree on to determine what part of the DPS data is outlier?
So I guess from our perspective, in terms of the data analysis, we're looking at it purely from a statistical analysis.
I may add also that there are reasonable boundaries. So if you have a calibration and you get a value over 100% compaction, no way. Anything less than 80, no way. So there are outer boundaries. Then there's a reasonable boundary. So it's a little fuzzy in my mind right now.
Chuck? Are you happy with 25%, 75% quintile?
That's my answer.
Chuck doesn't have anything to add other than looking at quantile.
And again, the quantiles, you can, I mean, in terms of the tool, the user can define what those are. Okay? And again, the values that are the defaults in the tool right now are those that, you know, are kind of commonly used for statistical analysis, but you've got the flexibility to change those however you're comfortable.
So maybe I misunderstood this, but you broke down the specific compositions of minerals of the aggregates from.
No, we took the say different aggregate stockpiles and did the dielectric measurement on each individual aggregate stockpile. We did the dielectric measurement on binder.
Oh, so, okay. Did you use a vacuum? How do you do that?
So just, it's an acrylic mold that we used. Okay, and then, so it's a 6-inch diameter acrylic mold that was, what, I think it's it was 5 inches, 5 or 6 inches deep. I'd have to go back. I don't have any pictures in here. But then you just do the compacted, okay? Do the dielectric measurement on that sample in the acrylic mold. Yeah, same procedure you use for the bits. Okay, you just compact a specimen of your aggregate. Do the same measurement.
Yeah, I was just curious because obviously the air voids would be quite a bit higher, right? So how you calculate?
Right, so using the model that Roger presented, where you can go from so using, we know it's a known volume, Okay, so we can measure the air voids. And then you can then determine what the dielectric is at 0% air voids, which would be the solid material. And then we use that in the component mix.
So in reality, if we can break that down from a mix design and eliminate air or know the composition of this, is there a way to use that in making sure that with mix changes in the plant that we're in limits?
Yeah. Yeah.
Because limits with the plant or plant changes, if we know that this specific mix design is supposed to be this percent, this, and we know the dielectrics of these and they fall out, it's kind of a flag that we.
Yeah, if they're different enough.
Outlier.
Yeah, I think you can do that if they're different enough in terms of the dielectric of the different components.
And I think it benefit too on the dent or the coarse graded mixes too, where you might struggle with larger aggregates or have those issues if you could break that down and use it a little bit more. That's just an idea.
Yeah, no, there are other applications for this as well, absolutely. And I mean, you can also, play around with different mix proportions too.
I guess a comment that particularly with balance, balance mix designs, where many states are looking to utilize them to increase their portion of RAP in conjunction with perhaps other additives. Looking at it cumulatively from a specific gravity or dielectric, I think it makes a lot more sense.
Yeah.
Otherwise, it's just going to be that much more challenging than trying to go out the thresholds for where RAP influences or other additives influence the results. It seems like a never-ending cycle otherwise.
Yeah, exactly.
So, sorry. My brain's just turning right now. Sorry. It's after lunch. It's okay.
So the AC content really doesn't produce the most volatility. It's the aggregates, right, that we're finding?
I'm sorry.
The biggest changes is the aggregate, the mineral.
Oh, yeah, by far. Yeah, because if you, even a range of different asphalt binders, the dielectric varies very little with the asphalt material. It's the aggregates that are going to change your dielectric value and shift it. Okay. If you go back and look at that.
Okay, go ahead, Monica.
I just wanted to add, maybe this could be a good place also to collaborate with the NDE lab, since now our next steps with the MATSI and the NDE lab is to look at aggregate and gradation and all that. So there's opportunity there for collaboration with FHWA.
Absolutely.
Thank you. Monica, I'm glad that you brought this up. I just sent an email to Ishan, Joe, and like several people at UNH and asked for meetings because the objective of this research project is very similar to what we're trying to do at the NDE lab. So it would be great to meet and chat.
Sure, sounds great.
Perfect.
Okay, Brian, do you have your hand up?
It doesn't want to talk anymore. Two questions, Joe, I had for you. One, you mentioned towards the beginning that you had the relationship between bulk specific gravity and dielectric constant values were basically linear and similar slope. Are they similar in slope enough that you could do maybe one measurement, identify which curve you're on, and then predict the rest of those values? Is that close enough? And then the second question I had was, did you look at the number of specimens you needed to be able to, the number of replicates you needed in each density value to come up with that relationship?
So first question, that's some of the analysis that we're looking to do next in terms of the slope. So do you need just one point or do you need multiple points, okay, to define that relationship between dielectric and bulk specific gravity? And again, some of the models that we're using, I think we can probably not have to do like 4 or 5 different points, whether it's 1 point or 2, or if there's another way that we can get at it. That's what it's looking like. The slopes here, again, it can be somewhat deceptive, again, depending on how you plot the data and how many points you actually have. But they're pretty consistent, but we still need to do that analysis in terms of, okay, if you're just assuming everything is the same slope, okay, really, how much error might you have? So to be determined.
And the other questions on the number of replicates each is.
Yeah, and I think same thing. Yeah, how many replicates do you need to define that relationship?
The only thing I would add to that question is, unfortunately, I don't know if we can trust that the slope of the puck measured, velocity-based dielectric to air void relationship from the pucks match what we see in the field. So do you have any thoughts on that?
Work is needed. But that's actually exactly that thing, that's one of the things that we are looking at with the analysis that we're doing with the pool fund, is because, with the lab dielectric, with the NCHRP project, we didn't necessarily have a lot of the field data with it. We have some of it, but then with the data that we've got now with this project, we'll be able to do a lot more with, okay, how different are those, and are they, is it different for each mix or not? So we just don't know yet, because we haven't had a chance to look at the data.
It hasn't been said yet, but to me it seems obvious. But for some of these mixes, the slope is different than other slopes. And with 160 measurements per specimen, I'm hoping that you also have the mix design, so you know that within the mix, what the proportion is of mixed material types. Because I'm sure that not all these mixes have 100% trap rock all from the same quarry, and that you have some that have a combination of maybe 3 or 4 different type materials.
Yeah, absolutely. And we didn't get to that level of granularity in terms of breaking these results down. And just so you know, not every single point on here is 160 measurements. It's a subset of those mixes that were 160 measurements, because we weren't going to do that for 16 different mixes. we did that for a handful of mixes to establish the procedure, and then took that procedure, and a lot of the forward data that we're collecting was only 3 measurements. So.
And when you get down to that level of granularity, maybe you'll be able to answer that question about outliers that George keeps on bringing up.
Well, and with the components, okay, doing the testing on the component materials, we do have each stockpile. Okay, so we do have the information on the variability of each stockpile. But again, we only have a handful of mixes that we were able to gather that information for. So that's why, we're looking at doing a follow-on NCHRP idea project with this to take the additional steps forward that it needs for the lab itself. Never mind correlating with what's happening with the DPS, but just for the lab dielectric.
Well, I think that brings up another subject on whether there is how many levels of interaction we need to look at. And one is the variability within a single stockpile of a single material versus the variability between changing the proportions of sand or chips, polish aggregate to the non-polish aggregate in a particular mix to take care of other specification requirements.
Yeah, no, absolutely.
Thank God for graduate students.
Yeah, we need some more of them.
We need more like a student.
Joe, if you have the components, why couldn't you do them on auto simulation?
Oh, we can.
And
we
answer
can.
the question, answer the question
Yes.
as the bin changes.
Yeah. Oh, absolutely. Yeah, we can. We just haven't.
All right, I'll be the good guy and send us to a break. Although you're creatures of habit and we've given you 15-minute breaks, it's 10 minutes. It's our last one.
And then we're gonna come and we're gonna end strong here after we come back at 2:30 PM. So we'll see you all back.
9 minutes.
9 minutes. If you didn't have questions about outliers, you would have had 6 minutes.
And Kyle, if you have a minute, I know you want to take a break as well. I'd like to touch base with you briefly about our next session.
Okay, sounds good. I'll touch base with you.
Okay.
All those
On the same stuff.
And then. Separate. But. So then when they're getting those border.
Yeah, exactly. Right, right.
Or even the business.
Yeah, exactly.
Just like.
Yeah, exactly. And good operator. Anyway, real world planning is.
I don't remember what we did that way.
Maybe understand what you're saying.
No, that's actual.
That was that compactor box or was that course? Because we didn't see any.
Let's, I guess, take that.
Well, I'll get to yeah, sorry.
Just like you would. This is the source, what you can expect. I agree. I think it's just one of those things like.
To a certain extent.
Sometimes think that they're trying to solve decades worth of problems. I thought we were getting a lot of variability.
There's like another. It's trying to do the system destroyers.
Oh, yes. Certainly, you're not going to get the same
My new gauge thing's like I couldn't.
Okay, time is up, everyone. You can continue discussions, but you gotta come back to your seat.
I know. I think that microphone. Yeah.
All right. I don't know if this is on or not, it doesn't matter.
Yeah, let's talk about it.
Okay.
We are to the portion of our agenda. If you thought that Joe was really gonna get our energy going here at the end of the session, I have Brian here for you, and it's gonna be even, what, three orders of magnitude more energy than Joe brought? Oh, I can't even hear you, so obviously the answer is no.
Okay, challenge.
No, still can't hear you, Brian.
How many you testing? No volume.
Oh, maybe it's on our end. I bet you it's on our end.
Well, it was okay before the break.
Can somebody else who's joining us from online try to talk?
Can you hear us?
Yeah, yeah. We can hear everybody but Brian.
Reboot.
Might have to reboot, Brian.
Oh, I've got to do tap dancing.
No tap dancing, sorry. We're just saving the technical difficulties for the very end. Here's the moment of truth.
Any better?
Yes.
All right, great. Well, that was a little inauspicious, but we're going to turn it around.
You brought the adrenaline up, so you did the job. Nice work.
Oh my gosh, yeah. Well, my adrenaline anyway. What another great day. And for those who were in attendance yesterday, you all saw these questions that we put up on the screen. And just to give a little preview of just how this last session, how Kyle and I envision this going. A lot of what we touched on during the day one brainstorming session was discussed in some detail today already in session 2. And we hit on some other things as well. What we would like to do with the remaining amount of time is have this be a somewhat interactive session with some thoughts on maybe crystallizing some of what we discussed as a group over the last 2 days and doing a bit of prioritization with an eye on next year and potentially an eye on what might happen in future years. So as we talked about the various things that were put up in the brainstorming session, thought a bit about what maybe could be communicated now, what needs to be discussed more potentially in a technical working group or outside of those groups, and what might be a research need for next year or for beyond 2023. And then as well, there may be some items that just aren't ready to be addressed or might not even be within the scope of this group. The two things that I think potentially this group could really make some progress with right now as a way to put a bow on this meeting is to think about things that are ready to go out based on what we heard and discussed, in terms of communication efforts. And that might either be things like monthly webinars were discussed, or various topics for 2-page communication briefs. And those were included in our brainstorming topics. And I think the other thing that maybe we can try to refine would be research needs with no limit on what the time frame might be, but just putting out there is, you know, what from a research standpoint is standing between where we are today and what needs to happen to get DPS to being the tool that the different stakeholders want it to be. And if we can get those two lists, well, we'll then really make it into even more of an interactive session. We're just going to be doing a little bit of online polling using Mentimeter, where folks will have a chance to identify what they look at as their priority items, both in the communication category and in the research category, and see what bubbles to the top as those most critical items. And then maybe the last thing we'll do from a polling standpoint, and this is not any sort of idea in terms of anyone committing to anything, but trying to get the temperature in the room on whether it looks like this pool fund is something that should go on beyond 2023. That would mean another phase of the pool fund, because there are a number of steps that need to happen. That's something that the wheels need to be put in motion before the end of 23 for that to continue without too much of a gap or no gap at all. So that might just be a kind of a straw poll, put it that way, that we might take at the end. Kyle, does that pretty well cover what you and I had discussed? And just are people nodding their heads or shaking their fists at you? Does that seem like a reasonable way to close out this session?
Unfortunately, I was looking at you instead of the heads, whether or not
All
they're
right.
nodding.
Well, are they frowning or smiling?
Smiling, nervous
Oh,
smile, thumbs
great.
up. Yeah, I think we're good. So let's move forward with that.
Okay, great. You know what, Kyle, I think I'm going to change my mind on this. We had talked about sharing your screen, but I think I'm going to share my screen instead. But have you typed?
Say that.
But have you? I mean, I still might have you type into this document with me.
That works.
Just so the folks online know, I am a mechanical engineer by background, so some of this stuff is very familiar to me, and some I've worked in transportation for 15 years and have learned quite a bit about road construction, but it's not my area of formal training. So I do count on Kyle and the rest of you folks to correct me with some of these technical details. So let me go ahead and share my screen.
It's not a shy group. You don't have to worry about them correcting you, Brian.
Oh, well, that's good. And hopefully you can see day 2 topics in brainstorming.
Yes. Yes, we can.
Okay. And again, I just was keying in on things that maybe caught my eye, which again, I don't consider myself a stakeholder the way all the folks around the table are. And this is just to add on to things that were talked about yesterday. And clearly, you know, we've been talking for 4 or 5 hours. Many more things than these were talked about. But I certainly welcome the opportunity to have people continue to throw things up on the wall to make sure that comments or questions or concerns that maybe weren't captured in this main brainstorming document yesterday get captured today. And actually, Kyle, I'm going to have you, starting with the top of day 2 there, start going down that list.
Okay.
And you can type right into this, Kyle.
Okay, sounds good. So I'm thinking rather than going through each one of these bullets, Brian, I think it's a good idea to allow everybody a chance first to give a statement as to if there's something that throughout these last 2 days, you said this is something that, in my opinion, is absolutely critical, and it's going to continue to be critical into the future as something that a group like this could accomplish. I would speak up now, and a lot of it might just come out organically, but I will lead by example and give my contribution first. I guess generally speaking, not to get too philosophical, but it became clear to me, thinking about DPS in comparison to some other tools that Minnesota's implemented already, and some other states, I think it's further along right now than DPS. I'm thinking about a lot of the comments that Caterpillar, Brian and Todd made about an industry perspective on these technologies, and how, at least in Minnesota, I've been using IC and PMTP as almost a one-to-one template of how we get to implementation for DPS. I think right now, what's different is that in order for us to collect the data, not to oversimplify what's being done with IC and PMTP, but it is mounted to a piece of equipment that is already part of the paving process. And, Bryce showed that picture of DPS being mounted to the equipment, but that's just not the reality that we're in right now with DPS. So in my opinion, what crystallized these last 2 days for me is that, well, first of all, I need to plug in my battery. My laptop's running out of steam, but is that I like what New York is doing in terms of getting consultants trained in to collect data. So Rich has a lot of experience, and he brings a lot of good insight from somebody who's collected in the field and overseeing people collecting in the field from a consultant perspective. At Minnesota, we're more training contractors, and that's worked pretty well for IC and thermal. I'm not sure we can just go directly to that for DPS, at least currently. And I think in some sense, it made me think, okay, do we need to develop like regional certified consultants who that's something that they know, if they specialize in this, there's a demand for them to collect this data. And it's not just something where I'd love to get Rich's perspective about kind of what are the things that would be needed in terms of how we organize it and how comfortable you are with being able to fulfill these data collection needs that we have. Is there something this group could do in terms of a roadmap that would help consultants to say, yeah, I'm going to invest in training in a certain amount of personnel, and then the various regions would have well-defined criteria that says, this is successful data collection. This is what successful data collection looks like. And then you have a target to hit, So right now, just getting quality data, whatever that means for the different states, is a huge challenge. So how do we attack that challenge as a group? Because we have really good equipment. The vendors are putting out really good equipment, and we have a huge need. Agencies love the data, but getting that data is a difficult thing, right now. So that's where I would just throw out to the group. Does it seem like a good idea to do something through this user group to encourage and develop expertise, not necessarily in agencies and contractors, which we will do, but also in consultants? And is that the right way to go for data collection for DPS or not? So I would just open that up for thoughts. If that's a terrible idea, speak up. Or if it's a good idea, speak up.
Well, Kyle, I would just mention that, you're basically training me at this point. So, I relied heavily on Minnesota DOT's website initially, along with training from GSSI, but having that ability to be a member of this full fund study and participate in meetings has been extraordinarily helpful. So, as a group, what I would like to see is the development of kind of what you guys are doing in Minnesota, Kyle, a kind of a comprehensive manual on how this whole process works from start to finish. Including the mixed design module, laboratory scanning, all the way up through collecting the data, producing the reports and doing the analysis. Heavily on the testing as opposed to the analysis, but I think a little bit of the analysis would be helpful. I know I've spent many years working in the inertial profiling business, and with that group, the Road Profiler User Group, RPUG, also extraordinarily helpful in the industry and explaining things. And one of the best documents that was not part of that group, but promoted by that group, was the Little Book of Profiling. I'm sure many people are familiar with.
The same page.
And, if this group could produce a document analogous to that, I think that would go a long way in promoting this technology and getting more people to adapt it. And again, it's got to be reduced to a more basic level. A lot of people who will be using this equipment are not going to be PhDs or PEs. They're going to be regular blue collar folk like myself. So I'm not saying dumb down, but presenting in such a way that it's not incredibly overwhelming. It's not incredibly complex, not to cover over some of the complexity, but to present it in such a way to make it feasible to the average user. And I think at this point, we're getting there. I'm really excited to see the development of the lab scan kit. I'm excited about this fiberglass, which apparently is going to resolve some of the issues I've been having. And I'm excited to see those tools from UNH to help assess the data that we're collecting. As manager of our technical services division, one of my problems, again, has been working with the field technicians in remote contact. They have issues. And then getting, a day's worth of bad data, which, I am unable remotely to correct once it's been exported without access to that cave scan tablet. So as I've been speaking to Roger and others throughout the meeting, again, analogous to inertial profiling, if I could have the vendors produce an export where I could then manipulate that remotely when errors are made by the field technician, I think that would be an extraordinary help. And it would kind of break the connection between, the tablet and the ability to produce that information. So I'm very excited, and I think I'd have to talk to the owner, but I doubt he would be upset if someone called and said, "Hey, we want to have you guys come out and help us with this, for a reasonable fee." I think that would be great. Yeah, I think in different regions of the country, you've obviously got Fiore over here and others who are also involved. If you could develop kind of regional centers and maybe a centralized or a common set of materials that these regions could train from, so everyone's doing things in a uniform way, I think that would be very helpful. But maybe we're putting the cart before the horse. If these standards aren't finalized yet, things are changing. We have to recognize that too.
I think I'm going to pick up where you dropped off, and I believe it's going to come down to economics. And it's also going to come down to what goals are being set by the agency that wants to see the data. And I think back to when everybody was pushing a California profilograph And at that time, roughly, depending what part of the country you are, it's half consultants, half contractors that had their own California profiler graph. In Wisconsin, we went through a transition of very close calls where people almost killed, pushing the profile graph that we looked into using either a gator, realized that we paid at a much quicker rate from the concrete industry, and we went right to the high-speed profiler graph. And for approximately 18 months, having the only high-speed profiler in the state, and having numerous trials with different regions, getting hired by different contractors, and riding with, I think at one point I'd ridden with every materials engineer in Wisconsin in the high-speed propylograph truck. You know, they want to know, well, how are you going to cheat me? Here's the data. You show me, you know, how are you going to manipulate it? But the fact is that within 2 years, instead of just one high-speed propylograph truck in the state, there was 5. By the year after that, anybody that had any sizable construction company had their own high-speed propylograph. And by this time, the state had their own high-speed propylograph. Now over in Michigan, they started off with that model, and then they decided to go with the consultant route because their one truck couldn't keep up with the projects in the state. They wanted to hire consultants. It should have been a nice gig, but you were on a 24/7 call. Yeah. And besides, but birthday week. So I think the other thing that happened during this time period is that as governors changed and the secretaries of transportation changed in Wisconsin, the staffing of district and regional agency labs became an issue. And having enough technicians to do any testing on projects became an issue. So there, the economic decision that the Wisconsin DOT made was that, you know, in a region that felt that they were short of materials, they would hire consultants to run their projects. And so I think that is what we're going to see with DPS is that the contractors that want to stay at the top of the game, and I dare say that we heard from Forrest, Granite Construction, we heard from Matt, from Matthew, companies like that, they're going to want to control the direction that they're going. For other companies that don't want to take a walk on the well side, I can think of somebody was trying to recruit for a workshop that you hear about later. Was on the, well, it's a not a proven technology. I have a hard time going to my owner and say, you know, I want to buy $100,000 worth of the equipment. And oh, by the way, I'm going to have to hire at least, well, to be realistic, I'm going to have to hire one person. And he's holding up 2 fingers. Yeah, I need this many people, boss. You know, I'm going to ask for this much money. And so it's going to come down to an economic issue on the contractor side as well as the agency side of whether we're going to have to get a lot more riches out there taking data or the company does it itself. And I think that's where we are.
Yeah, no, that's really good insight. One thing, say your name before you speak because the people online can't really see the discussion with the video. So that was Irv. So give him all the praise or whatever you want to give him for those comments.
Irv Duquette, curmudgeon and training.
There you go. And it was Rich Hamilton speaking earlier.
Somewhat retired.
Yeah.
Kyle, I raised my hand and to talk about the economic benefits, right? That's when we do the demonstrations with the MATC, the number one question I get from the contractors is, what's the economical benefit of me using this equipment? And usually we say NDE, any type of NDE is more economical, right? But we have no data to back that off. So we do need some life cycle cost analysis to show that maybe in the long run it is more economical, but we generally talk about that, you know, the benefits of it being cheaper in quotation marks. And so that is something we might want to look into, and that is LCCA, not LCA, yeah, to look at the economical benefit. And that is the number one question I get from all those site visits we did with the MATC in 2022. That was the first question I would get. How much is one of these? Or what, you know, why would I want to change my $3,000 nuclear gauge for a 30,000 or 60,000 piece of equipment? What's the benefit to me? And that was the number one question I would get all the time. And this is Monica Jurado.
Okay, thank you, Monica. Do we need to separate that between feedback you're getting from agencies versus feedback you're getting from contractors? Or how would you
So
assess?
that's a question I get from contractors, because most of the demos we've done, but I also get it from agencies. So it comes from everybody. That's the number one question I get, you know, in general from both. Even some of the academia that's present at some of these workshops and showcases, that's the question they ask.
Okay, yeah, because the reason I ask is, I mean, I think we have a lot of big-hearted contractors out there, but I don't know if Bryce or, you know, anybody who can speak on the contractor feedback. My understanding, it's a little bit more, what's my financial incentive to do this, this project right now? And the life cycle cost analysis would be more agency trying to say, why do I want my program to invest in this type of technology? Is it going to make my pavements last longer? So I don't know if Bryce or anybody else wants to comment on if I'm off base with that, or what do you think?
Contractors want to know their payback.
I think to just what Bryce just said, I think you described it very well, is that it goes back again to economics, and the incentive for the contractor, for the most part, is how much money am I going to be able to make this? I stay in business by making money. When we get into life cycle cost analysis, that's more of a system analysis, and how much money are we going to save for the state?
Yeah.
Or the federal government. Now, I think over time, there has been a very slow change, and through the guidance of NAPA and some of the other contracting organizations, that some contractors are taking the long view that say that, well, yeah, I want to do things that are going to make me money, but on the other hand, too, I want the agencies to keep buying my product. So what can I work with the agency on to make the product better? And build up some goodwill to keep the industry moving forward. And then the more efficient the industry is, and the better you build the pavements, then the more money comes out of the state. Then as we move, instead of building new pavements, then we move into maintenance construction. You know, so it's just how's the money being spent? You know, is it best spent on all new construction because roads have been mistreated and just completely died, or is it better to start a new model of pavement life, of remedial overlays and remedial treatments, and we have sustainable pavements?
Go ahead,
Jacob. Is there anything, Bryce, do you want to add to that?
No, it's a low bid. I mean, they're going to take the low bid, and whether, I think you got to set parameters on there. with whoever, if it's a consultant or if they're doing it, or whoever the low bid is has to have some kind of certification or something to, you know, the whole, with New York doing certifications and classes or having some minimum, all the other technologies, I guess I don't know how Minnesota is, but like in North Dakota, if you're running intelligent compaction, you have to have an IC manager to manage the data. You have to have somebody, and if you don't, you have to hire Trimble or TopCon or somebody to be there for a 10-hour training. So, I mean, it's just the nature of the industry. It's competitive bid. If I've been work for 7 years, if I would have took the higher bid to you know, out of these three contractors in a low bidding situation, and I wouldn't have got the project, I would have been fired. So contractors are going to take the low bid. I mean, they have to get the work to be successful. And I mean, it's just the nature of this industry. So.
Jacob Walker, Georgia DOT. But I guess I would think from an agency perspective, talking about, I guess, economics of it, and then just the cost benefit analysis. I think we all agree knowing consistency of the math is important. You know, but actually, you know, how does that translate into better roadway down the road? How many more years can you get out of it? You know, I think that's that would seem like a pretty big deal, especially when you're looking to change your program. I mean, I'm thinking state is, I think we all have staffing issues, private and public. And people are wanting to telework more, so I don't know that people want to be working at nights all the night and that kind of thing. Single project. And I know, just for instance, with Georgia, we hire a lot of consultants for a lot of our testing. So but a consultant might be running to multiple projects in one night, roadway and at the asphalt labs. So when you implement this, I mean, they're still going to have to be going to the plants, but then if they're having to be out on the roadway too, I mean, you're going to have to hire more people, more equipment. Especially if you try to go to upper management, I would think with any kind of DOT, you need to have something to really show them, like, what's the benefit of this, you know, especially for a big change, and especially if there's any kind of pushback from the industry in that state. I think that'd be important. But then I think also we talked about, I know it was brought up several times about maybe getting away from where it's a push part or it's mounted on something. I think that can actually help with that. So that where, especially if you can do it at the same time you're doing your smoothness or something like that, I think that can help with, certainly help with the costs.
I think this Earth Gas consultant again. I think the economic component, and going back to smoothness again, is that one of the things that led to the widespread use of the high-speed profilers is agencies, the Frozen Five, Minnesota, Michigan, Wisconsin, Iowa, Illinois, decided that smoothness was something worth paying for. And they put in quite generous bonuses if you got smoothness. And it was a scheduled or a equation bonus. So if you were a little bit good, you got a little bit of a bonus. But as you got better and better, the bonuses got bigger and bigger. Likewise, per FHWA protocol, if you were bad, you got a disincentive. Didn't take long to figure out that if you did a little bit of effort, you could make a lot of money making the road smooth. And then the game became, how much smoothness can I get and get that bonus? And then how much density I can get and still get that bonus. And where the DPS is an interesting twist on this scenario of how best to make lots of money without a whole lot of extra effort is, well, you're already getting density bonuses. Now, can I make a bigger density bonus with the DPS? And so that's where the specifications come in percent coverage and some of the things that we're covering with some of the other IC technologies. So I think it's the carrot versus the stick. And I think it's been proven across the country that carrots work much better than sticks. Lettuce works even better.
I guess one thing that got the wheels turning for me is I love the example of contractors want to get paid more by achieving better smoothness, and that's what we want. We want contractors to get paid more for building pavements with better density. For us to pay based on density, based on DPS results, requires a lot of check boxes that are difficult to check prior to getting it out there time after time after time, getting the data and collecting the data, analyzing the data, exposing it to whoever's going to be collecting the data, analyzing it for different mix types. So all these different things that I consider stepping stones to getting the check marks we need to use it as an acceptance tool are also the best carrot to give for why you should, use this device. So that's where I'm kind of struggling with right now is how do we get to the point where we're using DPS for acceptance? And to me, that requires still collecting a lot of data. So for Monica's question, which I think was good to bring up, is life cycle cost analysis. That's, I think, an easy sell is saying density is one of the biggest factors to the pavement lasting longer. If we increase our density by, 1%, all the numbers, 15% longer life, whatever it is, if it's below 92%, that's one way to do it, but that's hypothetical right now. Or alternatively, is it enough to say, these are some case studies, these are some examples like our last DPS digest, where the data that we collected with DPS was used to make a process change that's going to translate to longer life, which is less quantitative. It's more telling a story of having this information available helps us build longer lasting pavements, or, so I don't know if that's like a mentee poll. You talked about putting together, you're muted, Brian, but that's one thing we can do while we're here is try to kind of prioritize and poll, what do you think the most effective way to answer Monica's question, which is why is this economically viable, as a group, maybe figuring out some key ways that we can message when people ask that question that Monica was talking about getting asked, go ahead.
So I thought about that a lot too, and particularly, I think oftentimes for any new technologies. Oh, Rob Inman, Highway. We, industry, generically, collectively, all of us, we do a really good job of stating the benefits for a DOT with new technologies, but we don't do a very good job of the benefits for contractors, right? It's kind of like, hey, the DOT has to do this, and all right, guys, go do it. Otherwise, we're going to penalize you. We'll offer you an incentive too, but first, it's there's a lot of risk on the contractor. The risk is high contractor to do. And so I think one of the benefits that is helpful is, again, highlighting the equipment loan program with Monica's team, right? So then it minimizes the risk of purchasing it. You still have to learn it, but then also state DOTs being willing to pay for quality control aspects using it, right? And not necessarily bonuses, right? Not incentives or anything, but just being willing to utilize it on a project just because we know you know, and it can be a proportional spec for how much it's used based on, you know, it's paid and what they're paid. But then it minimizes contractor risk. It minimizes their risk. And you can have those discussions with them like, look, one of the things I think sometimes is very eye-opening. If you analyze a lot of pavement density data, what is the mean and standard deviation for thousands of data points across your state DOT? And if you look at it statistically, if you're looking at it from a percent within limits and a bonus and a disincentive, incentive and a disincentive, just probabilistic, statistically, where are you at? And sometimes contractors, paving contractors, producers think they're in one location. In reality, they might be in a very different location. And they've gotten lucky. And if they looked, and particularly if their state doesn't use statistical acceptance, they just don't see it. And so they're assuming higher risk than they don't realize they're assuming higher risk. And the state is too, but particularly the contractors assuming higher risk. So you can have those conversations with them about the risk and the payoffs of like, hey, yeah, you can then see increased potential incentives for density. But there also might be other incentives in operational, right? Are you stacking up trucks too much and you just, you know, they're backing up, so they're getting cold? Is there some other operational thing that you can improve? There are soft bonuses, and same with the DOT, where not just a longer service life, but you might see reduced maintenance costs. I would hope you see reduced maintenance costs, right? And so I think oftentimes there's a lot more benefit, but they're harder to measure. How do you measure something? Oh, I helped reduce the potential for this happening by X percent, right? Well, that didn't actually cost me anything. It just reduced risk or reduced the potential of something happening. But it's really, it's real. It's just maybe more of like a black swan event statistically, right? It just, and it's hard to quantify things that potentially reduce costs, even though they're not instantaneous costs.
Gotcha, Di.
Yeah, just one thing to add to Kyle's. Just one thing to add to Kyle's comments in terms of the cost benefit for the DPS. I think the DPS not only measures the density, we measure the density, but also the uniformity too. Yes, actually uniformity. Yeah. So how that's going to affect the payment line for performance. I mean, that's another aspect I think we need to consider in the cost benefit analysis.
Bryce Warrior Consulting. Would it be a good idea to involve like the AGC or someone that represents contractors to get involved in any of this to spark some more? I mean, you got Maffey and you got Granite, some of the most high profile contractors out there that just started using this technology. And I guarantee you there's maybe 5% of the construction asphalt paving industry that even knows really what this tool is and how it works. I don't know if there's a way we can spark more interest or bring knowledge to them. You know, I try to do it myself, but I'm one person. You know, and once people find out how it's used as a contractor and that it exists, it's eye-opening, really, especially on PWL projects. And I think there needs to be some of that brought out into that industry, like, hey, this exists, this tool can help you, and this is how. The APA is not AGC. American State GC? No, the state pavement associations rather than AGC. Or yeah, whoever, just someone that represents contractors or can write something for them.
So involving more of the kind of MAPA and those kind of organizations.
Brian Diefender for Virginia DOT. I like a lot of the comments that I'm hearing, but to me, there are some fundamental questions that we mentioned yesterday that haven't been addressed yet, that I think need to be addressed before some of these other things are. One being how much coverage is needed, how much the data density that we need. Those kind of things, I think as we start to answer those, be able to get a better idea of how to implement the system, following on with the Joe talked about. How many specimens do we need for the calibration? How many, those kind of things. Some of the things, lab related work, I think can be short term, maybe the next year or two. In that time, we can start to address maybe how to implement the system with vehicle based. I see positives and negatives to that. If it's vehicle based, are we going to be able to get the entire lane width? We need to get the entire. Again, going back to the original question. If it's something that's roller based, then we can probably cover the entire lane width, or whatever the area is that the roller actually covers. Hopefully it's the entire. But whatever the area the roller covers, it's adding a piece of equipment, but it's already there in place. It's not something that has to happen later. So I think maybe some discussion has to be needed to talk about this trade-off and what are the positives and negatives of each one of this. Again, this idea of the calibration side and all that stuff. I think some of those things need to be addressed first.
Anything else to add on these subjects?
I've been hearing that IC and PMTP easy sale because they are mounted on the existing paving equipment. It's not. Okay, I've been selling IC since 2007. Now less than 0.1% of roller have IC in the US. So selling any innovative technology is all very difficult. I always been asked the same question at Monica when I promoting IC and PMTP. What's the life cycle cost? What the benefit? What's the ROI? It's the same question for selling any innovation technology, except that IC PMTP had not been really used for industry before, but density measurement had been done using conventional coring. Now you're replacing with fully coverage technology. That's a totally different ballgame. It's not just replacing existing equipment, but using an innovative fully coverage technology. And that require exactly the same battle we have for promoting IC and PMTP technology. Is the technology mature enough? Can you provide equipment for the industry? How can we train people to use it? How can we get DOT agency to buy in to specify it? Minda is a great example to pull it off. Is going through the same process.
Hi, this is Fabricio Leiva. I wanted to follow up on that topic, and basically, going back to other products. Like I've been involved lately with fibers and cycloplastics, and what producers of these materials tend to do is they go first to DOTs. They try to get those materials approved, at least be part of the list of qualified materials that they can accept. And then you start the process of having those products being in a special provision or at least a shadow project and things like that. So I think that the approach that they try to follow is go first to the DOT, have some exactly have some type of acceptance at the DOT level, and from there you can start going to contractors and other people. Yes, the agency has at least give us the thumbs up. We don't know if it's going to be a project in the near future, but at least someone already is interested in the product. And I think we started in a good way with Mindo leading the process. There are several agencies already, leading the efforts. But I think we need to get more and more agencies, not only going through this and accepting the technology. Not only this, I agree with IC and thermal imaging. There are a few that they don't believe in that, right? So if they don't do it, why the contractor has to do it? So I think that's part of going first to the decision making people, and then little by little approaching other levels and other sectors of the industry. Thanks.
Okay, we're gonna switch gears just a little bit. So Irv is running a workshop at TRB, and I think it fits kind of in with what we're trying to do right now, which is answer critical questions. And I think before I give it to Irv, I just wanted to mention, you know, especially for states, because I think, you know, some of Fabricio's comments and a lot of people, it's initiated by states wanting it and states being able to sell it to their leadership. And so I just, when we go through all these questions, you know, if you're a state and you're thinking about this, you know, what are the barriers right now for you towards continuing to invest in DPS? And that's something we can look at from a perspective of how can we get it packaged in the end result for our work plan that we're currently on for December next year, but then also what we're potentially going to be proposing at the end of next year is basically what are our current barriers when people ask you, why are we investing? Why are we interested in DPS? And let's try to get those out in the open too. So, but here's our.
Thank you, Kyle. And I'm breaking in now because my computer's dying and Kyle's got the only receptacle down here. But the elevator talk is that this workshop, which is going to be on Thursday morning of TRB week from 8 until noon, is a workshop that contractors will get the feedback on how to improve their paving operations and increase profits with DPS and PMPT, paver mounted thermal profiling. For the state DOTs, the takeaways will be the tools for them to sell the use of these technologies for quality control, both today and into the future. Now, how are we going to do that? We're going to have a number of breakout sessions. The lead-off speaker is going to be Kurt Turgeon of the Minnesota DOT. And then the questions after we have various speakers, some of who you've already heard at this particular meeting, is we're going to ask people to answer questions such as what would be the best use of DPS and PMPT for your agency or company? How would you measure success for your company or agency? And we're expecting hopefully more than 50, but I think Dr. Zeiss had 400 or so at her workshop session on Thursday last year, so we'd like to break that record. The second set of questions will be what data would be needed and how should it be collected for illustrating pavement performance improvement using these technologies? And how could DPS and PMTP help sustainability and safety at your company or agency? What do you need to know to sell DPS or PMTP to your agency or company? Then that's followed up with, how would you actually implement the technology? What are the probable roadblocks? What would be the solutions? And then the final question that the people attending the session will be asked to answer is what are the biggest challenges and risks in using these technologies for acceptance, i.e. payment, for owners, agencies, and contractors. So that'll be coming up in January 2023, Washington, D.C. Be there or be square. Any question? Ask Kyle because he's helping me put it together. Or Adam Hand.
Yeah, are you gonna have a coffee and donut?
Oh, of course. We'll just, Nelson will take care of that. Adam, did I miss anything?
You got it.
Okay.
Is there anything from?
Yeah,
Go ahead,
good
George.
question. I think that's a great workshop. So I think for this is George. For a lot of great PRB workshops, what really, will be variable is turn this into a e-circular.
That's in motion.
Exactly.
All the people that have agreed to speak have agreed to put together written compilations of their presentation. And then we'll be summing up all the answers that the workshop participants come up to the questions. So we'll have the little book of DPS.
There we go. There we go. Yeah. For those who don't know about e-circular, that's the e-publication from TRB workshop that document what happened, what have been discussed, and with a slide and some notes to come with it and conclusions. And that would be a basis for your little book of DPS.
Hey there, Kyle. This is Brian Hurt. I'm going to break back in here if I could. This is the drawback to trying to facilitate from another location with so many big opinions in the room, which is excellent. My thought potentially is to maybe change a little bit of how we were thinking about we might poll the group. And the reason I would want to do that, and I don't want to cut short this discussion, but a lot of what's being discussed are maybe kind of non-parallel ideas, and they involve cost and implementation and marketing and short-term and long-term and things like that. And I think it might be more valuable because hopefully others who are listening and not talking maybe agree with what's being said or would want to chime in on their own. And I think possibly asking a few open-ended questions and having everyone answer, even if they've already spoken, just so we can really document and see, kind of what the temperature in the room is. I've been putting at the bottom of the shared document, and I'll go ahead and put it back on the screen, maybe 3 open-ended Menti questions that we could potentially ask of the group as a way of saying in December of 2022, this is what the people in the room, this is where everyone's heads were. And we could then try to kind of find commonalities based on what people say. So I'm just throwing this up on the screen. And if we could tweak these questions before, I didn't want to just put a Menti up without sharing that, but what are your thoughts potentially as a way to, without overburdening the people in the room and those joining online, to maybe tackle those 3 questions, and it doesn't have to be those 3 questions, but as an approach to trying to sum up what people are thinking.
I think that's a good idea. Let me pose it to the group. Is there a question that you'd like to see polled, or do you agree or like Brian's questions, and we should move forward with one of those things? Suggestions, please.
Can we add, do we want to have a poll for continuing the pool fund group afterwards?
Great idea.
Yeah, asked if you can put one, is there an interest in continuing the pool fund after December 2023? Which I think would involve creating a new pool fund because they're capped.
You have to.
Yep.
Give me a moment to add that question into my Menti poll, and then I will put it up. Thank you.
Okay, is there any other, while Brian's uploading that, is there any other questions that come to mind from the group that they'd like to get input? You didn't know you were going to get homework here at the end of the pool fund. And if you're joining from online, you can also obviously weigh in on the Menti pool, right, Brian?
Absolutely.
Sure.
just so you know, this is how we got our umbrella topics from the technical working groups. So these Menti polls, they work pretty well, I think. So thanks for putting it together on the fly here, Brian.
Sure.
Yeah.
Right.
Okay.
Kyle, is there any project currently or in the past that went fully DPS, like a specification or has been used for acceptance?
So the question is, has there been a project yet where DPS has been used as the sole form of acceptance for density? And the answer to my knowledge is no. Yeah.
So I just, oh, sorry.
Steps.
Yeah.
I hope you can see this on your screen. This should be for anybody who's joining online as well. You could go to menti.com, MENTI.com. I pasted that in the chat as well. There is a 7-digit code to type in. You should have the option to hit a thumbs up to show that you have made it there. You can do this on your computer or your phone. It might be a little easier on your computer since you're going to be typing.
Am I allowed to do more than one vote if I have some people in here without a laptop?
Most.
Oh, yes. Anyone who goes to these questions can type more than one answer. In terms of another thumbs up, it's just, this is mostly so I know that people are finding their way to the poll.
You can use your phone too.
Yes. Yes, you can. It may be a little more cumbersome to type your answers, but we're all used to texting at this point.
Let me know if you're not going there on your phone or your laptop, and then I'll count your vote in with mine. If you're online, you're on your own.
If you're online and you're having trouble, you can also paste your answer into the chat, and we can find our way to getting it into the notes and into the Menti. We have 19 people. This is a talented bunch. Even if we move on to the next slide, you'll be able to still join. That code will remain. We're at 20. I'm gonna make the big move to the first question here. And these are open-ended questions, and you should be able to. So when it says the main barrier, if you feel that there are multiple barriers, unless I set this up wrong, you should be able to type this multiple times. If you've already indicated this in discussion, this is going to be a summative document, or help us and help the pooled fund team really get a sense of what the barriers are. So please do go ahead and type that in now.
Okay, just to be clear, Brian, we're still on the first question. So when we say go to the next question.
If you are done, you can go to the next question, but I don't believe you're going to get it until I put it on the screen.
Okay.
A drawback to Menti is it won't show all the answers at once. I can scroll through these, and I'm doing so as they come in. We will be able to share the complete results with the group. But it looks like responses are still coming in.
And then is there, one, do you think it's valuable? And two, is there the ability to kind of vote on, so I know I submitted two actually. But then after reading some of the others, I think some might be better than what I put out there. Is there a way to vote on these as a group or not?
Potentially. My thinking is that it's going to take a little bit of sorting through these responses to find commonalities. I mean, there's several dozen responses, and there's no way to, in a very short amount of time, to do that.
Yeah, right.
That might be a good follow-up activity, and that might include people who aren't here to say, this is what we're seeing as the barriers at the December meeting. Maybe do a real quick survey monkey with 3 questions to get some voting done afterward.
Okay, yeah, that makes sense.
I am seeing a lot of, I mean, I know I'm kind of scrolling quickly as I attempt to see the different responses. There is some overlap as expected, and it also does really span the wide range from cost, technology, business case, data, everything we've talked about. I'm going to give you my microwave popcorn analogy, right? As the bag is, you're starting to hear the kernels stop popping and you're not quite sure when the bag's about to burn. I'd like to go to that second question at some point. I don't want to cut anyone short there. We'll just give it another couple seconds and then we'll, okay, here we go. So one more kernel popped. Yeah, clearly people are still typing. Kyle, we have 29 responses. I think I'd like to move to the next question.
I agree.
Okay, great. And I expect there should be some overlap between this and the next question, but as this isn't a surprise, you saw this on screen. What's an immediate research need that would enable DPS implementation?
I just really want to say that I appreciate everyone doing homework this late in the day after 2 long days. I see a lot of good ideas going up there.
Well, they found out it was classroom work and not homework, so that's, they get to skip out of the room afterward, so that's good. You have homework, Kyle, when we're done.
Good.
As expected, there's a lot of conceptual overlap between gaps and the research needs, but not identical. And I think this gets at some maybe more specifics about what potentially this group could be doing moving forward.
I think the kernels are done popping, Brian.
All right, let's do it. Before I click over, just a note that this, I do think this next question does change gears a little bit. I wanted to focus on this idea of a current communication gap or need for DPS. So maybe not down the road, but what potentially could the pool fund be putting out now to help get DPS moving along the track towards its ultimate ideal destination of implementation? I'll just comment, this is great seeing, in addition to communication topics, we're also seeing communication channels thrown out there, including workshops, webinars. We talked about the little book. So if that's something that's useful for you to think about as you're answering this question, please do. If there's another channel that's not being used, use this opportunity to make that comment as well. Just saw a note in the chat that Monica has to run. Thank you, Monica.
Haven't seen any pop kernels for a little bit here, Brian.
What I do see is a group of troublemakers in the back of the room. As a former high school teacher, I know we're getting to that time of day. So that's good. I have one last question, and that's the one that we were going to put up last, and that is, and again, this is open to all attendees of this meeting. If there would be an interest in having this pooled fund continue it would be a new phase.
Looks like we're preaching to the choir, right?
I sent the survey so you could only vote yes, so that's how that's going. No, it's that's something. That's great.
I thought about polling the group just by telling them to raise their hand, but this is a little bit more anonymous at least, so. I don't know, this maybe is closer to meeting the Code of Federal Regulations.
Well, there's your straw poll. I'm gonna.
Brian, are you able to tell if the folks online are voting as well? They're just, see how many folks there are.
I can see there are 22 votes or 23 now, and I'm not sure that if everyone 24 in the room voted, I don't think you would have gotten there. So yes, and I got a note from Hoda that indeed people online are voting as I expected they were.
You could tell them that it's an anonymous poll just to see if we get a few no's.
Yep, I got a yes from Jeff also. The number's at 25 now, yes. Nobody voting no, and nobody unsure. Again, not a commitment, but a perspective, which is great to see.
It's at least some motivation to do some homework and put together potential tasks and whatnot if we were able to extend it or do a new one. So appreciate that. And Brian, unless you want to try to, yesterday, I think I was trying to squeeze more juice out of the fruit, the proverbial fruit, but today I think I'm inclined to let people out 10 minutes early unless there's more pressing needs or topics. Yes, Robert.
For just another mentee question, if there's such a big interest in continuing that pool fund group, you want to find out the direction of what that pooled fund group might look like? Like where the focus?
Okay, here's what I think Robert's getting at. Correct me if I'm wrong. This is Kyle Hoy, Minnesota Department of Transportation. Is it worth putting a question up? Future pooled fund focus.
Bueno.
Quality assurance. Only. Quality control only. Quality assurance and. So how would you word your question?
No, you got it. You got it. You can leave it generic even and just see where the focus, and maybe that's what the mentee poll, the other questions will do too, right?
Yeah. All right, Robert, he loves homework, so we're gonna keep going. Do you know how to word that question, Brian?
I'm just trying to grasp if that was really a multiple choice question or if it was an open-ended question.
Open.
He wants it open-ended.
Okay.
So Kyle, next year, you're gonna have another meeting like this, user group meeting.
Yes.
And I'm sure a lot of this will be brought up again. That might be another opportunity to ask a question like that.
Yeah.
That's,
Another year.
Makes sense.
Regardless, we talk, right? So from yesterday to today, we can summarize this, list of something, send it to the group. Middle of next year, we have another group meeting.
Yeah.
So we can
But, yeah, and it certainly seems from implementation is really kind of the, if there's a next pool fund, that's where everyone's looking to go, right? How do we?
Yeah, what happened for this pool fund? What happened for this?
Say your name.
Steve Cooper with Federal Highway. I just remember working with Minnesota when we got this pool fund going. And at the time, Federal Highway was very adamant, every activity had to be research related, right? I'm pretty sure things have changed a little bit where if you had a little bit of implementation in there, the next pool fund, I would hope would be fine with that. So,
Okay.
remember that, Kyle?
Yes. Did you get that, Katie?
Yeah.
So was there still a desire to ask that question as a mentee?
Robert's shaking his head. I would say if you've already got the question up there and people want to answer it, they can, or we can dismiss.
Well, I'm not going to suggest it's premature, but I do think there will be an opportunity to have that discussion down the road a bit.
Okay. Brian just suggested it's premature.
Okay. Let the recording show. All right.
No,
fair enough.
I think these guys deserve at least 6 minutes because you guys have been outstanding. A lot of great discussion in person, and then also a lot of great participation online. So I think I'll let Di adjourn us here, and then we'll go on our merry way.
Well, I just want to thank you, everyone, to devote these 2 days coming here and Minnesota. And it's very productive 2 days. From my perspective, we got a lot of good discussions. I've learned from you guys, and more importantly, we identified some topics, and we'll continue on this topic. I think most states are interested in this technology, and more states are going to follow us to join this pool fund in the future. I truly appreciate your participation, active participation, and promoting this technology. Thank you, everyone. Safe drive back. Not drive, fly back.